Hello everyone, welcome to KMIT Solution Services, a leading IT training academy. If you are a DevOps engineer or who wants to learn Kubernetes from the scratch to advanced level, then this series is designed for you. In this live class series, I will cover Kubernetes step by step with practical and real-time examples, which helps you to understand how things works in the industry. The topics which I'm going to cover are Kubernetes architecture, Kubernetes pod. In the architecture, we will discuss theoretically, and also I will set up a Kubernetes cluster within on premises. On premises means I will take one virtual box and I will set up a complete Kubernetes cluster where I will have one master node and two worker nodes. So it will be totally free of cost. You need not to set up it on AWS or Azure where you need to pay the amount for those services. Next, we will talk about the replication controller and replica set, how the replication works, how the ports are replicated. So that will be discussed in this. Then how to deploy the application with the Kubernetes deployment. Blue-green process canary deployment will also be discussed. Then how to access the application internally, externally, or with the load balancer through the services. Ingress controller is also discussed with Nginx. Daemon set. If you want to deploy your application like a utility, then you use the daemon set. How to map the configuration files, how to manage the secret, that is also discussed. Role-based access control and the Helm charts, Prometheus and Grafana overview, and dashboard will be discussed in this entire series. I'm really very excited to start this series, and I hope if you are a learner for Kubernetes, you are excited too. So then let's not delay and start our lecture one for this. Till then, bye-bye. So today we will start the Kubernetes. Now, what is Kubernetes? If you remember in our last lecture, we have discussed about the Docker Swarm. Right? So Docker Swarm is a container orchestration tool, right, which is for Docker. So we discussed about the Docker Swarm. So Docker Swarm is a container orchestration tool. But for Docker only. So if you are having any other container runtime like Rocket, Runc, so you cannot use Docker Swarm there. So Docker Swarm is only for Docker. Okay, and it is a container orchestration tool which comes with very limited features. But if you are having a small project or medium level of project where you don't need too many features for container orchestration point of view. For example, you are creating a project and you deploy your application as a container application and you want replication. You want maybe you want the replication, you want something which is some other features like run the containers only on the worker node, scale out, scale in. So those things which we have discussed in last lecture. So if you are having limited features for your container orchestration, then you can go with the Docker Swarm. But the features are not limited in Kubernetes. So Kubernetes is also a container orchestration tool. So next is the Kubernetes. So okay, this color is not good.
So have you shared your screen? I'm not able to see you.
You are not able to see? Oh, sorry. Can you see now?
Yes.
Okay, so Docker Swarm is a container orchestration tool, but it is only for the Docker. It is not used for the any other container runtime. Now, the when the when we are talking about the Kubernetes, so Kubernetes is also a container orchestration tool. So uh, this color. So Kubernetes. So Kubernetes. So Kubernetes is also container orchestration tool. Right? Now, question arises that if there is a Docker Swarm, why we need the Kubernetes? That gradually you will understand when we proceed to the Kubernetes these sessions. Then you will understand that Kubernetes is something which is having lot and lot of features. Docker Swarm is tiny in front of that Kubernetes in terms of features. So Kubernetes is having a lot of features, and it can support different container runtimes also. So Kubernetes is something which is a complete container orchestration tool. Now, when we are saying container orchestration tool, what is this container orchestration tool? So see, consider you are having one container. Okay, you are having one container. If you don't have that container orchestration in place, then what will happen? Someone has to manually monitor these containers. Okay, that is one of the feature which I'm talking about, the container orchestration. Consider you want no manual intervention. It should be automatically. It should be automatically um, started up or automatically scale out, automatically scale down, automatically, uh, you know, uh, means if it is having some problem, then automatically heal out. So those things happens through the container orchestration tool, right? So Kubernetes, Docker Swarm, these are the container orchestration tool. But if we compare Docker Swarm and the Kubernetes, so our choice should be Kubernetes, because Kubernetes supports all type of projects, whether it is small, whether it is big, medium level, right? So for example, you are creating a very simple container which is supporting hello world kind of application. You are creating one hello world kind of means very simple application, or you are going to create any enterprise level applications. So in all those cases, you can uh, you can use the Kubernetes. So very Kubernetes is having a lot of advantages. And if we talk about Google, if we talk about Microsoft, if we talk about ChatGPT, if we are talking about Facebook, Most of their applications are running as a container, and these are maintained or orchestrated by Kubernetes. So Kubernetes is one of the very powerful tool which is having a lot of features, maintains your applications, your Amazon Web Services, Amazon e-commerce websites. So all those are running with the help of containerization only and managed by the Kubernetes, right? So you can understand that Kubernetes is very much required for a DevOps engineer. Okay, so if you go for any interview, it is I don't think if it is related to the DevOps, right? So interviewer definitely asks the questions related to the Kubernetes and Docker, especially. So these are two main tools where DevOps engineer almost working on day-to-day activities. Okay. So now Kubernetes has a short form. We can write K8S. Okay. So this is the short form. Kubernetes is open source. Kubernetes and Docker both are developed in uh, Go programming language. Okay. So Kubernetes and Docker, the programming language which is used is Go programming language. So um,
So what does state represent here?
K8S is the short form of the Kubernetes. How it is actually Kubernetes is total 10-letter word. First letter is K, last letter is S, and total letters in between 8. So
Oh,
K8S. Okay. So this is K8S. Now, uh, let us see our, so Kubernetes, one more thing that Kubernetes works on a cluster. Okay. Kubernetes always works on a cluster. Who has created Kubernetes? It is created by Google. Okay. Google has created this. So Google was working on a project called Borg, and they have done 10 years testing for Kubernetes. After that, they they bring it into the market. So this is very powerful tool. Consider that Google has tested for 10 years and then it came into the market. So so it is definitely a tool which is very mature tool. And you know, if you are working as a DevOps engineer, then probably you will be dealing with the Docker and Kubernetes also. So Kubernetes, first of all, it is open source. Okay. And Google has developed this. And now Google is also, it's not only maintained by Google now. Now it's a open source. So CF is an organization, those who are basically taking care of Kubernetes related stuff. But contributors are Google, Microsoft, and there are many other companies. Okay, so we'll see that those which are those companies. Now Kubernetes always works on a cluster. So when we talk about a cluster, so cluster should have one master node and the worker node. So today's lecture will be a theoretical lecture because uh, first I want to make a base that what is Kubernetes. Once you understand a big picture of that, then tomorrow's lecture we will talk about the Kubernetes. And what I will do offline, I will share you some steps because installation takes a lot of time, especially when we install it on our own premises. If it is cluster which is on Azure AKS cluster or AWS EKS cluster, those are already configured, but we will create the cluster on our local machine. So what I will do, I will make one video, okay, and I will put it on with the steps as our next lecture. So you just follow that lecture and you can install the Kubernetes on your machine also. There is one thing which is called mini cube also, which is, you know, in that case on your machine itself, if you want to do the development only, you can use the mini cube also. But I will show you that how to create the Kubernetes by using kubeadm.
Okay.
All right. So now when we talk about the cluster, so in cluster, basically what happens that you are having consider this is my first machine and this machine is my master machine. Master machine, we also call it control plane. Okay. So that if someone says control plane, it means master, and node means machine. Okay. It could be virtual machine. It could be physical machine, bare metal, anything. And there will be some set of worker nodes. It could be, there could be 0 or more than 0 worker node. Means worker node can be 1, 2, 300, no worker node. But master node is mandatory. Master node is required. First of all, these machines, consider we are having these 3 machines, right? So these 3 machines should be in the network, normal, without, means if we have not installed Kubernetes so far. So these machines should be in the networks so they can communicate to each other, right? Now, uh, right. Now they need to communicate to each other, right? So this is your master node. These are worker nodes. So what are the worker nodes? Worker nodes are those machines where actually containers will be created. Okay, master node is the instructor. He will say, okay, create the container. So the container will be created on worker node. Okay, any request which comes to the Kubernetes cluster, it will come to the master node only, and we will run all the commands mostly on the master node only. So master node is the machine where all the request comes. It means your commands will be executed on the master node, and master node will create the containers on the worker node. So you can have 1 worker node, 2 worker node, 3 worker node, 4. It depends that how big is your project, right? You can have multiple master nodes also. Consider this is one master node and you think that there are a lot of requests comes simultaneously. So you can create one more master node, right? And master node components are, means master node includes all the components which are related to master related activities, right? So it is not only having the component of worker node, it has the component of worker node plus it has some extra component which we will discuss in our architecture. Today itself we will discuss, right? So whenever you are basically, uh, whenever you are, uh, right? So whenever you are having multiple master node, right? So the main purpose is that to distribute the traffic. Okay, that is the main purpose of that one, right? Now, so master node configuration as compared to the worker node configuration will be little bit more. Means, for example, we will discuss that also, that what will be the master node configuration. Okay, but as compared to the worker node, because worker node has to create the container, run the container. Other components, which is master node, is because master node is also maintaining a database that how many worker nodes I have. So entire cluster information is on the master node. So master node should be a advanced level of machine where you are having, RAM accordingly, CPU accordingly. So Kubernetes, when you install Kubernetes, especially for master node, you need minimum, means if you want to create on a beginner level, you need minimum 4 GB RAM, minimum you need 2 CPU. Okay, so That is basically the minimum requirement. For worker node, these are simple machine. If you are having 1 GB RAM and 1 CPU, that also work. Okay, because they just need to follow the instruction which is sent by the master node. Right. So now they are in a network. Then what will happen when you install Kubernetes? There is one more network get created, one more network layer. This is called pod network layer. Now, what is pod? Right. So when we are saying pod, so pod is a atomic or basic unit of Kubernetes. What does it mean? See, when we are talking about Docker, so Docker having the basic unit as container. So when we were talking about the um, Docker, we were always talking about container, replicate the container, attach the volume to the container, right? Networking of the container. So we are always talking. So container is the basic unit or the atomic unit of the Docker. Same way, pod is the basic or the atomic unit for the Kubernetes. So pod is you can say it's a wrapper around the container. So you have a container, for example, Nginx container you are running, which is running at port number 80. So around that, there is one more wrapper, which is called pod. Or you can say a container is inside a pod. Okay, a container is inside a pod. So if you want to access the container, you need to access via pod only. If you want to delete a container, you will ask pod, hey, can you delete this container? If you want to, something which is related to the container, you are not directly interacting with the container. You are going via pod only. Understood what is pod? Pod is a wrapper around the container. So benefit is that, uh, see, if you want to apply the security on the container level. So there are two levels of security I can provide. That is one advantage, like I can provide the security on the pod level. I can provide the security on the container level, right? So that I can do. Another advantage is this is when single pod is having single container, right? When a single pod is having single container, that is called single container pod. Single container pod. Okay. If there may be possibility that a single pod can have multiple containers inside it, and there are some design patterns. So this is my container 1, this is my container 2, and both are residing inside a single pod, right? So this is called the multi-container pod. So one pod is having multiple multi-container pod, right? Now the benefit is that consider there are some design patterns, sidecar pattern, ambassador pattern, and there is some other patterns which we use for the Kubernetes multi-container pod. Okay, that we will discuss once we get familiar with the Kubernetes concepts. But you can create multiple containers in a single pod. That also we can do, right? Now, uh, let me take one example of multi-container pod. Consider you are having one web application which is running as a container. This web application is generating some file, right? And this file is to be shipped to some database or some cloud-based system. For that, you have created one more container, which is the shipper container, for example. Okay, so there is two containers. web container, which is after executing some script, it is creating a file, and that file is to be. Now you need to have this one operation, right? This entire is one operation. So what you will do, you will create a single pod, and in that pod you can have two containers, like here I have mentioned, one for web and second is for the shipper. Now if you do a replication, you need both the containers. So it means we will do the replication on the pod level. Okay, replication is on the pod level. So then another pod will be created which will have two containers. Right? So that is why pod is our basic unit. I hope you are understanding. If you have any question, you can interrupt me anytime.
Sure, sir.
Understood? Okay. Now, the IP address is basically assigned on the pod level. If you want to access your application, okay, let me just show you that one. So now these pods, right? So uh, these pods are created on the pod network layer. So now on top of my network, right, or on top of this network, right? So I have considered this is my pod, okay, and pod is having a container. This is considered my web pod, where application is running as a pod, and inside that there is a container which is running at port number 80. Consider I have one more pod, okay, which are having multi-container pod, right, which is running at port number 80 and port number say 8080, right? And this pod is also running on top of this pod network. So how this pod network is uh, how this pod network is installed? So there are some native tools are there, means Kubernetes is having its native tools. With the help of that, we can have the uh, right. So with the help of that, we can install the pod network. But there are some third party. So right. So uh, right. So there are some third party tools are also available, or plugins are available. Calico, Flannel, and Weave Network. Right. So these are some network companies. Calico, okay, Calico, Flannel, Weave Network, and there are many. But these are the one which are used. These are the one which are basically mostly or commonly used for the Kubernetes pod network. So the purpose of the pod network is that when you create the pods in the Kubernetes, so they get created on the pod network, not on your host cluster or host network, right? So this will have its own networking, right? Yeah, this is your domain level networking, but on top of it is not getting created on top of this. Ultimately, the containers or the pods will be created on these machines, but they are maintained on this particular pod network. Now, every pod, when we are talking about these pod, right? So um, every pod is having the IP address. Okay, every pod is having the IP address, and uh, you can define a pod network which with a CIDR range. For example, if my pod network is 192.168.0.0/16. So in this case, my right. So in this case, this is my CIDR range. Now, if a pod get created, it should be created within this IP address range. For example, we can create the static pods, but that static pods concept is different. But static pods or dynamic pods, whatever we are creating, so they must have the IP address range uh, within this CIDR range, which we define when we create the master node or cluster, right? So this is, for example, this pod is having the IP address 192.168.0.12. Okay, so this is in this CIDR range. Same way, we consider this is having the IP address 192.168.0.13, right? And this is under this range. Right. So now this is the container. How I can access this container? To access this container, I need the IP address. Okay. To access this container, I need the IP address. Now, to access container, I need the IP address, which is web pod IP address colon container port number. For example, I want to access this this container. To access this, I will use 192.168.0.12 colon 80. Okay. And consider I want to access this pod. And there are two containers. To access these containers, 192.168.0.13 colon 80. And if I want to access this container, so this is for this container 8080. So I will say 192.168.0.13.8080. Do you understand this?
Yes, sir.
Hmm? See this this how Kubernetes works in a cluster, how we can access the application. So these are the fundamental. Um, until unless you are not clear about the fundamental, then what will happen? It will be difficult for me to explain the advanced concept. So these fundamentals should be very much clear. Now there is one more thing. If these two ports, they can communicate to each other. Okay, these two ports, they can communicate to each other. But this is my multi-container port because there are multiple containers. Now, if there is a multiple containers, so containers, these two containers, they are local host to each other. Local host to each other. What does it mean? It means, for example, I'm running one application here. I'm running another application. It is in a single pod. Then if this wants to access this, then they need not to mention this IP address. They simply say local host because they are local host to each other. If this container wants this application, then it needs the pod IP address. But here, pod IP address is not required. Okay, so this is how logically the pods communicate to each other. Okay, so this is how the pods communicate to each other. Now let me go to my documentation. So I'll go here. This is the logo of Kubernetes. See, logo of the Kubernetes is also very interesting. you have seen something like this.
In boat, sailor boat.
Yeah, exactly. So in the bot, you see this is the wheel steering, right? So it is similar to that because it is also managing the entire ship, right? And this is the one uh, Kubernetes, right? See, it is same. So Kubernetes logo is interesting, right? Now, Kubernetes is open source for automating the deployment, scaling, and management of the applications. Now, you can give the containers to your Kubernetes, and Kubernetes manage it on certain machine or node. Right? Now, this is what I was explaining to you, right? This is a master node, worker node, and any request which comes, it comes to the master node, and it will be creating the containers on the worker node. Or now you need to say create the pod, and pod get created on top of the pod network layer, and this pod network layer can be created with the help of the pod network plugins like Calico, Flannel, Weave Network, right? And there is a CIDR range. Now these are the containers: single container, multi-container, and multi-containers are local host to each other. Right? And this is what I have, whatever I have mentioned, I have written here. Now, once upon a time, Docker and Kubernetes, they are best friend. And uh, which is basically uh, before I think 2021. Before that, default container runtime for the Kubernetes was Docker. Okay, so see, Kubernetes needs to create a container. So it means container runtime is required, container software is required. So it was using Docker. So if you install the Kubernetes, you need to install Docker first. But now that thing is changed. Okay. Now, why it is changed? Why there is a breakup between Kubernetes and Docker? It's not a kind of thing which Kubernetes wants that, but there are some complexity, and that complexity is because of the extra layer which is called Docker shim. So there was a news: Kubernetes stop supporting Docker. Okay, so companies were in panicking state. They were saying that, oh, why this Kubernetes is stop supporting Docker? Our containers are in Docker only. So then there is one article: do not panic, Kubernetes uh, and Docker. So this is the blog. You need not to. So what is that? Kubernetes support for Docker via Docker shim is now removed. So they are saying we removed the support of Docker via Docker, means Docker shim part is removed. So Kubernetes is deprecating Docker as a container runtime after V120. Now it is 30 point something latest version. So what it is saying, Docker is underlying runtime is being deprecated in favor of the runtimes that use container runtime interface. What is container runtime interface? Which is called CRI. So CRI is how Kubernetes, for example, you need to create a container. So Kubernetes will not create the container. Kubernetes is having one CRI, which is the container runtime interface. That CRI is Docker, Containerd, Cario, right? So those runtime creates the container. So it will say, it is something like that. Your managers or your, maybe your ADM or someone, what they are saying, hey, can you develop this? Uh, can you develop this product or this project? So when you are developing, right? So you are developing. So you are container, and you are reporting to your manager, and your manager is saying, hey, can you work on this? So it means now today it is Mikhail, tomorrow it will be Raman, third day after tomorrow there will be someone else on the same project. So for Kubernetes it is like that. Earlier it was Docker, CRI, container runtime interface for the Kubernetes, which is asking Docker to work on this. As a container means create the containers, stop the container, whatever, right? So now it is Containerd. Okay, now the default container runtime which is used is Containerd. So Docker as an underlying runtime being deprecated, now it is removed in favor of runtimes that uses the CRI created for the Kubernetes. Docker produce the images will continue to work. So Docker has a monopoly. Docker has a monopoly for creating the Docker images. Whatever container runtime you are using the Docker images only. Okay, so Docker images when you are using container runtime as Containerd in Kubernetes, which will create the containers, right? Uh, so under that the Docker images, it will be Docker images. It will be used. I mean, Docker images will be used. Okay, so that is continue for all the runtimes, all container runtimes. Now, if you are an end user for Kubernetes, note a whole lot will be changing for you. This does not mean the death of Docker, and it does not mean you can't or you should not use the Docker as a development tool anymore. So this is deprecated for Docker shim is deprecated, which is one extra layer, right? It is deprecated for Kubernetes point of view, right? It doesn't mean that you will stop learning Docker, you stop using Docker. It is not like that. So we are still using the Docker containers, Docker Swarm, Docker Compose, right? So Docker images and Docker images are we need to create by using Docker file in our CI/CD pipeline. Also, we need to create the Docker images, custom Docker images. So that will be continued, right? So it doesn't mean that Docker is gone. If you are using managed Kubernetes, see if you are using AWS, then EKS cluster, AKS or GKE, AKS for Azure and GKE is for Google Cloud. You will need to make sure that worker nodes are using a supported container runtime before Docker's support is removed in future version of the Kubernetes. Right now, these days we are using the Containerd because Containerd is supported by the Kubernetes, and this is the default container runtime. So it is saying that whenever you are creating a cluster on AWS or Azure, right? So you need to make sure that whatever the container runtime you are using, don't use Docker now, use Containerd or mostly Containerd we use, right? That should be supported, right? So that is the one. So, um, so we are talking about two different environments here. So inside the Kubernetes cluster, there is a thing called container runtime that starts responsible for pulling and running the container images. Docker is a popular choice that runtime, right? So So now the choice is containerd or Carrier. But Docker was not designed to embed it inside the Kubernetes, and that caused a problem. Okay, so I hope you understand that is Docker is important, but it's not a choice for the Kubernetes now. I'll tell you one example. See, Kubernetes is having a networking concept. Docker is also having networking concept. Kubernetes also have the volume concept, persistent volume, non-persistent volume. Container means Docker is also having those concepts. So now Kubernetes says that why I need those networking drivers to be loaded, or the volume drivers are to be loaded when I create any container, or when I use Docker. So those are Docker shim. So that is why unnecessarily it was a burden on the Kubernetes cluster. So those problems we don't see in other container runtimes. Okay, so that is why containerd is very lightweight. Even the Docker is also using the container uh, D. So in the Docker itself, we are having container D included, right? So uh, that is why, right, this Docker support was removed, or container runtime default container. You can add Docker also, but it is not recommended now, right? So it is removed after v1.24. Okay. Now Kubernetes directly support runtimes are container D and Carrier. Can Kubernetes use other container runtimes? Yes. These are default, but you can attach the others. We need to follow certain steps. So Kubernetes supports multiple container runtime via CRI, container runtime interface. Container D, Carrier, Docker also indirectly through the container D, Kata containers, gvisor. So these are uh, multiple containers, right? But we will go with the container D, which is the default one. Who created the Kubernetes? Google has created in 2014. So it was inspired by Google's internal cluster management system project, which was Borg. In 2014, Google open sourced the Kubernetes. Who maintains the Kubernetes today? Kubernetes is maintained by CNCF, which is Cloud Native Computing Foundation. CNCF is the part of the Linux Foundation. The major contributors are Google, Red Hat, Microsoft, Amazon, IBM, and VMware, right? So Intel. Now there are different certifications. So mainly there are three certifications uh, which shines your resume. Those certifications are CKAD. First, we need to do CKAD, Certified Kubernetes Application Developer. So this is, you can say, it's the first step to learn about the development in the Kubernetes. Okay. So second is CKA, Certified Kubernetes Administrator. So in the Kubernetes, if you want to create the users, you want to give a role-based access, and there are so many admin related activities. And if you want to do that, then you can go with the CKA. Third is CKS, Certified Kubernetes Security, right? So I'm already certified in these. CKS I have not done so far, right? But and in this training, we will means um, I will be covering both CKAD and CKA. Okay, so
And how much does it cost?
that actually, if you on the December month, if you go that what we call Black Friday sale.
Black Friday.
So so at that time it is 50% off. Overall cost, I think it is $400. That we can see on Linux Foundation. So $400. So one, and you will get 2 attempts. And the questions are not MCQ questions. So they will give you one cluster and they will ask you to, you know, um, to work on that cluster. Like they will give you some scenario, and on the basis of that scenario, you need to uh, write some command or scripts. Okay, and these are open book. Okay, so these all are
Okay.
open
Open book
book.
test.
Yes, so you can refer the Kubernetes uh, website for the documentation. And Kubernetes, because see, Kubernetes is using the scripts and there are so many keywords, YAML syntax, it's very difficult for anyone to remember those. So that's why they made it open book, and it is very straightforward. For example, there is a question. In the question, they will give you one uh, link button. So you can click on that and you can directly jump to that particular uh, that documentation. And if you want to see the syntax or something related to that. So there, when I took that exam, there were 17 questions, and I think 70% is the pass marks. So, mm, so they rate on the basis of the questions they give, the difficulty level of that questions. Okay, so these are some certifications. Now, yeah, 2 hours, 67% is pass marks, 66, yeah. No? See, if you are creating the Kubernetes within your own premises, right? Like we are going to create, we will have our own virtual machine, or if you are setting up it on your own data center, you use a tool which is called KubeADM. So KubeADM is a tool if you want to set up the Kubernetes cluster master worker nodes on the if you want to set up it on a on-premises environment. If you want that master node is to be managed by a cloud-based environment like Azure, AWS, or Google Cloud. So there you need not to set up the environment. AWS will give you a ready-made environment. You just need to pay for the resources which you are using. Okay. So in AWS, EKS, in Azure, AKS, in Google Cloud, it's GKE. AKS, Azure Kubernetes Service, Microsoft Azure, and manage control plane, integrate the security networking. So you can take the advantage of the Azure here, Azure services. Like there is a key vault service, there is networking, there is intra ID, right? So all those things uh, you can take the advantage with the Kubernetes cluster. Okay. So for example, here, when I create the virtual machine, it will be the Azure virtual machine. And whatever the security, whatever the features it has, that will be automatically added. So same case with the EKS, which is the Elastic Kubernetes Service, AWS. Fully managed service by means managed by AWS. Deep integration with the AWS services, IAM integrations, and GK is for the Google Cloud. Okay, so this is provider is Google Cloud, maintained and created by the Kubernetes. So Google is the founder of this Kubernetes engine, right? So this is created by Kubernetes, right? Highly optimized, and so these are the things. Any question you have?
No, sir.
Just walk through this lecture one more time, and or this documentation. Now let us talk about the Kubernetes architecture. So when we are talking about the Kubernetes architecture, so there are mainly two components. One is called the master node, or we call it control plane. And second is worker node. So worker node is the one where actually the container get created. On master node, we are see, as I mentioned, any request. So like in Docker CLI, we are having Docker command, Docker container run, Docker images, Docker, all the commands which are related to the uh, Docker, they are started with the Docker CLI, right? Docker. In Kubernetes, if you are running any command, it will be started with the kubectl or kubectl. Okay? So some of my students, they pronounce it kubectl, especially those who are foreigner, American based. So they call it kubectl. So it's up to you. You can pronounce it kubectl or kubectl. Okay. So you can also interact with the some dashboard programmatically when you are accessing it. So Kubernetes can be accessible. Uh, kubectl command line tool. Okay, or you can say Kubernetes client, CLI. So all the requests when come, it comes to the master node first. In master node, on the front door, API server is sitting. So API server is a Kube API implementation. So what it does, you can think it as a security guard in front of your company. If someone comes into your company, they need to show the badge, right? So they need to show their ID card that we are from this company or we are the authorized. So API server is the front, it's a front end for the Kubernetes. And when any request comes, it comes to the API server first. Then API server will check what to do, right? Where this request is to send. So there are different components. First component is called etcd. This is a key value pair of cluster information. Entire cluster information is stored in the etcd file, or etcd you can say database. It's not a MySQL Oracle kind of database, it's a file system only. But the entire cluster information, what is cluster information? How many worker nodes, how many containers, which container get created on which worker node, networking, whatever is in the cluster, everything will be stored in the form of key value pair in the um, etcd file. Sometimes this file becomes very large when you are having a large um, Kubernetes cluster. So what do you do? In that case, you can just remove this etcd from this main cluster server. Okay, this, and you put it into a separate server. There is a separate server which is having etcd because unnecessarily this slows down this server. So that is why we keep it on a separate machine. If your cluster is very big and you are having only limited server for the master, right? So then it will be a good idea. So it will not unnecessarily slow down your system. Now, second is the scheduler. So scheduler is the one which will decide where a pod will be created. Will it be created on worker node 1, worker node 2, worker node 3? So pod allocation is done by the scheduler. If you are having certain constraint in the sense you are saying that uh, my cluster is to be or my pod is to be created on worker node 1 only. So that constraint I will give it to the scheduler, and scheduler will create the cluster, create that pod on that particular worker node only. Then we are having controller manager. So controller manager is the one which has multiple subcomponent. You can say replication controller. There is a endpoint controller, node controller, right? So those, for example, you want to apply a replication. So controller manager is running one infinite loop, which will be checking that current state is equals to the desired state or not. Like if you are saying there should be two replicas. So two replicas are running or not, that will be decided by the controller manager. That is one of the example. These are the master component. The worker node, where the, so API server will send a pod specification to the worker node. Okay, pod specification that we need to create a container with this pods Nginx container and this Docker image, right? And some other properties if you want to give port number, etc. So worker node is the machine where your actual container will be created. So kubelet is the service which is, you can say, supervisor or you can say agent on the worker node. So what it will do, it will say that whatever the pod specification I'm receiving from the API server, whether the containers get created with that specification or not. For example, a container is to be created in Nginx. So what it will do, it will create a container. Okay, because this is the one who is the supervisor or who is the agent on that particular worker node. It will create a container as per the specification. Consider someone deletes this container. Then it will create it again because it will be keep checking that container which is created by this particular kubelet, right? So kubelet is a service which is running as a service. So it will check that whatever the port specification I have received, whether that port specification is that port specification and which we have received, is it running with the same configuration of the container? If not, then it will create the container also. Then kubeproxy, it is basically used for the networking. See, containers are running on this worker node. How they will be accessible through, there is a concept in the Kubernetes services. So network things, how container will be accessible, right? How the network traffic will flow, what are the foundations, what are the constraint, etc. So those things will be defined under the network policies, right? So those worker node level network policies, how the Kubernetes service will talk to the Kubernetes worker node. So those things will be managed by the kubeproxy. Container runtime means containerd in our case, and pod will be created. Is it clear?
Yes, sir.
Yeah, good. So this is the Kubernetes architecture. You need to print it into your mind because that is one of the favorite question of the interviewer for Kubernetes. One thing I have not added it, but I will just show you. So whenever you are, there are something which is restriction for the Kubernetes, that you you cannot have more than 5,000 nodes in a cluster. You cannot create more than 150,000 or 150,000 pods in a cluster. You cannot create more than 300,000 containers in a cluster. You cannot create more than 100 pods per node. So these are some restrictions. Resource requirement, like hard disk or memory requirement, it totally depends that what type of pod you are running, what type of containers you are running, right? Worker nodes, how many worker nodes we need to create? So it totally again depends upon, for example, you are saying total number of worker node size, depends upon the pod resource requirement. The total number is maximum number of pods. For example, you want to create 10 pods, and per node, you want to create 2 pods. It means I need 5 worker nodes. Okay, just 2 divided by. So plan some failure nodes means 5. You can make it 7 nodes, so that if one or other node is, if it is failed, then you can utilize the other one. Right. Then this is the master server configuration. If you in your cluster you are having 1 to 5 nodes, then 2 CPU. This is the minimum requirement for the master node or control plane. 2 CPU and 4 GB RAM. If you are having 6 to 10, this is for master node only. Okay, worker node you can have a less configuration. 6 to 10 nodes, 2 CPU and 7.5 GB RAM. If it is more than 500 nodes, then 36 CPU and 60 GB RAM. So Kubernetes, even though we are going to do a practice also, but configuration wise, we need a server type machine. Okay, so in today's lecture, I told you this will be a theoretical lecture. So in this lecture, we have basically gone through what is Kubernetes, what are different certification, what is Kubernetes cluster, Kubernetes architecture, what are the Kubernetes restrictions, why Docker is stopped supporting, right? So all this now, as I mentioned, I will share one video with you. I will add it into the same playlist, and you will see that how the Kubernetes cluster is to be created. Okay, you just follow that one, and if you face any issue, then you can let me know.
Sure, sir.
Hmm?
Sure, sir. Yeah.
Yeah.
No,
All right, then that's it for today. Hmm? We'll meet tomorrow. Thank you.
okay, sir. Bye.
Yeah, thank you. Bye. Hello, everyone. Welcome to this lecture. In this lecture, we will see that how we can install Kubernetes 1.35.0 version by using KubeADM on our local system. You can use AWS or Azure system for this installation. I'm using my VirtualBox Ubuntu machines, and if you see here, I have these 3 machines, Ubuntu and Worker Node 2 and Worker Node 1, right? So these are the machines which are basically my machines where Ubuntu 24.04 is already running. And I will uh, take my Ubuntu as a master server, and these 2 are the worker nodes. Okay, so I'm already having a network connection with my virtual box. So if you see here, if I go to uh, file, and if I show you the network settings, so here I am having a input network, which is my NAT network. And here it has the CIDR range 192.168.0.0/24. So this input network I have used for all the machines as adapter 2. So if I go back here, if I show you my master server network settings, so I will go to the settings, and here in the network, what I have done, I have created adapter 2, and there I have used this input network. And to connect this machine uh, through my MOBA Extreme or PuTTY in adapter 1, I have uh, done the port forwarding. So 2295 port number I have uh, mapped with port number 22 of my virtual machine. Similar kind of network settings I have done for worker 1 and worker 2. Now in my MOBA Extreme, these are the 3 machines. So I will log in with the root user. sudo su and vbox user, and I have a password. So I'm currently logged in as a root user. So this is my machine 1, this is my machine 2, right? And this is my machine 3, right? So if I show you the IP address of master node, so you can see the IP address of master node. This is for adapter 1 and this is for adapter 2, 192.168.0.5. And for my worker 1, the IP address is 192.168.0.6. And for worker 2, the IP address is 192.168.0.7, right? So these three machines are in the same network. First, we will check whether they can ping to each other. So here from worker 2, I'm just pinging to 192.168.0.5, which is my master node. So see, I'm getting the response. Same way, I will check whether it is able to communicate to 06 also. Yes, the communication is happening. Same way, worker 2, I will say ping to 192.168.0.5, which is my master server. Yes, so it means they are in the network, and 07, which is the worker node 2. Now on master server also I will do a double check. I will say ping 192.168.0.6. I'm getting the response, and same way for 07 I'm getting the response, right? So uh, architecture part I have already discussed. So we first what we will do, we will install the common components of master and worker node. So for that, what I'm doing, I'm just using this multi-executor in MobaXterm. So with the help of that, what I can do, I can run the command on all the machines together. And I'm following this document. So this document I will share with you, or I will put it into my GitHub repository. This is the installation guide. So if you are using AWS machine, then T2 medium is the machine for master server. For worker node, you can take T2 micro. Okay, T2 medium is not free, of course, that you just need to bear into your mind. Now, there are some commands which you need to execute on both master and the worker node. So let us execute those commands. First command, sudo is optional because we are logged in as a root user, but let us run as it is. So first command is apt update command. So I will go to my MobaXterm and I will click on the multi-paste. Now this will execute this command, right? So once it is executed, then we are having some prerequisites, like we need to install the apt transport https curl command. Okay, let us copy this command also and run it on all those machines. So these are still in the update state, so it will be finished soon. Right. So this particular push, this worker 1 is done, and it is fetching the detail for master node and the worker 2. Okay. So yeah. So worker 1 and worker 2 is done now. And master is also done. Now I click on multi-piece. So it will install these two softwares. Now next is that I'm using containerd, which is the container for the or the container runtime. So let me execute this command. Because I'm using my local setup, that's why it is bit slow as compared to the AWS or Azure machines, right? So these are installed. Now I'll click on the multi-paste and press enter. So this is done. Now, next is that we have used the curl command. Now, next we need to install this. And these are the steps. So we will run these 3 lines together, right? So I'll go here and multi-paste and press enter, right? Done. So now next is apt update, because we have added something into our apt repository, which is reference to the containerd. So once it is done, then we will install our containerd, which is containerd.io -y, right? So we will run this command. Right? So once it is installed on all the machine, we need to create some files which are related to the containerd for containerd configuration. Right? So it is installing. Right? Now I'll create this directory, containerd directory under etc. Then I will have this configuration file, right? So, right now, next is I will run this command to give the systemd C group and yeah, C group information, right? Now we will restart our containerd. If it is get restarted successfully, it means our containerd is up and running. Okay, so no error. Now we will install the Kubernetes related package. So far we have installed the container runtime. So this part I will remove it. It's not required because this is 30 version. We will be using 35. So I will just, this is a echo message, right? So let us run this also. So, okay. So I think single quote is missing. I'll put a single quote. I will put it into the, okay. So now this is a echo command actually, which is not doing anything. It's a message only. So I'll put a single quote here. Now, next one is that I need to download the GPG key and it should return OK if it is the correct one. So we will download this GPG key. Okay. And okay, it did not return the error. Uh, okay, in the previous versions, it was returning OK. Okay, but here it did not return the OK. Let us see um, whether it is causing any issue. Now we will give the permission to this GPG key. Okay, no error. Now, what we will do, we will add the reference to our Kubernetes packages. Okay, so this echo command is not required. Means if you want, you can just for reference purpose what we are doing. So I'll copy this. Okay, something is missing. So, okay, actually here the command is starting from echo only. It includes everything. So let me just copy this again and let me press Control C and we will do it again. Multi-paste and press enter. Right. So now next is that apt update. So we'll run apt update, multi-paste. Okay. So because we added the Kubernetes list, Now we will install these three packages, which is kubelet, kubectl, and kubeadm. Okay, which will take little bit time to install. And okay, so these are building, means it is getting downloaded. That's good. So once they are downloaded, they are basically uh, kubelet, kubectl, they are running as a service. Okay, so once they are in the running stage, so we will mark it as a hold. Okay, so that if there is any updations are required, so we need to mark it on hold. So it will be a planned way to deal with these services. Okay, so this is installed. Good. Now, next is that we need to run this command. So let us run this command. Right. Now, next is that we need to enable the kubelet service so that it should be always be in the running state. If it is not in the running state, we will get some issues because this is the agent on the machine, right? We need to disable the swap also. So I will swap off. Okay. And mode prop br net filter. Okay. And we will just write IP forward equals to true. Right. And right. So common commands are executed. Now, what we need to do, we need to run the command only on the master node. Okay. So what I'll do, I will just exit from this execution mode and I will go to the master node because now the commands are to be executed on the master node. And if you see here, I'm using this IP address 192.168.0.5. So that kubectl kubeadm init command with the API, and this is the IP address of my master server. And this is the CIDR range for my pod network. So let me run this on the master server. Okay. It will take little bit time to install. Maybe it will take 2 to 3 minutes. Okay. So I will pause the video once it is done. Then I will come back to this. Now it is installed, right? And here you can see there is a join command. So we need to copy this join command and we need to execute it on our worker node to join in this cluster. Here you can see it is giving some instruction. We will follow that. We need to create these directories. But what it is saying, we need to run this command. You can join any number of worker nodes by running the following on each as a root user. So I will copy this. I will go to the worker node 1 and I will run this command. Okay. So same way, I need to run it on worker node 2. Right? Now, if I go to my master node and in the master node, uh, there are some commands to start using your cluster. You need to run this following as a regular user or the root user is also fine. So I need to create .cube directory. Okay. Second, I need to run this copy command, which is a config uh, file, which is copied into .cube home.cube directory. And third one is that we need to give the we need to give the ownership to the configuration file. So I will just paste it here, enter. Right now, everything is done. One thing is left. We need to install the pod network plugin. But if I run this command, kubectl get nodes, so you can see I have 3 machines in my cluster now: K master, K worker, worker 1, and worker 2. Master is control plane, and but you see all are in not ready state. The reason is because these are these needs in network plugin. So I'm using Flannel network. So if I go here, and now if you see here, um, you can see here, these are basically some troubleshooting. Let me just check that Flannel, right? So here we need to install this network uh, plugin file. Okay, so we'll just copy this, and and that we need to execute only on the master machine. Okay, so on master machine, I will run this Flannel file, and you can see this particular uh, file, YAML file get executed, and you can see everything is fine, right? Now, if I run the command kubectl get nodes, still they are not in the ready state. We will wait for some time. It takes maybe 1 minute or so, then they will be in the ready state. So let's wait. Now, after waiting 1 or 2 minutes, I can see all the nodes are in the ready state. Okay, we will do a normal testing that our cluster is creating the pods or not. So we will check that kubectl and run pod 1 with the image nginx. Okay, pod get created. Now we will double check kubectl get pods. So you can see it is in the creating state. So again, we will wait for a minute, and it is still in the creating state. It should be in the running state if everything is fine. Okay, now you can see my pod is in the running state. So it means our setup is good, and that's it for this lecture, where I wanted to show you that how we can have our Kubernetes cluster ready. Okay, so yeah, see you in the next lecture. Till then, bye bye. Hello everyone. In this lecture, we will see one problem during the installation or after the installation. When you reboot your master server or worker node, you find that your pods are not getting created properly. And I'm just trying to provide that solution for your Kubernetes setup. And that error is basically happens when you are using the Flannel network, right? Um, so you see when you are creating your pods, it is always in the creating state. And when you describe that pod with your pod name, so you see some error failed to create the sandbox, RPC error, unknown, right? So the main root cause is basically either swap is enabled, IP forwarding is disabled, BR net filter is not loaded properly. So these are the steps which is basically causing this issue. Now, if I go to the steps which I have followed earlier, so we have executed these steps to disable the swap and net filter and IP for forward steps equals to 1. But actually, we did not run it for the permanently. Even though whatever the solution I'm going to show you now, you can put it into your initial setup also. But if you have already installed Kubernetes and you are facing this error, then you can run the commands which I am going to run now to fix that issue. So what kind of errors you will get? So if you run this command kubectl get pods -n, which is the namespace kube flannel. So when you run this here in my case, because I have fixed that issue, so here it will show error or it will show unknown, right? Some or crash back of that kind of error it will show. Now, to fix this, what we need to do, we just go here and we will see the solutions. First of all, you need to see the swap is off or not. Now, for that, you can run the free -h command on all the machines. Okay. So this solution is for all the machines. So what I'll do, I will just click on this multi-executor and let me, I'm already logged in as a root user. Okay, free command we can run without root user. If I say free -h, so here you can see swap is 0 byte. So in my case, swap is disabled. But consider, let me exit from this multi-execution mode, right? Uh, so what I'm showing you now, it will be, you need to check on all the machines. So swap should be 0 byte. It should be off. Okay, so that is one thing you need to check. Now, if it is showing enabled some value it is showing, then what you can do, you can just go to a file, which is the etc under etc fs tab file. And there you will find the entry which is related to the swap. If it is there, then comment it. If it is not there, no need to do anything. Okay. So if that entry is not there, it means swap is already off. Okay. So that is one thing. Now, second thing is that we need to have this IP forward and the IP tables call. It should be equals to 1. So in that case, we will go to this file. If this file is not there, then you need to create it and you need to add those entry into that file. So let me just go. I have already added those entry and that you need to run it on all the machines. So if I say cat, and you can see I have already added those entries here where I'm setting up the IP forward equals to 1 and uh, that IP tables equals to 1, right? So these entries we need to do. Then after that, whenever your system get rebooted, so uh, these settings should be automatically get applied. So that is why we need to run sysctl -- system. Okay, once you run it, so this will be permanently get changed even though when you reboot your system. Another thing is that in the kernel module, we need to enter one value which is for the net filter. So here you can see that this file, which is the etc, and this file also does not exist. We need to create that. So if I go to this particular file, so you can see I have written br underscore net filter. So you need to enter this value and then uh, you need not to do anything. Just if you want to do a verification, you can just run this command. Then after that, you just restart your kubelet. This is optional, I did not do, or you just reboot your system. Once you reboot your system, the issue will be resolved. Okay. And now if I go to my, and these things you need to run it on all the worker nodes and master node. Okay. Not only on the master node. I have shown you on the master node, but you need to do it on the master node as well as on the worker node. Now, if I say kubectl and get ports, so you can see now my ports are in the running state. If I say kubectl and delete ports --all, so you can see all the ports get deleted and we will create a new port, kubectl run pod 1 with the image, say nginx. So now I'm creating a new port, so it should not give that error. Let us check. If I say kubectl get ports, so you can see it is in the running state. So now it means our setup is correct. I have rebooted this system earlier. So if you are facing any issue still, then just write it on the comment. I will see those if there is any possible errors which is to be to be rectified. Okay, so that's it for this lecture. Thank you. Hello everyone, welcome to KMIT Solutions Services. My name is Raman. I want to discuss a very important error which mostly we face when we are having Kubernetes installed on our local environment. Means we are having a virtual box, we are having Ubuntu machines, and we set up the cluster over there. Before talking about this error, let me just show you my setup. So this is my Ubuntu machine, which is master node. This is worker 2 and this is worker 1. Now, one thing I have done to make them communicate to each other, I have created one network, which is the NAT network. In the NAT network, it is called as input network. And it is having a range cider 192.168.0.0/24. Now, if I go to these machines, all the machines are having one common setting, and that is that its network, if I go, I have created two adapters. One adapter which is 190, which is NAT, and second adapter is connected to my input network, which is 192.168.0.0/24. Now, all the machines are having same setting. Now, whenever I'm using this virtual box, and if I go to these machines, so one thing is same here. If I say IP address, so you can see the IP address on adapter 1 is 10.0.2.15 and on adapter 2 192.168.0.6 for worker 1. And if I run the same command for worker 2, it is also similar way because the adapter 1 is having same IP address as worker 1 and the second adapter is having 192.168.0.7 and on master machine it is the same setting. Now what was happening after means we are having this setup, and if you remember, if you are following my lectures for installing the Kubernetes, so I was having one init command, right, which I have executed. And there I had given 192.168.0.5, which is the adapter 2 IP address of master node when I have initialized my master server. But there is one issue which you will face, even though all the machines are in the ready state. But when you run this command, kubectl get nodes minus o void, so you will see that master node, worker 1 and worker 2, they are having the same internal IP because it is picking up the uh, adapter 1 IP address, right? So now what what will happen if this thing happen? If you are having the same IP address, then what will happen if you see here, I have one pod which is in the running state. And then when I was trying to go inside that pod, it was giving me the error. Internal error occurred, unable to upgrade the connection. Pod does not exist, whereas pod exists. Now, the reason or the root cause is that because all the internal IPs are same. So that is why my pod is not able to find on the worker nodes. Even though everything is working, your pod get created and pod is in the running state. If you go to that particular machine and if you curl with the pod IP address, it will work. So now to fix this problem, what we need to do, we need to follow certain steps. Step number 1, that you need to go to a file. Actually, we need to tell to the kubelet that use adapter 2 IP address instead of adapter 1. So on all the machines, you need to go to a file which is etc under root default and kubelet. Right? So here you need to do this setting. So on each machine, you need to have this kubelet extra args node IP equals to this. Okay, so when you use this node IP address for your kubelet, then it will come to know, oh, I need to use this adapter, right? So adapter 2. So similar way, if I am on my worker node 1, so in worker node 1, also I will run the same command, cat slash etc. You just need to open this. So I'll show you how you can do that. You can say nano etc default and kubelet. And here you need to enter this setting, right? So once it is done, then basically you need to restart the kubelet service. Same setting you need to do for all of your worker node, right? So then after, you just need to execute these two commands, systemctl daemon and remote exec. And second is systemctl restart kubelet. When you run this command on all the machine, then what will happen if I go to my master node now, and if I say kubectl and get pods, right? So you can see this pod get created 6 hours ago. Now, if I say kubectl exec minus IT, and the pod name is new pod and hyphen hyphen bash. So what it will do, now I'm able to go inside the pod, and this was not happening earlier. If I say, if I come out of this particular pod, and if I say kubectl and describe pod, and the pod name is new pod, and here you can see it is running on worker 1, and it is picking up the IP address, which is 192.168.0.6. So if you also face the same issue, then uh, follow these steps, and it will help you to resolve this issue. Documentation point of view, I have created this document. All the commands are available here, and you can copy paste these commands. And I have mentioned the root cause and the solution. I hope you like this video, and yeah, we will meet on the next lecture. Till then, bye-bye. That is related to the Kubernetes, right? We have discussed the architecture. We have discussed the basic unit is pod, right? We have discussed that whenever you are creating a um, pod, it is basically having a container inside it. So we discussed that there will be a cluster, right? So there will be a cluster, and in that cluster we will have some machines, and one of them must be a master machine, which is also known as control plane, right? So the one which I have set up environment, so it has control plane, and it is having the worker nodes. So worker nodes are those machines where actually the containers get created. And now if I say that I want to create a pod, so pod will be created on this pod network layer. So during the installation, I used a plugin which is the Flannel plugin. So there are many plugins are there, right? Like Calico is one of them. So they have their own advantages. So they are having their dedicated portion, which is for the um, for the Kubernetes only. So Kubernetes also recommends that we need to use these plugins, right? If you see AKS, if you see EKS, or you know any cloud-based environment, so they are using these uh, plugins only, right? So with the AKS, you can use Calico, right? There are some plugins which are inbuilt in the Kubernetes also. So if you want to use that network solution for pod network, you can use that one also. But as I mentioned, Kubernetes also recommends that we need to use these uh, uh, these plugins. Okay, so now uh, now so what we will do now, our setup is ready, and I fixed those issues as well. So I will connect to those machines, my machines. So I will go to my master node. And I'll go to my worker one, and I'll go to my worker two also. Okay. So these are in the starting state, that's why. So now you can see here that these machines are getting started. So if I remove this, right. Okay, so looks like these get started. Let me just, okay, worker one is having no trouble actually. It is giving some message where it says that it is not supporting this VirtualBox, whereas it supports. I don't know why it gives that error, but you can see that worker one is also connected. Worker two, it is asking the password, and I'm giving the password. Now all these three machines are in the network that I have mentioned in during the installation, and also these machines are uh, now connected through the pod network, right? So how do you know that it is connected with the pod network? So whenever you are running, first time any command, for example, if you restart your cluster, so this is a cluster, okay, where we are having the master node and the worker node, and all the commands will be executed on the master node only. So this is my cluster, and as I mentioned, everything will be executed on the master node. So I have installed everything as a root user. So I'm logging as a root user, and I will execute all the commands by using root user. So master node, it is required. Worker node, it's up to you, means you want to log in as a root user or not. Underneath of this Kubernetes, the container runtime which we have used, that is container D, okay, not the Docker. So during the steps, I have also mentioned that we are installing a container runtime, which is container D on all these machines. Okay, so if I say Docker hyphen hyphen version, so Docker is not there. Okay, container D is there. Right. So now, first I want to check. Let me clear the history. History minus C. First, what I want to do, I want to check that all the nodes are in ready state, because unless these are not in the ready state, we cannot proceed, because we want to create the pods or containers that should be created on these worker nodes and through master node. So should be in the uh, all should be in the ready state. So I'll say kubectl get pods, get nodes. So you can it will run a query, and you can see all the nodes are in the ready state. This is master node, which is also known as control plane. These are the worker nodes, and we are using version 3 uh, 1.35.2. This version we are using, right? So our machines are ready, And now we move to the next part. And then one more thing, before proceeding, the error which I have received after installation or after rebooting my system. So that also we will check. So kubectl get ns namespace, and there is a namespace which is called the kube flannel. So this is the namespace which is basically required for the network or pod network point of view. So we need to see all the things are good in this particular namespace, especially the pods. So I'll say kubectl get pods under the namespace, which is this one. Okay. Now these are in the running state. Okay. So if it is in the running state, then it means it is fine. Okay. It doesn't matter that it get restarted 6 times, 2 times, but ultimately it is in the running state. So that is a good thing. Right. Now, uh, now we can start our, if I say our means pod creation or other things. So if I say kubectl get pods, let me see, is there any pod? There is one pod which is in the running state. If I say kubectl delete pod and pod one. Right. Now, first what we will do, we will see the application deployment. Deployment on Kubernetes using uh, using pod. First, we will see the how we can deploy the application as a pod. Pod is the basic unit of your Kubernetes. If you see in the Kubernetes, everything is moving around the pod. Like in Docker, Docker container is the one which is a basic or atomic unit. So in Kubernetes, it is pod, right? So we will, whenever we are talking about application deployment, when we are talking about how to access our application, so everything is moving near to this or moving around this pod only. So now this is, so now when we are creating the pod, so we can create the pods especially in two ways. One is by using commands, Kubernetes commands, and second is by using manifest file, which is nothing but the YAML file, YAML or YML file. Okay, so these are like this. So first we will see how to create the pod by using command. Knowledge of command is very much required whenever you are doing any day-to-day activities, or if you are appearing for the CKAD or CKA exam or any Kubernetes exam, because sometimes what happens that you are having uh, a scenario-based question, right? So in CKAD or CKA, all the questions are scenario-based, and you need to execute some commands. Okay, you need, maybe they will ask that change service account. They may ask that change the image of the pod, right? So if you have the knowledge of the command, it will be very easy for speed up those things, right? So it saves a lot of time during the exam, and also it's a good practice into your day-to-day activities also. So, right. So so let us understand the pod. So what I'm going to do, I will create a pod, okay, and I will deploy my application. So as of now, if you are having your own Docker image, you can use that one. But I don't have any Docker image at this moment. I have, but we'll take the example of the web server, which is Nginx. So Nginx is a Docker image from Docker Hub. So we will download this Docker image. So what will happen when I create this pod? It will be created on top of the pod network, and then it will be created as a container. Means because Nginx is a container, right? Nginx is a Docker image which will be created as a container inside the pod. So ultimately the container will be created. So that container will be created on some worker node. Okay, so let us try that. So the command, which is the kubectl run command to create the pod, right? So now if I say uh, kubectl run and hyphen hyphen help, it will show all the commands which are related to the Kubernetes run. If I say kubectl run and hyphen hyphen help, so you'll see that there are many commands are there, right? So you can see there are some examples are also given here. If you see kubectl run nginx image nginx, so this is the pod name. Okay, they had given the same name as the image name, but and then we are having the image nginx. There are some more options. For example, you want to specify that my application is running a specific port, right? So like nginx by default it runs at port number 80. So no need to mention hyphen hyphen port and then 80 because that is default. But consider your application is running on port number 81, then you can mention hyphen hyphen port and 81. Okay, so that we can do. Now, there are some other examples are there, like we can set the environment variable inside my container. I can also set the namespace, means these are the environment variables only, right? Hyphen hyphen env. So let us see these examples one by one. So first what I will do, I will create a container with a Docker image nginx, not a container. I'll say container will be created, create a pod, and inside the pod there will be a single container which is with Docker image, that is nginx, right? So kubectl run pod name I will give nginx pod, and the image which I want to use is nginx. So a pod get created and its name is nginx pod. Now ultimately what I have done, I have deployed my application because Docker image is what? It is your uh, application which you want to deploy as a container or as a pod. So earlier when I executed in Docker create a container, so at that time it was created by the Docker itself. But now I am using the Kubernetes, and in the Kubernetes I'm saying that um, create a pod with the image. Now pod and container both get created. Now how do you know to list the pods? Okay, so what I'll do, kubectl get pods. So it will list all the pods. Now see, it is saying this is my pod name. 1 out of 1 means this one indicates that how many containers you are having in the pod. So I'm having only one container, right? And first one indicates that how many are in the ready state, means they are in the readiness means something they can now accept the request. Okay, so they are ready to accept the request for container point of view. So it is ready state. Status is running. Currently it is running. So there are different status. There are, and that we will also see time to time. But let me talk about some of the status. One status is running. So running means your pod is up and running. Okay, pod is up and running. Second is pending. So when we talk about pending, so initially, actually this is the initial state. So initially it is looking for the worker node where it is to be created. This pod is to be created. So in that case, it is basically looking for those worker nodes. So initially your pod is in the pending state. Then it goes into the container creating. For example, it found that I need to be created. Who will decide that where a pod is to be created? In control plane or master node, there is a scheduler. So scheduler is the one who is basically creates the pod on a particular worker node. So that will be decided by the scheduler. Okay. So we will also see that um, how we can create the pod specifically on a particular worker node. That comes later. Okay. But the scheduler is the component in the control plane who will decide that uh, where a pod is to be created. Okay. So first pending, then container creating. So then on that particular um, on that particular worker node, when the container is started creating, right? So that is called the container creating. Now, after that, the container can be created successfully and in the running state, or it could be in the failed state. So running means like our container is in the running state. Yesterday means or in the in some cases what we have seen that container is in the creating state all the time. So we need to see that why it is not getting created. So there is a describe command. With the describe command, we can see that if there is a problem in creating the container, what is the problem? So according to that, um, we need to take the steps to 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 rectify that error. Okay. So these are different states. Number one, pending to find the worker node. Number two, create the container. Number three, it is in the running state or the failed state. Okay, and failing can be because of any reason your image is not correct or there is no sufficient memory or CPU on the on that worker node. Could be any reason. Okay, so no. So when I talk about the uh, uh, so when I talk about the states or status of pod. Okay, so status of pod is pending, then container creating, and then running or failed. Okay, this is pod life cycle. Now, next thing is that whenever you create a pod, okay, so whenever you create the pod, there are many uh, properties are attached to the pod. So here what I have done, I have given only two properties, right? Name of the pod and the image. But there are hundreds of other properties are automatically get attached. And to see those properties, we can use kubectl get pod and the pod name, which is nginx pod. Okay, if you want to find a particular pod, get pod and the pod name, and then -o YAML, or you can use -o JSON in whichever format you want to see. YAML is more, mostly we use YAML only. So now what I'll do here, kubectl get nodes, get pods. Okay, and my pod name is nginx pod -o YAML. So here you can see there are so many properties are here, right? So you can see that this is basically a YAML file, and this YAML file we can use for our manifest point of view also. So here you can see that pod, and these are other properties, right? Label is the one which we use, namespace, and there are many properties. Not all the properties we will discuss, but yes, whatever is required, time to time we will discuss those properties. Right? Same way, if you want to see this in the JSON format, so you simply say JSON, right? So same thing, but now it is in the JSON format. Right? Okay. Now, whenever uh, if you want to edit the if you want to edit the pod at runtime with Kubernetes command, then use kubectl edit command. Edit and your pod name. For example, I want to edit some property, kubectl and edit, and then the kubectl edit and pod name is nginx pod, right? So what it will do now, it is opened in the form of VI editor, same YAML properties which we have seen with the get command. So same thing, but now we can modify it. Now this is a VI editor. So now what I'm doing, um, I'm just changing something here. I will say label, I will change. So what happened? Okay, something wrong I'm doing. Oh, it is not working. Something wrong. Let me come out of this. Okay, kubectl edit pod and the pod name nginx pod. Okay, and what I'm doing, it is not taking. What's wrong with this? Okay, somehow it is not taking my characters. Let me just go to my, this is master node. Let me go directly to the GUI and see whether there is any problem. Maybe I need to update Vim, looks like. I'll say apt update VI editor. Update command takes no argument. Oh, sorry, apt update. I think VI editor is not installed. That's why. I'll check that one. Because this kind of problem occurs when your VI editor is not properly installed. Now see, after fixing that error, my CPU utilization is very, it is okay. I did not increase the number of CPUs also. Right. Now I will say apt install Vim. Okay. You want to install? Yes. So it was missing. All right, so this is installed. Let me try now again, that one. Yeah, now it is good. So now, for example, I want to make some changes here. So I'll say Nginx pod 1, right? So I will save this, right? So this is saved. Now, if I run the command kubectl get in the form of YAML, and I will grab the pod 1, right? Pod 1 was there. Right? See, it is changed. Or if you want to see complete detail, so you can mention the only without grep command, and you can see that change happened or not in the label. Okay, so this way we can edit the pod. Now, next question is that can we um, replace the Docker image for a pod? Can we replace? The answer is yes. So now, will it change the pod name? The answer is no. Same pod, but we can modify that image. Okay, what it will do? So it will remove the existing container and create a new container with new Docker image. Okay, so what it will do? It will means we in the container we cannot do that in Docker container. If you want to replace the image, you need to delete the container and you need to create a new container. But here in the pod, we can modify. What we can do, we can update the Docker image. And when we are updating the Docker image, then what will happen? It will delete the existing container and then it will create a new container. Okay. So when the container is replaced, then the pod get restarted. Okay. So first we will see how to go inside the container. Then we will see how to update the Docker image. Okay. So let's first find that where the pod is running. See, I have created a pod. Pod will be created on some worker node, right? Which worker node I want to see? So kubectl get pods. Okay, and you can use -o wide option. Okay. Now here you can see this is my pod IP address. So every pod is having the IP address, and see currently it is running on worker 1. It is running here on this machine, right? And now how this IP address is assigned? So if you remember, I have discussed that earlier with the pod network plugin, we can do that. Now here you can see when I have created my master node, right, in this step, here I had given pod network CIDR range, which is 10.244.0.0/16. So it means this particular pod will be under this CIDR range only. So 10.244 plus 0 plus dot 0/16, and this number is random. So, but it will be in that range only. Okay, so right. So the pod get created. Pod has an IP address. Pod get created on worker node 1. As I mentioned, We will see later that how the pod will be created on a specific worker node, right? But at this moment, scheduler has decided uh, put this pod on the worker node 1. Okay. Now, what I want to do, let me see if I can update the image. Now, um, let us update the image of the pod or container. So now we have created, if I say kubectl and get pod, and the pod name is nginx pod. Okay, get pod nginx pod, and if I say grep and minus I ignore, I want to see the image. Okay, get pod minus o yaml. Right. So here you can see I'm using Docker image, which is nginx. Okay, now if I say kubectl get pods, and my pod is in the running state, and if I say minus o void, I will see some more. I'll see some more cases, especially this. Now, if you are having this, if I say curl and this IP address, okay, so I'm supposed to get the nginx output. Okay, but because my looks like my pod is not reachable, looks like there is something virtual box kind of thing, some port is to be opened. I'll check that one. Okay, let me just see. Is this because of some port issue? No, this happens exec command. Kubelet. Okay, let me check that kubelet is running here. Systemctl status kubelet service. Yeah, so that is fine. So this is fine. Not sure where exactly is the issue, right? So let me see if I can update the. See, when I run this command curl, say an example, if I go into my worker node 1, and if I run this command, see, I'm getting the nginx response, right? So somehow master node is not able to communicate to the worker node, but on worker node, I have taken the pod IP address, and see, I'm able to go inside the container and I can see the output. Okay, right. Now I want to update this Docker image, and I want to see what is basically getting updated and what is not getting updated, right? So if I say kubectl and set image, so this command you can use kubectl set image of my pod. Which pod? nginx pod. So by default, the container name is same as the pod name. We can check that also with the help of the kubectl get pod minus o yaml container name. Okay, so if I say set image for my container, which is nginx pod container, and I want to change the image to Tomcat. From server not found pod Tom. Okay, kubectl set image pod nginx pod, and the container name equals to. Okay, so the image is updated. So now let me see. So what are the changes will happen? Number one, pod will be restarted. Second, nothing else. The port number, if because Tomcat runs at port number 8080, So that is for the Docker image. And let us see that. Now, if I say kubectl get pods minus o wide, so currently it is running. Okay, let us see whether it is updated or not. So far looks like it is not updated because my container is to be, or my pod is to be restarted. Okay, image is updated. Image is updated. So if I go here, now if I say curl, so this will not work. Now it is running at port number 8080. See, this is updated. Now let us see why the pod is not restarted. kubectl get pods. Yeah, it is restarted, right? Because whenever you are updating the Docker image, so basically what you are doing, you are deleting the container. So when you are deleting the container, then the pod is automatically get restarted because it is saying, okay, something went wrong into that container, or that container does not exist. A new container get created. So see, container is replaced, but the pod properties are same. Okay, only that restart is only the restart thing is updated. Do you understand this? Yes, sir. Yeah. Okay. Let me give 1 second. So now, uh, right. So now my container is replaced and new container got created, and my pod name and everything remains same. Okay. So set image command is basically updating the image of the container. Now, next thing is that I want to delete the container. I want to see the events, okay, to check the events related to Kubernetes pod. I want to see what are the events, or I want to see some, not only the events, but there are some other properties like which we see in the get pod command minus OYML. Some of the properties which are commonly required. In get pod, you get everything, right? But here, I don't want everything. I want some commonly used properties, but plus events. Events means how my pod get created, right? What is the Docker, means how the Docker image is pulled, how the Docker image is creating the container, what are the container names, etc. So what I will do here, I will say kubectl and describe pod and the pod name, which is Nginx pod, right? So here you can see that, right. So here you can see these are the events. Initially what happens, successfully assign the Nginx port to the worker node 1. Specification, pulling the Docker image, which is the Nginx image, and then successfully pull the image in these many seconds. Okay. When we have updated the Docker image to Tomcat, then it is also mentioning here that this is the Docker image which is changed to Tomcat. Container is created. Pull the image. Container is started. So there is no issue, right? So in worker node 1 also we can see this is the Tomcat output only. Earlier it was Nginx. There are some more properties, as I mentioned, you can see here. You can see the container name, like container name is Nginx pod. This is the container ID. As I mentioned, the by default container name and the pod name is same, right? So now this is the container ID. This is the image. This is the image ID. Port number we have not mentioned. So that's why there is no port number. And now here you can see label current state, it is in the running state. This is the IP address of the pod. This is the IP address of where it is basically get created. Like it got created on worker node 1, and this is the IP address of worker node 1. This is the issue. This is the issue. It should be 192. Okay, got it. So actually, I have used two adapters here. If I say IP address, so I have two adapters. I need to, maybe it is not talking to this adapter. That's why exec command is not working properly. But I will check that offline, that why it is not. It is taking this. This is also fine because if, okay, this is fine. So it is taking this worker node 1 IP address, right? So this is the describe command. In the describe command, you can see the complete detailed runtime properties and what are the things which basically get executed inside the pod, right? Last state also it is showing it was terminated because a new pod get created, right? So when the new pod get created, so it was in the terminated state, right? Now, if you want to delete the pod, then the command is kubectl delete pod and the pod name. So my pod name is Nginx pod. So it will delete the pod, it will delete the container, right? So everything get deleted, mean to say. So now we have seen how to create the pod. We have seen how to see the properties with the get command. We have seen that how to inspect the pod. For troubleshooting, you just go to the events and see what are the issues. If it is pod related issues, you can see in the events. And next is that we can delete the pod. We can edit the pod. We can delete the pod. Is it clear up till here?
Yes, sir.
Good. Now what we will do, this is one way. Second way is that we can create the manifest files. Okay. So we can create the manifest files also. Manifest files are the YAML files. Okay. So you can create in JSON, but everyone is creating in YAML only. So this is the second way to write the script into the, this is the second way to create the resources in the Kubernetes by using this script, and that script is called the YAML script. No? Writing a YAML script is very challenging because it is having a lot of indentation alignment problems, plus we need to remember so many reserved words. So that is why when you take the exam in for Kubernetes, like CKD, CKA, CKS, so these are open book exam. So for syntax point of view, what you can do, you can use the Kubernetes documentation. So let us see what is Kubernetes documentation and how we can create the resources with that. So I will go here and I will say Kubernetes documentation. Okay, so I will go to the Kubernetes documentation. This is the official documentation. You can come over here and you can search for example, I am searching for pod. Okay, so this is the pod. Go to the pods, and here you will see complete definition and explanation for the pod. And here you can see there is a YAML file. So what I will do, I will copy this YAML file. I need not to use much my mind, and I will say nano, and what I'll do, I will create a directory. I will create a directory called manifest so that I can keep my files there. So I will say cd and manifest. Okay, and now here I will create a file called pod.yaml. Okay, you can give any name. Extension should be YAML, and I will put that code here. Now what this code is doing, it is creating a pod, and that pod name is Nginx. So I will just change the name. So whatever changes are required, you make those changes. I'm changing the name to Nginx pod, and it is using a specific version. I want to use Nginx. Okay, so this is my code, and I want to create a pod by using this definition. Okay, what I have done, I have copied it from the Kubernetes documentation. Whatever the changes are required, I have done those changes. I did not remember the syntax and everything, and I'm going to save this. So this is my file. Now to create a resource like pod from the manifest file, we use create -f, apply -f, and delete -f commands. So create -f to create a new resource. For example, I want to create a new resource. Apply means update. Up means create or update. And delete means delete that resource. Okay. So let us do. So now if I say kubectl get pods, I don't have any pod because I have deleted that one. Now I want to create a pod by using this YAML file. So I'll say kubectl create -f pod.yaml file. So pod get created. Now if I say kubectl and get pods, so you can see, yes, my pod get created. See, similar way. Now this time I have used the YAML file. Okay. Now if you want to make any change, now I will go to this particular file, which is the pod.yaml file. I will make some change. For example, I want to here we don't make. I will add something called labels. Okay, so I will add it here, labels. Right, and here I will say name equals to or app equals to web app. Okay, I'm writing this. So if you see now kubectl, if I say describe pod Nginx, I did not apply that change so far. So now if I go Nginx, right? So if you see here, the label, these are properties of my pod. So here you can see label is none. Now I will apply that change. Now I will say kubectl. So I'm modifying. Okay. So I will say kubectl apply -f, and my file name is pod.yaml. Okay. So this warning you can ignore, but now my pod is configured. Right. Now if I check again, describe command, and now here you can see label is set to, so it means my pod get updated. Okay, so app equals to web app. Okay, so this is the IP address of my pod. So apply command. Now if you want to delete the pod, you can use the previous command also, like means earlier command which we have discussed to delete the pod, kubectl delete pod name, or you can also use kubectl delete -f and pod.yaml. So it will go and check what you have created in this YAML file. So kind is pod and pod name. It will delete that pod. Now if I say kubectl and get pods, so you can see no resource found. So this is one way to create the pod by using YAML file. Is it clear to you?
Yes, sir.
Maybe you need to practice this. Okay. So
So can you
uh,
share the command, history command?
I will share all the commands and file also. Now next is, this is one way, but this is also fine. But there are some other ways. Now you can also create the manifest file by using kubectl commands. Okay. So, but the resource should have the create command. Like to create the um, uh, pod, we have kubectl run command. Okay. So if we are having a create command for the resource means further we will see services, deployment, etc. So if we are having the if we are having create command for that resource, then we can create the YAML file from command itself. So the command is, now we don't have any resource. So I want to create one more YAML file. So I'll say kubectl and run. For example, I want to create a pod. Pod name is pod1 with the image nginx. If I run this command, it will create the pod, but I want to create a YAML file so that I can share with others. I can do a version control of that. So now I will write here ---- dry run equals to client. Okay, -o YAML. When you run this command, it will create a YAML file for you, but it has so many maybe something which you don't want, like resources you don't want, DNS policy. At this moment, we don't need it. So then you can modify that one. So here I have printed the output on my screen, but I want that this output should go to my sum file. So I will set this and greater than, I will just give pod1.yaml file. Okay, now this time a file get created, which is pod1.yaml file. Okay. Now I want to remove the things which I don't need. So what I will do, I will go vi and pod1.yaml file, and I will remove these things which are not required. For now, it is not required. So this is my simple this Kubernetes manifest file, and what I will do, I will save this. Now I will say kubectl and create -f pod1.yaml file. Now pod get created. See, this time I did not refer to the Kubernetes documentation. I have created through command this manifest file. If I say kubectl get pods, so you can see, yes, pod1 get created. Right. So this is the second way to create the manifest file. Now I'll say kubectl delete -f pod1. I am deleting this pod. Third way is that you need to have Visual Studio Code. Right. So you can have the Visual Studio Code. Let me go to my Ubuntu machine. Right. Now let me see whether I have Visual Studio Code here. Visual is not there. VS Code. Or what we can do, we can install the Visual Studio Code on our system. Or you can do it on your Windows system also install the Visual Studio Code. Or we can go to the website and we can say install VS Code on Linux or Ubuntu. Right, we'll go to this website, right, and Debian package. Okay, so okay, so it is okay. Let me, because I already have on my Windows, let me open in the Windows. So when you are having your Visual Studio Code, right? So what you need to do, you just need to add a extension. So you need to go to the extensions and you can search for extension, which is Kubernetes extension. So Kubernetes from Microsoft, okay? Take this one and install this extension. Once this extension is installed, then what you can do, you can create, or let me create a folder. This is already existing folder. So I will go to my E drive and I will create a folder and I will name it as and create a folder called manifest. And I will open this folder into my Visual Studio Code. Right. So once you have that extension, let me create a file called my app. I'll call it as my app.yaml file. Extension should be YAML. Now, here what I can do, I can simply say pod. Right. See, it is in Kubernetes pod. Press enter. See, it has created the script for you. So now you can, change, like your pod name is my app pod, right? Label, this is optional if you want to remove. Resources we will discuss later. Container pod also we will discuss later, right? So now my image name will be Nginx image. So now I will copy this, okay? And what I will do, I will go here and I will say nano and my app pod.yaml. Now I will save this kubectl and create minus my app pod.yaml. So pod get created. If I say kubectl get pod. So this way also, so this is the third way. First way, Kubernetes documentation. Second, through command. Third, by using Visual Studio Code. Okay. So in this case, you need not to remember the syntax of the script. You need not to remember alignment. So yeah, so in that case, Kubernetes developer job is easy. Okay, even though you are having a lot of these sources, with the help of that you can create your YAML file. But I always recommend that you need to know at least few lines, or at least how to create a basic pod. Because if you have the knowledge of that, how to create a basic pod, then you can, you know, you can understand the scripts. At this moment, maybe you are not able to understand the script, but once you have that basic or foundation knowledge, then it will be easy for you to understand the other scripts, which maybe you can create by using those sources, Visual Studio Code or Kubernetes documentation. But you need to if something is required to change, so those things um, you can do it uh, uh, by understanding that script. So let me try to explain that very common code which we write. Now I will delete this also. kubectl delete -f and my app.pod.yaml. So this is also getting deleted. Now let me open the notepad. Right. So here I will say language, which is YAML. So there are four main components: API version, kind, metadata, and specification. So these are the four main components when you define the pod. Now API version is hard coded. I will share that what are the API codes, but these are hard coded for each and every type of resource. For example, uh, for pod, it is V1. For for deployment, it is different, right? So now kind means what you want to create. I want to create the pod, right? I want to create the pod. So kind is pod. When you are writing kind, first letter should be capital of each word. For example, you are creating replication controller. Then you need to say replication R capital, controller C capital, replica set R capital, S capital. Okay. So I'm creating a pod, right? Metadata is what are the properties, like name of the pod. So name of the pod, for example, this is, I'll say new pod. Okay. Then this is required, name is required. There is one more property which is called labels. So labels it's a, some custom properties if we are defining for pod, but this label will be practically we will see when we start talking about the replication. So here I'll say label, and label is, for example, I will call it app equals to Nginx app. Okay, some my own key value pair. Now in the specification, you need to define the containers. So I'm saying I have containers. So name of the container is, you can give anything, say C1, and the which Docker image you want to use. I want to use the Docker image, which is Nginx. Okay, so I will copy this manifest file and I will go here and I will say nano and new pod dot YAML file, and I will paste that code here. Okay, do you understand these 10 lines? And that
Yes, sir.
you need to write by your own without seeing this. Maybe you can practice one time, two times, 10 times, but you should be able to write these 10 lines. Then it will be very easy to understand the replication, very easy to understand deployment, because these 10 lines will be used everywhere. Okay, so you should be able to write these lines. You should be able to understand that what are these 10 lines means. So now let me save this. Now I will say kubectl and create -f new pod.yml file. Oh, sorry, something wrong. 1 second. Okay, one thing wrong. Name should be small letter all the time, not capital. Now let me run it again. Now pod get created. Kubectl get pods. So you can see my pod get created, which is Nginx pod. Other properties are same, delete, and this get and edit, whatever means we have discussed, you can apply. So it does not matter that how this pod get created, whether it is created by using YAML file or by using command. So ultimately it get created. After that, whatever the commands you want to run, you can run. Now script purpose is that we can version control it, and whenever you are using the CI/CD pipeline, so their YAML file is basically required, right? So in the YAML file, if you are having the YAML file, then it will be easy for the automation point of view. Is it clear? So let us do one thing. Let's wind up here for today, right? And let me just share the history of this command with you. We have executed all these commands. Let me share it on the chat window. Did you get it?
Yes, sir.
Okay, good, good. Let me share those files also. So I will say tail minus. So these are the YAML files. Take this YAML file also. So tomorrow we will connect. You want to connect tomorrow or not?
So tomorrow I'll do revision.
Okay, so tomorrow you want to take a break. Okay, so please do this before coming to the next
Yes.
lectures. Then it will be very easy for you to understand the further concepts.
Sure, sir.
All right, see you on Monday then. Okay.
Sure, sir. Same time.
Bye-bye.
Bye.
Bye. Now, in last lecture, we have seen that how to create the pod, right? And we have also seen that how we can create the pod. So pod you can create by using commands, right? So we have used that command, which is which is basically kubectl run command, right? So that command we have executed and our pod got created. Then I have shown you that how to do different operations, like how you can see the pods, right? How you can delete the pod, edit the pod, right? So all those things also we have seen in our last lecture. So everything is basically kubectl, right? So through kubectl we can add it to kubectl, we can delete. So those commands we have seen. Then after we have seen that how you can create a manifest file. Right? So I have shown you some couple of ways you can create the manifest file by using Kubernetes documentation, right? You can also use Visual Studio Code with the Kubernetes extension. Or I have also shown you that you can write at least those 10 lines, and those 10 lines are nothing but to create the pod. So pod definition we should at least know, right? So those things we have seen in our last lecture. So today we will see what is multi-container pod, right? So multi-container pod, and we will see how we can go inside the pod. Okay, how to go inside the pod, and then we will talk about the static pods, and if time permits, then we will talk about the config map and secrets. Okay, so let's start with this. So what I'll do here, I will connect to my MobaXterm. I'm connecting to my cluster, which is master node. And I will connect to my worker nodes as well. Right. So I'm on master node. First thing, we always need to check whether our cluster is ready or not. Right. So now first thing what I need to do, kubectl. Let me clear the history. Now if I say kubectl and get nodes, so all the nodes should be in the ready state. That is our first check, whether nodes are in the ready state or not. Okay? Because I just started my cluster, that's why initially it is taking some time. Now you can see, yes, my cluster is in the ready state, right? All the worker nodes and master node are in the ready state, right? So that is our first check. Always make it a practice when you are having on-premise. If it is EKS or AKS cluster, then it's a different thing because that is managed by cloud service providers. But here you can see all are ready. Now, last time we have created some pods, kubectl get pods. Let us see whether those ports are there or not. Yes, there is one new port. So I'm going to delete this one, okay? Kubectl delete pod and the pod name. If you want to delete all the ports, right, then hyphen all command. So this command basically deletes all the ports. If there are 100 ports, maybe you have created for testing purpose and now you want to delete all the ports together, then you can run this command. Now, I should not have that pod, right? Pod not found, right? So now next is kubectl, and we have created one directory called manifest. Let me go to that manifest directory, right? So I'm inside that one. If I say ls, so these files we have created last time, and I have shared these files with you as well. And now what I'll do, I will create a new uh, pod. Remember last time we have created this new pod. If I say cat, so multiple methods I have shown you, new pod.yaml, or you can take any file. Like let me take pod.yaml or pod1.yaml. So we have discussed up till node affinity yesterday. Right? Now let us talk about pod affinity. Right? So node affinity, I'll just recap what we have discussed in yesterday's lecture so that it will be easy to understand the further topics. So now if I say node name, so if you want to create a pod on a particular node, then node name you can use, and you can say node name equals to worker one. I want to create it on worker one. Okay, so that is node name we have discussed. After that, we discussed about the node selector. In the node selector, what we have done, we have basically mentioned, we have given the labels to our worker node, like environment equals to production, environment equals to uh, staging. Then we mentioned that if the environment equals to production, create the pod on that particular machine or worker node, right? So then we have discussed about the node affinity. In node affinity, we have discussed two options. One is required during scheduling, ignored during execution. So in that case, we can use the expressions, right? So let me just talk about those expressions which we have used in the node affinity. So if you see here, this is our environment equals, this is node selector, node type, node affinity types. We are having required during scheduling, ignore during execution. This is called the hard rule. And because this is required, means if that particular worker node is not found, which is having the matching label, then your pod will be in the pending state all the time. Same way, prefer during scheduling, ignore during, this is called the soft rule, because if that matching label is not found for the worker node, then what it will do, it can be created anywhere. Okay, scheduler will decide. So this type of example we have discussed yesterday, right? And I just want to talk about these operators. We have discussed three operators yesterday in where you say where environment in test or staging, then you can use the in operator. Not in just opposite to that. It means if you are saying that my environment is not in production, so it will search those worker nodes which are other than production. Exist, it will only compare the key. Okay, so it will only compare the key. For example, you are saying environment equals to production, right? So in that case, it will search environment, not the value. Does not exist. It will just check this label does not exist. Okay, or you can say it is opposite to exist. GT is greater than and LT is less than. For example, you are saying my CPU is greater than 2 something, right? You want to do this, then you can use GT, and LT is the less than. Let us see with the example, then it will be more clear to you. So here you can see in operator, right? So here in the match expressions, I'm saying environment in production. And same way, not in, you can see where environment not in staging, right? So it will be searching not in. Now here you can see where the label means key is the GPU, like environment. If I put environment exist, so it is not comparing the value, it is only comparing the key. And does not exist here. Uh, test node does not exist. So it will be just looking for those machines where label is not mentioned as test node. Now this is GT, which is greater than. For example, you are having a label which is called CPU equals to 8 in numeric value. So now you can see I want to see only those pods, or so only those worker nodes which is having CPU more than 8, right? So see, this is the real time we do. What we do, for example, there are some machines, right? And those machines are commodity hardwares or the advanced machines. Commodity hardware means they are having one CPU and 1 GB RAM. And advanced level, we are having 4 CPU, 8 CPUs. So now consider you want your application, your pod, which is running, it is having a it is having a you know very ERP kind of application. So it needs more CPU. Okay, or you want to increase the performance. You don't want to run it on the commodity hardware. So in that case, what you can do, you can mention into your condition that select only those worker nodes where CPU is greater than 2 CPU or 3 CPUs. Okay, and label, you just provide the label CPU is equals to 2, 3, 4 like this. Right. So here you can see, here I'm saying CPU and greater than value 4. Okay, same way less than. Now soft rule we have discussed, prefer during. I have mentioned that you are having the preferences. Like here, this is one preference, right? And this preference is the one which is basically saying environment is production. So it will be looking for those worker nodes where environment is production. If the environment is production found, it will create this pod on that particular worker node. But if that environment equals to production, that worker node is not found, then what it will do, it will be created anywhere, wherever it get the place. Who will decide that? Scheduler will decide that, right? But as I mentioned yesterday also, uh, there is something called weight. If you are having multiple preferences, for example, you have weight equals to 20, weight equals to 40. So similar way, you are having one more preference here, and there you have mentioned weight equals to 40. So in that case, this condition will be checked after this condition. So this preference will be taken first. This will be the high priority, and this is the lower priority. Right? So those things we have discussed in our yesterday's lecture. Right? So now, yeah, this is what I have mentioned. Weight determines the priority, right? 1 to 100. So 100 is the highest preference and 1 is the lowest preference. Right. Now, this is a complete script. How to execute it? We have executed yesterday. Now, next topic which I want to discuss. Okay. Okay. So now let us talk about the pod affinity. Right. So now pod affinity is what? Now let us understand with a example. Consider you are creating a pod, and that pod is web application pod. Okay. This is the web app pod. Okay. Inside the pod, the container is running. Okay. So consider you are having a pod, and that pod is web app pod. Now you want that this pod is to run on the same machine where database pod is running. Okay, where the database pod is running, I want to run this pod into that machine. So it means this is called pod affinity. Okay, it will be having the same options like required during scheduling, ignore during execution, but that was for the node. But now here we are talking about the pod. Okay, or maybe you want to run all your um, pods, web pod on the similar or closed machines. So pod affinity is used to control the which pod should run close to the other pods. Instead of selecting the nodes, pod affinity select the other pods. Okay, so this is selecting the pods. Okay, let us take one example. Run this, for example, run this pod on a node where another specific pod is already running. Okay, if DB pod is already running, create this pod onto that machine. Okay, example, your app pod run close to the database pod, right? What will be the purpose of this? It will create the network latency. Latency is the request plus response time, communication delays, right? So it will help to reduce this one. Now, pod affinity is useful It is beneficial in such a scenario where microservice communications are required. Front and back end, they want to communicate to each other. If they are on the same machine, then it will be a fast communication. Okay, so that is basically the one of the use case. To reduce the network calls, both pods can run on the same node. Now, database applications, you are having application port, database port, keeping together to improve the performance. High performance workload, when the ports need the fast communication, they should run on the same node or join. See, whenever we are talking about, pod affinity, so pod affinity basically of, you can say, three types. One is whenever we are talking about on-premises environment, right? So we are talking about the host machines. It could be region-wise. For example, you are having a cloud-based environment and you want to create a pod. So then you want to select a region, right? So you are saying, okay, my pod should be on certain region or certain zone, right, where other pods are running. Okay, so we'll see with these examples. Now, here you can see, as I mentioned, these are the two types of node affinity. One is required during scheduling and ignore during execution, which is a hard rule. Prefer during scheduling and ignore during execution. This is a soft rule. It is same as the node affinity. Means whenever a pod is getting created and it is looking for a pod which is having the same label or some label which you are selecting, then if it is found, then it will be created on that particular machine. And if it is not found, it will be in the pending state, right? And prefer during scheduling, ignore during execution. This is a soft rule. It will be creating a pod, and that pod uh, is searching for that matching rule. If it is not found, then it can be created anywhere. Right. So now let us see the required during scheduling. So pod must run on the node where the another specific pod exists. Otherwise, it will be in the pending state. Let's take example. Suppose we have a pod which is having a label backend equals to pod, and now we want front end pod. Okay, not label. There are two pods which is backend and front end, and we want to run on the same node as the so front end pod should be running on the same machine or same worker node where the backend pod is running. Okay, so let us create this backend pod. It is very simple. We have discussed so many times, right? So this script, uh, what I'm going to do, let me go to my Mobextrum. Okay, let me connect to my master machine. So what I'll do, I will connect with the root user. Right now, I will say, let me clear the history first. And now I'll say kubectl and get nodes. First, I need to see all my nodes are up and running or not. If my nodes are not in the ready state, then creating pods or other resources will cause the issue. So this is first thing always you need to check. Everything is in the ready state, and in my case, it is in the ready state. Now we have created one manifest directory. So here what I will do, I will create a backend. Name I had given backend -pod. Okay, so .yaml file I'm creating, and I'm not writing from the scratch because this thing we have discussed so many times. Now here one thing you need to note, the name of the pod is this backend pod, and there is a label called app equals to backend. Okay, so this is the label. So this label is useful when I create my front-end pod. At that time, I will say create this pod on the same machine where backend pod is running. So how it will search that? On the basis of this label only. Okay, so label is very important. And here I'm using one Nginx. Okay, that is fine. Okay, we can actually in real time backend means some backend application like MySQL or something, right? So, but because we are just understanding the concept, not the real time example, so I'm taking it as a image as a Nginx. Okay, now let me save this. Now let us run the command. First, let me see, is there any pod running? There is no pod. So I'll say kubectl create -f backend.yaml file. So my pod should be created. Right. So this is created. Now we will double check kubectl get pods -o white. So here you can see it is in the creating state and it is getting created on worker node 1. Okay, something wrong. It should be created by this time. Okay, let me just kubectl describe pod and the pod name is backend pod. Okay, so yeah, it is created. It is saying everything is fine. So it means it will be in the running state by this time. Yes, it is in the running state, right? So it is created on worker node 1, right? Now I want to create one more pod, which is front end pod. I always recommend that use Visual Studio Code, but because we are copy pasting here, so not required. But whenever you are writing the code for your manifest file, always use Visual Studio Code. It will help you to automatically write the scripts, right? So pod.yaml file, right? So now I will go here, front end pod. Now here you can see I'm in the front end. I'm using affinity, which is the pod affinity, right? So in the pod affinity, what I'm saying, required during scheduling, ignore during execution. Okay, so this is the hard rule. Now label selector, match expression. I want to search those machines where app in operator I'm using. So in means compare the value. So it is searching for the backend. App equals to backend. That is that application. So it means definitely it will be created on that machine. I'm using a topology key. So this topology key is basically telling what you are searching for. I'm searching for the machine, right? Host name machine. Okay, so host name is a machine. So these topology region and zone also we will discuss. And my container is front-end container and it is using the Docker image, which is Nginx. See, this order does not matter. If you write kind first, then API version works. If you cut from here and you paste it here, that will also fine. So order does not matter. Kubernetes compiler automatically check all these things that required things. So sequence does not matter. Okay, that's what I'm trying to say. So now what I will do, I will copy this script, right? And I will go to my code and I will save this. Now tell me where it should be created, on worker node 1 or worker node 2.
The node 1.
Node 1, very good. Because it is searching for those worker nodes where the backend application is running, right? So that is why it will be created on the same machine. Okay. Now, if I see this, now you can see it also got created on worker node 1, right? Now let us do one experiment. We will make some changes into our code. So I will delete this kubectl delete -f front end pod.yaml. So that is deleted. Now if I say get pod, that pod is deleted. Now I will open that front end, and here what I will do, I will say search the key where it is backend one, or maybe different key if I mention. Right? Now tell me what it will do now. If that particular label is not found, what it will do?
Show error.
Will it be create? Okay, you are correct actually, partially correct. So what type of error? Complete, partial to complete. Pending, right? Because it will be in the pending. It is searching, it is not found. So in the pod lifecycle, first step is pending. Then it will be, assigned to some worker node. But it is not getting assigned to some worker node because we are using the hard rule, right? So it will be always it will not go to next state. So right now, if I say kubectl get pods minus o void, so you can see it is in the pending state, and it will be in the pending state forever until unless you modify your script, right? Or until unless you have one more worker node which is matching with that label. Okay. So now I hope you are understanding.
Yes, sir.
Good. Right. So this is done. Now, next one is these are the important fields we have already discussed. You just go through this, and topology I as mentioned, where the pod should be placed together. Okay. So hostname runs the pod on the same node. What are the other one? Zone and region. These are mostly we use for the cloud-based environments, because Kubernetes we can use in the AWS, Azure, right? So cloud-based environment, right? So now soft pod affinity, it means if the pod runs to the near other pods, but not mandatory. Scheduler place the pod nearby. Okay. If the matching label exists, it will be created on that particular machine. Otherwise, it will be created anywhere. Let's take the example. Now, here, same example. What I want to do? I want to add these things. So what I will do, I will just create a separate name of this. I'll copy this and I'll go to my mobile external. I will say nano and front end pod, and I will say soft. Okay, soft.yaml. So I will put it here. I will just name it differently, so that I can identify this. Here you can see wait is there, preferred during scheduling and ignored during execution. So it means it's not a hard rule, it is a soft rule, right? So now it is searching for the, if I put as it is, it will be created on worker node 1. Now I'm putting the value backend 1 which does not exist, right? So it does not exist means what will happen now? It will be created anywhere. It could be on worker 1 or worker 2 also. Okay. So because it is searching for that label, but that label is not found. So what I'll do here, kubectl and create -f front end pod -soft.yaml file. So pod get created. Let us see kubectl get pods -o void. So you can see it got created on worker node 1. Okay, that is it could be created on worker node 2 also, because labels are not matched, then it can be created anywhere. Okay? So this is called the pod affinity, similar to node affinity, right? Now let us clean up this environment. We'll say kubectl delete pods -all. It will delete all the pods. Let us see something left. This is a complete example. Okay, node affinity, node labels, pod affinity, pod labels, scheduling target node, scheduling target pod location, use case hardware, environment like CPU and etc. And here the application proximity. Proximity means location, okay, where it is to be created. Now, next is the node NT affinity that you need to try by yourself. There is no difference. It is just opposite of that. Okay, what is opposite to that? Do not schedule pods together. Okay, this is the pod NT affinity. So this you need to try by yourself. And it is also having the same required during scheduling, ignore during um, execution, same thing. Just or if means you need to do little bit work on that. You just need to. I don't have example here, but you can say pod, NT, affinity, Kubernetes, right? So you can go to the Kubernetes documentation. Okay, better to go to the Kubernetes documentation pod, right? So pods to the nodes. Okay, and if I search for here pod affinity, right? So it's on the, let's try this one, maybe here. Affinity, NT affinity, node affinity, interpod affinity, and NT affinity. So you can go here, right? So you can check here pod affinity and pod NT affinity, right? So same options you need to use, but it will be the opposite of what we have discussed in the affinity. Okay, so this thing you need to try by yourself. So this is all about the pod affinity and NT affinity. Now let us talk about the taints and toleration. So what is taint and toleration? So when we are talking about the taints and toleration, so okay, this is wrong notes, looks like. Maybe I have not properly copied that. Give me 1 second. I'm stop sharing for a second. Let me modify these notes. Just be here for 1 minute. Just searching where I keep my notes. Almost done. I found my notes. Okay, I'm sharing now. Right. So taints and toleration. See, when we are talking about the node selector, node affinity, or pod affinity, so what we are talking about? We are talking about that when the matching label is found, then pod can be executed on that particular machine. Now, let us talk about the taint. See, consider you are having one machine. Okay? This is your worker node 1. This is worker node 2. So there is a property on the node level which is called taints property. Okay? So here, taints. So now what will happen? Consider I have created a taint app equals to web. Okay, one worker node, and here taint property is not defined, for example. Now, whenever you are creating a pod, right, and if there is a tainted worker node or node, it could be master node also. This pod, when it is trying to get created on this machine, if you simply run kubectl run pod 1 with the image nginx, when it is trying to get created on this machine, it will be repelled. It will be repelled. Why it is repelled? Because this taint is saying, hey pod, are you coming with the toleration? Okay. So what is toleration means? Whenever you are defining a taint to the worker node level or node level, then it is expecting that I will create the pod which is matching to that taint. Okay. And uh, if it is not matched, because this pod is coming without any toleration, so it will be repelled. Then it will go to this machine, and here we don't have the taint, so it can be created here. Right. So let us see whether we are having the taint already defined in our worker node. So here, what we will search for now, taint. Taint is on node level, and toleration is on pod level. Okay. So now if I say kubectl and get node, okay, I want to get a node which is the worker 1, right? So, and okay, instead of get, we'll say describe. Okay, we will describe the worker node 1. Now here you will find a property which is called taints, right? And see, it is none. Now I can search something like this also, grep and taints, right? So taints value is none for worker 1. Let us see for worker 2. See, worker 2 also it is none. Let us search for our master node. So which is K master, right? So you can see here it is not none. It is having some value, and there is something called effect, which is the no schedule effect. Now, there is a very important question, especially whenever we are discussing about the taints and toleration on premises point of view setup. So the question is that why the pods are not getting created on the master node? So the answer is because my master node is a tainted node, right? So there is a taint defined, and taint is having some effect which is called no schedule. No schedule is a hard rule. Okay, so this is a hard rule. It will only accept only those kind of pods which are coming with a toleration matching to this toleration, right? So now that is why any pod which we are creating, it is either getting created on worker 1 or worker 2 because they have taint property none, right? Now what I will do, I will define a taint property to my worker node 1. Okay, so let us do that. Now let us define the taint property to worker 1. Okay. So I'll say kubectl taint to my nodes. Which node? Worker 1. What taint property is something? App equals to web something. Okay. Kubectl kubectl taint some syntax problem. Kubectl taint nodes worker 1. Oh, sorry, app equals to. So what it is saying, something naming problem. Taint specific app equals to name part must consist of alphanumeric characters hyphen must start with an alphanumeric. Okay, maybe a space. Is it okay? Oh, let me just check the syntax once. So kubectl oh my god, my bad. It should be effect, no schedule. Okay, now it is tainted. We need to give the effect. Now if I search for worker 1 now, see it is having a taint value which is app equals to web, and it is having the no schedule effect which is a hard rule. So it means what will happen now, if I create a normal pod, it cannot be created on master node because that is a tainted node with the no schedule effect. And it will not be created on worker 1 also because this is also a tainted node now. Okay, so let us see. If I say kubectl and run pod 1 with the image, say nginx, right? So this is created, but now guess where it will be created? On worker 2 only, right? Because worker 1 is tainted, master is tainted already. So now if I say kubectl get pods minus o wide, so you can see that it got created on worker node 2. Now if I create it again a new pod, it will be again get created on worker node 2, right? So if I say pod 2, so it will be created on worker node 2 because that is having taint value none, right? So now what I will do, kubectl and delete pods. I will delete all the pods, right? Now right. So what is taint? Taint is or let us see here, right? These methods attract the pods, means node affinity, node selector, pod affinity to the nodes. But taint is opposite. Taint repels the pod from the nodes unless pod is matching toleration. So node, on the node level, we are defining the taint, block the pods, and pod is having toleration which is allowed to run. Okay, let us see one example. Suppose, so let us take this example. Suppose you have the nodes dedicated to the GPU workload, production workload, and database workload. So you are having 3 types of nodes, which is having these GPU production and database workload. You don't want that normal applications run on these nodes. Okay, so what do you want? That whenever you are creating a pod, it should not be created on these machines because these are for some purpose, which is the GPU production and database workload. So what you will do, you will apply GPU equals to true for your worker node, right? So we will apply that taint on the worker node, like I have applied in my example, app equals to web. Right? Now only ports with the matching toleration will be running on those machines, not any other. Now what is taint? Taint is applied to the node to restrict the ports from scheduling on the node. So it is structure, key value, and the effect. Like environment equals to production and no schedule, meanings ports cannot run on these machines unless they having a toleration. Okay, matching toleration. Right. Now, what is toleration now? Now I will create a pod. Right. Now, see, there are two things. Now consider this is my worker node 1. Right. And in this worker node 1, I have mentioned GPU equals to true. Okay. And now I'll create a pod, and there is another worker node, say worker node 2. Okay. Now here taint is none. Now when this pod is having the matching toleration, for example, like here I'm defining the toleration, key environment, value operator equal, and no schedule. Okay. So consider instead of GPU true, I'm having environment production. Okay, something like this. Now it means this pod is, if this is coming with the toleration, for example, right? Now if this pod is having the matching toleration, then it is eligible to get created on this machine. So it is eligible, but it is not mandatory that it will be created on this machine. Okay, but it is eligible to get created on this machine. Means what? If this pod comes to worker node 1, it can be created. When this goes to worker node 2, it will be created. So toleration is not only checking the matching on the matching taints machine, it will be created definitely, but it can be created on the machines which is having taint equals to none. Okay, so that also can be done. Now let us see. So what I'll do here, we will take this code, right, and I will go here and I will say here we had given the taint app equals to web, right? So now I'll say nano and taint pod.yaml file. Okay, and here I'll quickly create API version, which is v1, and kind is pod metadata, where name I will give as I'll just call it taint pod. Okay, label I'm skipping for now, and specification I'll say it is having the containers, and under containers I have my first container, name of the container say C1, and the image I'm using Nginx. Now I want to define the toleration. So I define the toleration. So here the toleration key is, in our case, it is app. App equals to, operator is equals to, value is, in our case, it is web. And the schedule effect is no schedule. Okay. So now I am defining the toleration on top of my pod, which is app equals to web and no schedule. Let us save this. Now I'll say kubectl get pods minus o wide. So now, if you remember last time our pod was normal pod was not getting created on worker node 1. Now let us see whether this will be created. So we will try kubectl and create minus f and taint pod.yaml. So pod get created. Now if I say kubectl get pods minus o white, so, minus o white, right? Kubectl get pods minus o white. See, it got created on worker node 1 because now it is allowed, because it is having the matching toleration. So taint is, so worker 1 says, okay, you are coming with a card into this marriage, which says that you are a guest. Okay, you are invited. Okay, so you are welcomed into that particular, but it is not necessary all the time. It will be created on, it's not mandatory. If there is a none, we are having one none, right? Which is taint 2. Sorry, worker 2, which is having taint value equals to none. So in that case, it will be created. It can be created on that machine also. So let us try that one also. If I say kubectl and if I delete minus f and taint.yaml file, this is deleted. Now let me create. Now let me try to create a normal pod, kubectl. Okay, so here I cannot do that because I have tainted, and by default it will be created on worker node 2 all the nodes. So but just keep in your mind when you are practicing this and you find that something is not worker 2 is not having that taint value, but my toleration pod get created on that machine, that can happen. Okay, that is what I want to say. Now let us go back to our notes. Now here types, these are 3 types of effects. One is no schedule. No schedule, pod will not be scheduled on other node. Means if no schedule is applied, then it always accept the pods with the matching toleration only. Prefer is a soft rule. This is hard rule. This is soft rule. So what it will do, it will basically prefer to avoid the scheduling. Means it will first it will search whether the matching toleration is found. If not found, right, then it will be created on any machine. Okay, same as the node labels, right? Now no execute, remove the running pods if they don't tolerate. Now let us do one thing. Let us create our no execute. Let us try to understand this one. So what I'm going to do here, I will apply that taint is already applied, right? Kubectl. So I will create that pod again, kubectl, and create minus f and taint pod. So this get created, kubectl get pods minus o white. So it will be created on worker node 1. Now consider I want to remove the taint property. Remove the taint property from worker 1. So what I'm doing, kubectl and taint my worker taint nodes, my worker 1, and you just need to give the key name, which is app, and then hyphen. So it will untaint that. So we can double check that. We can say kubectl describe, and our worker node 1 taints. Now it is none. Okay, but let me see whether my pod is still running. Kubectl get pods minus o white. right? So here you can see, yes, it is running on worker 1. Now what I will do, I will create a taint again with the no execute. So when you have the no execute, then it will remove the pods which are not matching with the taint property. Okay, so let me do that. If I say kubectl and taint my node, which node? Worker 1. And here I will say environment equals to test. Environment equals to test colon, and I'm giving no execute. Okay, so what it will do? Now it will see this particular pod is not having the environment equals to test toleration, so it will remove that. Okay, this is tainted now. Now if I run this, see my pod get deleted. So that is what I have mentioned here. Remove running pods if they don't tolerate. Right? So this is how we define that. Right? No execute. Now there is a complete example here I have. This is my, so let us understand. Now maybe you will be able to understand this. Now I'm creating a pod, right? And here you can define no schedule, add a taint to the node, environment equals to production, no schedule. Now here you can see that taint pod, and here you can see container image equals to nginx toleration environment operator is equal. So now this pod is created. Now you create a pod, verify the pod placement. It is running on worker node 1, and at the end we can remove the taint property. Right. So common real-time master node production, we use the taint. Dedicated nodes, we use maintenance node. So in those cases, we are using the taints. Taints versus node selector. So scheduling style, it is attraction, it is repulsion. Based upon label, based upon taints. Port control, simple, advanced. Right? Okay. So I hope you understand this, but yes, it needs little bit more practice. Now let me just remove that taint property also from here. And this is one of the, troubleshooting step also. Whenever you are, if you see your pods are not getting created, you need to check whether your worker node is tainted or not. Okay, so that comes in the troubleshooting steps also. All right, so I think for today we can discuss up till here. Do you have any question?
Oh, sorry, I have to go through it again.
Yeah, absolutely. So we just need to see this again, right? And we will meet tomorrow then. Thank you.
Yes, bye.
Thank you. Bye. So step 1, we need to verify that our cluster is in the ready state or not. Excuse me. So what I'll do, first I log in with the root user, and then kubectl get nodes. So all the nodes are in the ready state. So in yesterday's lecture, we talked about the taints and toleration. Basically, we were talking about that how to assign the pods to is specific worker node. So when we were basically talking about that, at that time, we have seen that few topics. Means last 2 lectures are basically like that: node name property, node selector, and then node name, node selector, and then node affinity. Right? We have discussed this one. Then we have discussed about the pod affinity. Okay. pod affinity. Then we discussed about taints and toleration. Every topic which is in the Kubernetes is very important. So one or other way it is related to your advanced topics. I would say that these topics which we have discussed yesterday, it comes especially after node affinity. So this comes in the advanced level only, taints and toleration. Okay, so try to as much as practice you can do for these things, because these are not easy to understand, but when you practice it, it will be easy only. All right, so now today we will discuss about one thing which is called the kubelet service. So in the Kubernetes architecture, I have explained you kubelet is basically, it's a service which is running on worker node and master node both, but especially I'm talking with respect to worker nodes. So this is a service. Now, what is the job of this service? In master node, there is a API server. Now, API server is the one who takes care of all the activities in the Kubernetes. For example, you want to create a pod, you want to delete the pod, you want to do whatever activity you are doing in the Kubernetes. So that is basically managed by the API server in the control plane or master node. Okay. Now, consider you have executed a command to create a pod, kubectl run pod and the pod name. So that request to create the pod goes to the scheduler, and scheduler is the one who will decide where this pod will be created. So consider you have given a command to create a pod, and that pod is to be created on some worker node. So that request goes to the API server. Scheduler will say, okay, it will be created on the worker node 1 on the basis of certain statistics. So it checks, okay, which system is less loaded. Let's create that pod on that particular machine, until unless we are having certain conditions where we are bypassing the scheduler, like node name, node selector, right? So apart from those things, by default, the pod will be created by by the API server, and scheduler will decide where it will be created. It can be created on worker node 1, it can be created on worker node 2, and so on. And every worker node is having a service which is called the kubelet service, right? Now, what is the job of this service? Now, API server send that request, okay, worker node 1, scheduler has asked me to create a pod on this particular machine. So API server sends the pod specifications, and that specification goes to the kubelet. Now, kubelet duty is that on the machine worker node 1, it will create a container with the whatever the pod specification we are having. For example, we are creating the Nginx. We are creating something called Nginx pod. Okay. So now when this pod get created, right? So then Nginx pod and Nginx container, right? Because pod is monitoring the container. And this all activity is done by the kubelet. So it means the instruction came from the API server to kubelet, and kubelet is running this on the machine. Let me just show you that one. So I will go to my master server, and if I say kubectl get pods, so you can see no pod. Now I will create a pod, kubectl run pod 1 with the image Nginx. So pod get created. Let us see where it is created. So it is getting created on worker node 1. Let's wait this to be created. Now this is created. Now if I go to worker node 1, right, and here if I say sudo su, so we are running the container just 1 second. I'm unchaining for a minute. All right, so I'm back. Okay, so now what I was doing, I have created a container which is on worker one get created. Now, if I go to worker one, and here we are running the container. How do you know that container is running? So CTR and containers list. Okay, so if I run this, CTRs, what is that? CTR L container container D, right? So let's because I never worked on container D. So let us see how we can see the uh, containers. Okay, so container D and list containers, right? So we'll see that command. So it is okay. This is containers CTR only, container list or LS. Okay, so it is not showing. This is looks like it's not a CTRL containers or PS command. Just let me just check on what is the command for the container D especially. Okay, let's open the chat GPT and I'll say container list in container D worker node Kubernetes. So the command is CRI-CTL. Okay, so this is the command. So I'll say CRI-CTL and PS minus it. Okay, so now here you can see my pod one is running. See, pod one is running, and this is my container which is running with the Docker image. So here you can see this is the, well, let me just decrease the zoom. Right. Now here you can see this is the name of my pod and this is the container ID. This is the I think I need to reduce a little bit more so that it can be easily, yeah, now it is, you can see. So this is my pod one, see, it is running on this machine and this get created. This is a container, okay? This container get created on that particular worker node machine. If I say CRI, CTL and images, okay, so here you can see this image, right? Here it is showing the image ID 204, and that 204 image ID is the image ID of the Nginx only, right? So it means this container is running on this particular machine. Who has created? Kubelet has created. Now, if I say, are you able to see properly this screen? Actually, to
Yes, sir. I can see.
because I want to show in a column wise. Otherwise, that wrapping is happening, so we cannot see the value under that particular column. All right. So now, if I say here, let me delete this particular container. Okay, let me delete this container. So now when I'm going to delete this container manually on worker node, then kubelet is basically keep watching that whatever the pod specification I have received from the API server, whether the container is running with that specification or not. If it is not, then it will create that container again. Let us try that. Now I think the command will be crictl and rm -f and the container ID. Okay, so it is saying stop the container from the runtime. Okay, we'll stop that first. We'll say kill or stop because container D commands are different from the Docker command. Okay, okay, looks like it is stopped. Now I'll say crictl remove this. Now this is removed. Now if I say crictl and container list, right? So you can see that container which is having the container ID 960. Is it here? I don't see. This is removed. But a new pod get created or new container get created when 32 seconds ago. Who has created this? This is created by the kubelet. Because kubelet is keep watching that whatever the pod specification I have received from the API server, so whether my containers are running with that specification. Now what I have done, manually I have deleted this particular container. Now kubelet is watching, oh, that container is not running, and this is the API specification, and it is to be running on this machine, and it creates that on the basis of the pod specification. Now let us do one thing. Let us delete our pod here. kubectl delete pod and pod 1. So I'm deleting this pod. So this pod get deleted. Now the container also get deleted because now kubelet received one more signal that, okay, delete this container from the API server. So it is obeying the order of API server. Now, if I say docker ps -a, and you can see pod 1 got deleted, right? So this way, the kubelet service is working. If I say systemctl status of kubelet service, right? So you can see that this is a service which is active and running, right? So this way, right? So this way we are basically getting the information or kubelet service information, whether it is running or not running. If it is not running, there will be a problem. You will not be able, because it will not monitor the containers running or not, or there are some other activities which kubelet service is doing. It is like an agent on that particular machine. Okay. Now, so now let us talk about one more type of pod, which is called static pods. Static pods. So what is static pod? Now, API server is creating the pod and it sends to the kubelet on that worker node. And on worker node, kubelet creates the container. Right. Now, consider you want something to be managed on the worker node level. See, whenever APIs server get the signal from the scheduler, now scheduler is saying, okay, create this pod on worker node 1 or worker node 2. So API server will send that specification to that particular kubelet, which is running on that particular machine. Now consider there is a worker node 1, and on worker node 1, you want to run some specific thing like you want to collect the inventory log, you want to monitor the system, which is specifically for the worker node 1. Then what we can do, we can create a pod directly on worker node 1. So if you create the pod directly on the worker node 1 and it is to be created by the kubelet service, that is called the static pod. Okay. So let me first show you how we create a static pod. Then, it will be easy to understand the definition. Let us see that one. Now, what I'm going to do here, I'm going to worker node 1 or worker node 2, any of that machine I can go. So let me go to the worker node 1. Okay. In worker node 1, what I'm doing, there is a special type of directory, which is etc, under etc Kubernetes. So if you see here, there is a directory which is called the manifest. Let me go to the master server first and let me run kubectl get pods minus o void. Okay, so there is nothing, no resource form. Right now here you can see there is a directory. I'm on worker node 1. You can just check the host name here. Okay, I'm on worker node 1. So now if I go to this manifest directory, now there is nothing inside this. Let me go inside this directory. Now I will create a file, say nano and pod1.yaml file, or I will say worker node 1 pod. Actually, I'll say pod. What I'll say monitoring pod. I'll say okay, monitoring pod dot YAML file. Okay, so I will create a pod. See, so far we have executed all the commands on the master node, but I am on the worker node at this moment. So I'll simply say API version, which is v1, and kind is pod, and metadata. And here I will say name of the pod is, I'll say worker node 1 monitoring pod. Or I will say simply, I will remove worker node 1. Okay, I will show you that worker node 1 automatically get added. And now I will say specification. Under specification, I have the containers. Consider you are running your monitoring container, but I don't have that image. So I will simply say name of the container is monitoring, and the image is say Nginx. Okay, it could be some monitoring Docker image, but I'm using Nginx. Save it. Nothing we need to do after that. I'm not running kubectl create command. Now, if I run this, now you can see there is one container or one pod is already there. So few things we need to note down. First thing is that you can see that the name of the pod. So the name of the pod, if you see here, which is monitoring pod, right? This name we had given, but after that it automatically added this part -worker node 1. So this is a static pod. This is a static pod because this pod is not created by API server. Who has created it? It has created by the kubelet service, which is running on worker node 1. So that has created. If it is not created by API server, then why it is showing this? So it will be shown by the API server, or you can say it is a mirror copy of that. Okay. Now what we will do, we will see this IP address. This is the pod IP address. Now, if you remember, when I was deleting the pod, normal pod, then what was happening? When I create it again, then its IP address gets changed. But here it is not like that, because this is not maintained by the API server. Even though if I delete this particular pod, its IP address remains same. So let us check that one. So what I'll do here, first I will take this IP address and I will go to my worker node 1, and here if I say curl and this IP address, so you can see I'm getting the Nginx, means my pod is running and I can access it on worker node 1, right? Now what I will do, I will delete this pod. Okay, so this is the IP, right? Now what I will do, I will delete the pod. Okay, so how to delete the pod? kubectl delete pod, and the pod name, you can give this pod name. Okay, now when you delete, immediately it will be created again. See, it is in pending, but it will be created soon, right? See, the IP address is same, exactly same, and it is in the running state. Whenever I have a pod, if I delete the pod, then all the data inside the pod get deleted. Let me show you that one. If I create a normal pod, kubectl run pod 1 with the image Nginx, right? So pod get created. Now, if I say kubectl and if I say kubectl exec minus IT, right? And the pod name is pod 1. And if I say mkdir and I'm creating a test directory. Okay. Now what I will do under this test directory, I will create a file, say touch and some file, say new file.txt. Now, if I say ls my directory, right, inside the pod, this is a normal pod. Okay, so you can see there is a new file.txt file, right? Now, if I delete the pod, if I say kubectl delete pod 1, then what it will do? The pod get deleted. So this data also get deleted because pod get deleted. But now let us do the same thing with our monitoring or static pod. So what I will do, I will go inside my pod, which is the monitoring pod and worker one. Okay, and I will say mkdir and create under root test directory. Okay, so let me just check the name from. So name is this one. Right. So I will say I think problem is hyphen I missed. So that directory got created. Now what I will do, I will create a file inside this touch and I'll say test.txt file. Right. Now what I'm going to do, I'm going to delete this pod, static pod. So kubectl delete pod and the pod name. So pod is deleted. Right. So now we can check kubectl get pod. So again, it got created 5 seconds. Actually, it is not created. It is taking a copy again from the master or from the worker node. See, IP address is same. Now, if this is a normal port, data also get deleted. But here the data should not be deleted. Now, if I say ls and under root test directory, so you can see my file is there because that file is not on the pod which I have deleted. So when you delete, so you are deleting the copy. You are not deleting the actual pod. That's why this file is there. Now, if you see, the name of the pod is also very interesting. Here, up till here, this is the name of the pod. After that, on which worker node it is running. If it is running on worker node 1, it will be worker node 1. If it is running on worker node 2, it will be worker node 2. Now, another very commonly asked question, that why we need it. So initially I mentioned you that when you are monitoring a particular worker node, create a static pod on that. If you want to access the log of a particular node, then you can go with the static pods. Okay, even though those get deleted, it will be maintained by the kubelet service on that worker node. Now, when we talk about the master node components, etcd, scheduler, API server, those all are the static pods. Let me show you. kubectl get pods minus n kube system. Kube system is a namespace. Namespace is a separate topic we will discuss later. Now here you can see there is a kube API server hyphen kmaster hyphen worker node name. So this is running on the master server. Now here you can see etcd kmaster. This is also static pod. Kube scheduler kmaster. This is also a static pod. Kube controller manager kmaster. So this is also a static pod. So all the control plane components which are working as for the master node, all they are the static pods. Now, if these are static pod, they must be in a special directory, which is /etc/ Kubernetes and manifest file, right? So here you can see the definition of all these pods are in this particular directory. So static pods should be under this directory, whether it is worker node or master node. And if someone by mistake deletes or your administrator deletes this particular pod, it will be automatically get created with the same configuration because it is not created by the API server. Let us go to our documentation quickly to understand this one. So let me just go to that one. Static pods. Static pod is a pod that is managed directly by the kubelet, not by the Kubernetes API server. Normally, pods are created using kubelet commands, YAML manifest file, or deployment. These pods are scheduled by the Kubernetes scheduler. Okay, if you are not using the static pods, but the static pods are different. So they are created directly on the node and managed by the kubelet, not scheduled by the Kubernetes, okay, or Kubernetes scheduler. Key characteristics of static pods. These are managed by kubelet. These are created on the local manifest file. These are scheduled by itself, means kubelet only, not by the scheduler. It is on a specific worker node. and only observed by the API server, not create. Now, static pods, normal pod, API server, scheduler, and worker node. Static pod, manifest file, kubelet, and then the pod created. Where the static pod manifest files are stored, these are stored under etc, Kubernetes, and manifest directory. This directory is monitored by the kubelet. Kubelet automatically creates the pod if it is deleted, if uh, that particular pod is created, or that YAML file is inside that particular directory. Example, this is the example similar we have created. Create the static pods, right? And if you put your YAML file into this particular directory, that automatically becomes the static pod. You can verify this the way we have shown that. Now, delete the pod via kubectl. I have deleted, it get recreated. Delete the manifest file, pod will be removed. So what will happen? So if I go to my worker node 1 now, right? And here, if I remove this file, if I say rm and this YAML file, now pod will be automatically get deleted. So if I say kubectl and get pods, so you can see that pod get deleted, right? So scheduler not used. Delete the static pod. To delete the static pod, remove the manifest file, right? That I have done. Why static pods are important? These are mainly used by the Kubernetes control plane component, that which I have shown to you. Excuse me. So you can check the control plane with this command I have executed. Now this is the difference between the real normal pods and the static pods. So these are created by the kubelet. This normal pod created by API server. Scheduler is not used in the static pod. It is managed by the local file. It is managed by the Kubernetes. Now used for the system component. This is used for the application point of view. Right. So yeah. Do you have any question related to static pods?
No, sir.
Okay. Okay. So I hope you understand this concept. Now,
Yeah, I'm getting that.
good. Okay. Now let us talk about the replication now. What is replication? See, let me try to explain with some example. Now, I'll choose just a second. I'll use draw.io. Right. Now, consider that you are having a cluster, right? In Kubernetes, we work on a cluster on it. So this is my, right. So this is my master node, right? This is my master node. And this is my worker node 1. And this is my worker node 2. So there are, our cluster is something like that only. Okay. So now they are basically they are connected to each other, right, through the pod network. Right. So so there is a pod network which is so all are connected with the pod network. Now on top of that, we are having one more network layer. On top of this pod, on top of that host machine network, we are having one more network layer, which is called the pod network layer, right? So where is that pencil? Just 1 second. I'm just searching that. Here you go. Line color, and this is the. Let me see. This one is the one. Okay. So this is my. So let me decrease the. So this is my pod, and this is my pod network. So, or we can use direct. This is the pod network. Okay. Now, whenever we are creating the pods, consider this is the pod which I have created, right? And this pod is created on top of this pod network layer. So this is how basically it works. So this pod is created on top of this pod network layer. Okay? Now consider someone has deleted this pod. Okay? Someone has deleted this pod. So if this pod get deleted, then what will happen? Then application is deleted, data is deleted, everything get deleted. So when we are creating a pod, we want that because some client is using this, right? So some client who is basically, oh, this is not good. Okay, I need to do a little bit more practice on this. Looks like. Okay, I will use it later. I will go to the MS Paint for now. Okay, that will be much better option. So now this is our cluster. And on top of this cluster, this is in the network. And on top of this cluster, we are having this pod network. And on this pod network, we are having a pod running. Now this pod, if it is deleted, okay, if this particular pod, if it is deleted, then what will happen? Then deleted means deleted, everything is gone related to that pod. But I want that if this pod get deleted, automatically a new pod get created. This is called auto healing also. Okay. So if a pod get deleted, then automatically it will create a new pod. It is not the static pod. This should be created by the API server. Then we use a concept of replication. So when we talk about the replication, there are two types of replication concepts we are having. One is replication controller, one is replica set. But let us talk about the replication controller first. It is managed by the controller manager of the control plane component. Okay, so controller manager is managing that. Now, in the replication controller, there will be a desired state. Desired state means how many replicas you want to create. For example, you are saying I need to create 3 pods. Okay, and how many are running, which is the current state. How many are running? Consider there is 1 pod running. So what it will do, it will create 2 new pods with the same pod definition. So the pod definition it picked up from the pod template. So we will define a pod template, and that pod template is the one which is basically creates a pod. So pod template is having the pod definition for the replication controller. So whenever a pod is created by the replication controller, it takes this pod template definition. It takes that and create the pod. Okay. So for example, there is 1 pod which is running. So instead of one pod, it needs 3. So it will create the replicated pod. Now the replication, how it knows that which pod, right? So how it identifies the replication? So what it will do, it will identify by using uh, the labels or pod labels. Okay. So consider for this pod, I have a label which is app equals to Nginx app. Okay. So now, right. So this pod is created. So I need to create similar pod. So how it will identify that pod? With the label app equals to Nginx app. So what I'm going to do, I'm going to copy this particular pod now. Take a copy of this. So this is my first pod, copy and paste. This is my second pod. What is the similarity? It is same because it is having the same label. So label matters. So I want to create 3 pods. So these 3 pods are running with the label app equals to Nginx app. Okay. Now what are the use cases? For example, your pod is running on this particular machine, worker node 1. And now your worker node 1 goes for a kernel update or patching. Then what will happen? This particular machine will be which is my worker node 1. If it is going for patching and if a pod is running without replication, then what will happen? That pod get also it will not be accessible. Okay, but you want, if my machine goes for the patching, then then what it will do? It will basically then it should go to that particular that pod should be created on some other worker node. So that can happen by using replication controller. So if the current state is not equals to desired state, so replication controller make it equal. Okay, so let us take with the example. Another thing is that replication controller you cannot create by using kubelet command, kubectl command. So we need to use the script only. Okay, so let us see that one. So what I'm going to do now, you can use the Visual Studio Code, you can use the Kubernetes documentation. I have already the documentation ready here. Replication controller ensures that specified number of pods replicas are always running in the Kubernetes cluster. If a pod fails gets deleted, replication control automatically creates the new pod to maintain the desired number of replicas. Okay, so desired pod 3, running pod 3. If the pod crashes, desired is 3, replication controller will automatically create the pod to resolve the count. Why replication controller is important? For high availability, for fault toleration, automatic pod recovery, and load distribution. So if we talk about, these are the use cases, right? When you need the high availability, you can go with the replication. When you need a fault toleration means if particular application or machine is not available, then other will take the load and manage the application load. So that is basically the fault toleration. Automatic recovery, right? So if application is down, a new pod will be created on some other machine. And when we are using the load balancing, we need the replication underneath that. Now, example, web application running with 3. If one pod fails, Kubernetes creates another pod automatically. Now, let us talk about the replication controller. So replication controller continuously monitor the pod on the basis of the labels. Now component metadata. So this is the example. So if I take this example, here you can see API version, kind is replication controller. Name of the replication controller, you can give anything. Now here you mention the replicas. Now replica equals to 3 means 3 replicas I need for this. This is the pod template. This is the definition. So in this definition, what I'm saying, metadata, labels, right? So label is important. Now here, this is my pod definition. It is same as we have created earlier, right? So here I'm saying label app equals to web. Specification containers. So I have the name of the container is Nginx. Docker image I'm using Nginx, and it is running on port number 80. So on the basis of this pod template definition, it will create 3 pods. Okay. And this is the selector, which is called the label selector. So now it is how it is monitoring which ports are running on the basis of app equals to web. So it is looking for all the ports which are having label app equals to web. So let's copy this one and let me go to my cluster. Right? Now here I don't have any pod at this moment. Something goes wrong. Okay. My system got disconnected. Okay, somehow. Now what will they? Sudo su. Okay. Now replication controller. Right. So what I'll do, I will go to my manifest directory, and here what I will say, nano and replication controller.yaml file. As I mentioned, there is no command for this. We just need to use the YAML file only. Now let me save this. Now if I say kubectl and create -f replication controller.yaml file, right? So now this get created. If I say kubectl get pods or get replication controller. So here you can see the name of the replication controller. Actually, name of the replication controller is also interesting because the pod which get created, these get created on the basis of this name as the prefix of the replication controller. Now, desired state is 3 because we have mentioned 3 replicas. Currently 3 are running. 1 is ready. Let us see again. So 3 are ready. All are ready. And 30 seconds ago it got created. Now let us see kubectl and get pods -o wide. So there should be 3 pods. See, all are started with the replication controller name and then hyphen some random value. So these are in the running state. 2 are running on worker node 1 and 1 is running on worker node 2, right? And these are the IP addresses of my pod. Now I want to check whether really it is created by the replication controller or not. How do you know? Kubectl and describe replication controller, which is Nginx replication controller. So here you can see these are the events which basically takes place by the replication controller, and it is saying yes, I have created this. See the name 9xLRR6, 9xL RR6 and third one, right? So all get created by the replication controller only. Here in the describe command, you can see some more properties. This is the pod template, right? And this is basically having the pod status. 3 are running and 0 waiting, 0 succeeded, 0 failed. 3 are the current and 3 are the desired, right? So this is fine. Now, what I will do, I will delete a particular pod and we will see whether replication controller will create that pod or not, right? So let me delete one of the pod. If I say kubectl delete pod and pod name is considered 9xl, I'm deleting. Now this is deleted, right? Now if I say kubectl and get pod, a new pod should be created. See, 6 seconds ago, a new pod get created, 9xl, this pod got deleted. And this pod is in the running state. Who has created this? Again, we will check the describe command, right? So here you can see a new pod get created by the by the replication controller. Deletion, it is not done by the replication controller. That's why it is not recorded here. Right? So it will maintain the replication controller maintains the current state equals to desired state. Now, next thing is that how do you identify that all the pods are running with the replication controller? One way is describe command. Other way is that you can first check kubectl get replication controller with a label app equals to what we have given here, app equals to web, app equals to web. It will show all the replication controller which has the label where we are defining here. You can see um, selector app equals to web, right? So this is the one which is having the label app equals to web, right? Now I want to see all the pods which are having label app equals to web. So there are three. Now consider if I create one more pod kubectl run and pod one with the image nginx. So this pod get created. Now you can see here it is not showing pod one because its label is different from the app equals to web, right? So this way we can use the replication controller. You can also say that, if you want to see double equals to, this will also give the same result. Equals to or double equals to you can use. You can use not equals to. Not equals to, it will show all the ports where app is not equals to web. Okay. So pod one is the one which is not the matching label pod, and so it will show all the ports which are not equals to the pod which is having the label app equals to web. Okay. Now you can scale also, scale the replication controller. How to automatically scale that we will see later in our horizontal pod auto scaling. But if we want to scale manually, so scale the replication controller. So if I say kubectl and scale my replication controller, and the name of the replication controller is this one, and how many replicas you want to increase or decrease. So increase means total number of replicas. If I want 5, so it means now 5 pods will be running with the label app equals to web. So we can check that, right? So now you can see there are 5 pods are running, right? Now, if you want to scale in, means you want to make it again 3. So what it will do, it will delete the pods, right, which got created, right? So new pods get deleted, and now here you can see there are 3 pods are running. So you can scale out or you can scale in also. So if you think that if this replication is used in the background of a load balancer, and you think that we need we need more replication, so you can scale out that also. And if I delete my if I say kubectl delete replication controller and the name of the replication controller, if I delete this particular replication controller, then what will happen? It will delete the replication controller as well as it will delete the pods which are related to this replication controller, right? So now if you see all the pods which are related to this get deleted, only we are having that pod one, right? Let us go to this replica 3 selector, right? Template. So we have created, I have executed all these commands. We have deleted a pod and we have seen it is running. Scaling also we have seen, and deleting. Limitation of replication controller. This is the old Kubernetes concept and it is equality based. Modern replacement is replica set. So let us talk about the replica set first, right? So what is replica set? So replica set is doing the same work as replication controller is doing. Means current state should be equals to the desired state. But what is the difference? The replication controller is if we talk about the replication controller, this is equality based. Okay? This is equality based. What is equality based means? It is using the equals to symbol only. Okay? Say an example. I'm saying where label equals to value, right? But replica set can use the set based operator. Okay, set based operator. What is set based operator? So these are something like in operator, not in, exists, the one which we have discussed in the node affinity or pod affinity, right? So those operators can be used. These are called the set based operator, and that we can use in the replica set. Okay, so let us see that one. So here you can see this is same. Why replica set is important? Same way, right? Concept is same. Okay. Now we will talk about this replica set. We will create a replica set. Okay. Same thing as we have seen earlier. Okay. And now it is exactly same what we have discussed. But now here we are using something different. There we have used selector app equals to web. But here we can use the expressions also. Like here you can see match labels app equals to web. We can use the in operator. Let me see whether that example I have. Okay, it is not here. Let me just go to the Kubernetes documentation. Replica set Kubernetes. So we'll go to the Kubernetes documentation. And here you can see I have two labels. Let me take this example. This will be more relevant. Okay, no, this is only match label. So I'm just looking for the match expression syntax. Or I have that example. Let me go to my other website, which is devopsworld.co.in. And if I go to the Kubernetes, and here you can see the replica set. And this is the difference which I was talking about. It's a set based in, not in, exist you can use. For example, if you are searching something where label app equals to production, here I'm using equals to I can use with the match labels, and match expression I can use something like this. Key is the tier, operator is in, value is equals to front end. Let's take this example. Okay, so this is my replication controller, replica set. Let me copy this and let me go over here. And now I'll say nano and replica set dot YAML file. Now here what I'm saying, this is the name of my replica set. Kind is replica set. Now see the API version is different. Apps/v1. Earlier, so far it was v1. For replica set, it is apps/v1. Now this is the pod template. In the label section, I am creating two labels. You can create one label also, right? But label is must. One label at least you should have on the pod definition, because that is a selection criteria. But I use two labels, right? And now here I'm saying the container. This is Nginx container running at port number 80 and match label. So match label is the selector equals to where app equals to Nginx app. So this should be matching with this. And second selection criteria is the where key is the tier. So these labels can be user defined labels. Okay, key and value pair. So here key is tier, operator is in, and value is front end. Okay, so that is also one of the criteria to find the pods. Now what I will do, I will save this. Now I will create the kubectl create -f and replica set.yaml. So concept wise, exactly same whatever we are having in the replication controller, but it is a set based. If someone asks what is the difference between replication controller and replica set, so you can say replica set is the next generation of the replication controller. Okay, most of the uh, resources in the Kubernetes, they use replica set in the background for the replication point of view. Like deployment uses the replica set, and the daemon set, it is using replica set, right? Like that. So now if I see kubectl get pods, so you can see there are 3 pods are running. That scaling, deleting that part you can try by yourself, because you need to delete a pod and you need to see it is automatically coming up. Okay, that thing you can try by yourself. Now I want to show something kubectl describe replica set and the name of the replica set. Now here you can see there are 3 pods get created. Now here you can see the selection criteria. It will check all the pods which are having app equals to nginx app. So I can say kubectl get pods -l app equals to nginx app. Right? So see, it is showing all the ports which is related to replica set. Now, second criteria, second way you can use the in operator. Here you can see, I want to see all the ports where tier in front end. Okay, and how it came, because in our code, we have mentioned where tier in front end, right? So we can compare this also. Now, if I say kubectl and get pods where label, and in single quote, you need to mention that tier in front end. It will again return you the same. So we can use in operator, which we cannot use in the replication controller, right? So this is how the replica set is used. And again, you can scale out and scale in. Same, you just need to say kubectl scale replica set, and the replica set name hyphen replicas equals to 5, 3, same way as we have used in the replication controller. So I would suggest those commands you can try by yourself, because it will be the, if you repeat it, then you can, have a comfortability to use these commands. Now, if I delete kubectl, delete the replica set, which is the nginx replica set, it will delete all the ports which are related to the replica set. So if I say kubectl get pods, see all the ports which are related to the replica set is deleted. Now let me delete pod 1 also, kubectl delete pod and pod 1. Okay, so this is how we use the replica set. The short form is RS, right? Okay. Now replication is having the extension with the deployment, daemon set, and stateful set, right? And furthermore concepts like jobs. So I think for today, we have discussed that static pods, replication controller, and replica set, right? You practice these topics. And do you have any question?
No, sir.
Yeah, good. Okay. So then let's wind up today's session here. And tomorrow we will discuss about the deployment, daemon set, these 2 topics.
Okay, sir. Fine.
All right.
Yep.
Thank you. Bye bye. Talk about the Kubernetes deployment. Kubernetes deployment. So first of all, we need to know what is deployment, and so far whatever we have discussed, is it not the deployment? Okay, we have discussed about the replication, we have discussed about the pod. So that is not the deployment, first of all. So deployment means that you want to deploy your application, full-fledged application. What it means, you need the application so that, you know, when you deploy your application, it should be replicated, right? Means there are 2 ports, 3 ports, 5 ports, whatever number of ports you want to run. So, right, so that should be running with that desired state. Then you want that if I want to do a rollback, so far in the replication or in the pod, we never talked about the rollback. So I want to do a rollback. I want to do the rollback. I want to update also. Okay, I want to update from one version to another version. So these things are included inside the deployment. Okay. So all those things you can put it into the deployment. Okay, so let me go to my documentation once. So if I go to github.com, and if I select this master and DevOps, and Kubernetes replication, that manifest files I have added here, all the manifest files which we have created so far, right? So you can refer all the manifest file from here. All right. So this is the reference for your, means you need not to write. I would suggest that try by yourself, but if you need a reference, you can download it from here. Right. So it's during our training, whatever the manifest I'm using, so it is in this folder. Right. Let me see my notes. Deployment. So deployment is a Kubernetes object used to manage the replica set and the pods. It provides pod management, rolling updates, rolling back capability, self-healing because of the replication, and scaling. So all those things are included inside the deployment. So just 1 second. One thing I just want to discuss here. Okay. So there is something called blue-green deployment. What is blue-green deployment? See, basically what I want, consider this is my cluster. What happened to this mouse? So consider this is my cluster, right? Where I have master node and I'm having the worker nodes. Okay. And on top of that, I have my pod network plugin. And on top of that, my pods are created. So this is my pod 1. Consider this pod is created with the replication. And deployment is using replica set for the replication point of view. And let's fill it with blue color. And let's name it as V1 version 1 pod. Now it is having some label, say an example. it is having label app equals to Nginx app. Okay, so this is the label for the pod level. Now, similar way, I have considered 3 pods which are running. This is my pod 1. This is my pod 2. And this is my pod 3. So 3 pods are running on top of this pod network. And all are running with version v1. Right? Now, there are some questions which differentiate deployment with the replication only. See, basically what happens if you say that, okay, I want to run my application with the high availability, so I will run with the replication controller. I don't need the deployment replication controller or replica set only. But what will happen if you want to update this particular pod, right? Consider this is of green color. And it is running with version v1, v2. It is not visible. Version v2. Okay, I want to update with version v2. Okay. Then what will happen that this particular pod, if I want to update and consider my client, here is my client who is accessing this. Here is my client, right? And client is accessing this application version v1. Okay. Now, when he is going to access this particular application, then let's put it here. So, client is accessing the application, which is running with these. So, first of all, if client is accessing this application, right, then if there are multiple requests, right, if I use only the replication, then replication controller will not distribute this traffic to the other pods. Replication will create the pods, but it will not suggest that distribute the traffic automatically to the other replicated pods. So that is one problem. Second problem is that whenever you are using this this particular client is using this v1, and consider I will remove this, or maybe something happened and this pod get deleted. So the request will not automatically goes to the other pods. Maybe you can write some custom solution, but by default it is not there. That is the another thing, right? So that is why we need two things. One is definitely deployment, and second is called service. Service we will discuss after deployment. Now, we have seen that Google is always up. Facebook is always up. ChatGPT is always up. Reason? They are using Kubernetes. And in Kubernetes, we can maintain a zero downtime. Okay. This is the, you can say requirement for each and every client today. They want zero downtime. Okay. Zero downtime. Zero downtime means what? I have shown you earlier that AWS or Amazon releases per uh, per second, per hour or per day, it is 126,000 times. And that can be only possible with the help of the DevOps or the Kubernetes containerization, container orchestrations. Kubernetes is a container orchestration tool. So we can manage zero downtime along with the updation of the application. Now consider if we are not using the Kubernetes or if we are not using the containerization, then what will happen? You are running a container with version. Consider you are using containerization, Docker or Containerd or any other container runtime, and you are running with that application, and consider that you you have the 100% availability all the time. So you are saying we are having 24/7 team, those who are, you know, keeping their eyes on that glass, and they are saying that application is always up. As soon as it get, it get container get deleted, we immediately brings it up. That is good. Now the requirement comes that you need to change the Docker image, or you can say update the version of that particular container. So in that case, what you need to do, you need to shut down the existing container and you need to bring up the another container. Okay, that needs a downtime, maybe few seconds, I don't know, maybe minutes, maybe hours. And client says that I don't want that downtime. If my customer is paying, or my end user, if he is on the payment page, and when he pays when he was in his transaction, so my transaction should not be it should not be failed because of your updation. You are updating from version V1 to V2. How do we maintain that? How do we do that? With the help of the deployment. There are different rolling update strategies. Okay, there are some rolling update strategies. So let us talk about that rolling update strategies. So rolling update strategies. So what this rolling update strategy is, that there are two main parameters. One is maximum unavailable pods, and second, maximum surge pods. Okay, maximum surge pods. So this tells that whenever you are doing the updation, how many pods will be maximum unavailable. For example, by default, it has the value which is 25%. Okay, this is a default value. Now, you want to update this value, you can update that also. Okay, if you say that I need 50%, I need a number also, I need only one pod, and maximum surge is also 25%. This is the default value. Let us understand what does it mean. Now consider, I'm considering one pod is to be updated at a time. So now here basically what happens, that I want to update a version V1 with version V2. Okay, updation means what? We need to update the Docker image. Okay, that is the meaning of the updation, right? So this is my version V2. So first of all, V2 is to be created. The new pod is to be created before updating. So I will try to demonstrate you that there will be a zero downtime. Okay, and let me try to show you that one. So this is version V2. So I want to update all these V1 with V2. Okay, so then I will use the rolling update strategy. In rolling update strategy, what will happen? That this is my pod V2 first it get created. If this V2 is not get created, so there is no impact on these V1 pods. Okay, there is no impact on the V1 pods. So that is one thing. Second, consider this is created properly. Then what will happen? I will take one pod at a time to update. So it will go to the version, it will take this V1 pod, okay, and it will not touch any other V1 pod. It will take randomly one of the pod. It will take that pod and it will update with version V2. Once that is updated with version V2, now client request goes to the either V2. Okay, when this is updating, how the updation works, V1 will be deleted and V2 will be created. Okay, it updates like that. So if V1 is deleted and V2 is created, right? So there is something called grace timeout. Okay, so every pod which is getting deleted, they are having a grace timeout. Grace timeout. What is grace timeout means? Grace timeout means, for example, there is something which V1 pod, the one which is getting deleted, it is processing some request. Okay, and if that particular request is taking time and now V1 is to be replaced with V2 during that time. So now there will be a grace time out, which is by default, I think 30 seconds. Okay. So for 30 seconds, means when V1 is getting deleted, it will take 30 seconds more to process that pending request. You can change this value if you think that uh, it takes 60 seconds, it takes in seconds, you can put that value. Okay. So now V1 is updated with V2. Now, one more thing we need to consider whenever we are using the containerization. So our changes should not be big changes. Okay. It is not like that version V1 is entirely different from version V2. You can do that, but that's not a good practice. Good practice is that minor change in this way, that if my V1 is running with V2 in parallel, so it should run. Okay, so if client request goes to V2 or V1, right, client should not see the difference. Let me give you some example. When we are on the Google search engine, we see a doodle, right? So you are seeing a doodle and I'm not seeing a doodle, for example, because they are doing some updation. No, doodle is not making the much difference if it is showing differently to you and differently to me for a few seconds. Okay, so it means my V1 means you are using the previous newest version and I'm using the previous version. So in that case, I would say that my V1 and V2 they can run in parallel. So that's why microservices are more suitable for the containerization, microservice kind of applications. So if your application is, uh, you know, if your application is running in parallel, that in parallel with the previous version, okay, that is the requirement. So that, client should not face any downtime, right? For example, you are saying I'm going to add a new column to my database, okay? That is my change. That is my V2 change. In V1, that column does not exist. Now, you need to plan accordingly that if your deployment is failed, it should not impact to the client. Okay, So maybe you will create that column as a optional column first, right? Then slowly you can uh, make it as a required column, right? So something that you need to do, but that is more on the programming level, those programmers, those who are writing the code. But you as a DevOps engineer, you need to make sure whatever the changes are coming, these are the changes which can run in parallel with the previous ones. That's a best practice. Now
So
here
what is
V1
Doodle?
is a Doodle.
Do-
Okay, Doodle. Yeah. So Doodle is on, if you go to Google, right? So sometimes you see here some uh, something, right? With, for
Animation type.
example, if it is, yeah, something like if it is 15th August, it will show
Okay,
independence,
okay.
that kind of image. So that is Doodle.
Okay.
Yeah. Right. Now, um, now here V1 is deleted and V2 is updated with that one. So V1 is updated with V2. Now, once it is done, now client request can go to the V2 or V1. Now, there is another request, not request, actually another step. Now it will take the another pod and it will delete the existing pod and delete the existing pod and creates a new pod. And same process will happen to the third pod, right? And how it is happening on the basis of these maximum unavailable. So here 25%, consider I'm running 4 ports. So 4 port, 25% is 1 pod. So 1 pod will be updated, means unavailable at a time. And 25% says one will be created, right? And I will show you this practically also. So this way, what we are doing, we are maintaining zero downtime. Means client will not face any downtime during the process, of updation of the versions. Okay. So that is the one of the beauty of Kubernetes deployment. This process is called blue-green process. Okay, so this process is called blue-green process. That's why I have shown you the blue, I have shown you the uh, green, right? So this is a blue-green process.
Right, so.
You understood this process theoretically?
Yes, sir. Absolutely.
Right. Now we can also do a rollback, as I mentioned. We can also do a rollback. We can also do a updation, right? Update with the rolling update strategies. And what else? We can also scale out whenever required. Scaling we can do, scale out or scale in. So let us see this, okay? Practically. So what I'll do, I will connect to my master machine. So step number 1, we need to check that our cluster is in the ready state or not. So I'll say sudo su first, login with root account, and I will say kubectl get nodes. Okay, so that should be our first step. Now everything is in the ready state. Now first I will see, is there any pod running? Kubectl get pods. Let me delete this pod. Kubectl delete pod 1. Right. Now I will say kubectl and get all. It will show all the things. I have only one service running, which I have not created. We will talk about this service. This is created by Kubernetes itself. Okay. So it means nothing is running. Now what I'll do, I will create now deployment. You can create using command or using you can use the command, or you can use the manifest file. If there is a command, we can create the manifest file also. So first, let me show you how you can create a deployment by using command. So I'll say kubectl and create deployment. So what we will do, we will take one of the we'll take one of the Docker image from hub.docker.com. Okay, and I will search for the Nginx Docker image, official image, and these are the versions. So consider I will take any one of that version 1.28.2. So I'll say kubectl create deployment. Okay, and the name of the deployment I will say Nginx deployment, okay? And with the number of replicas, right? So replicas I want to create 3. I need to use the image which is Nginx colon 1.28.2. Okay. And number of replicas I want to use kubectl create deployment. I think it is. So my deployment get created. Right? We will double check now. Kubectl get all. So now you can see that this deployment, this is my deployment, right? So this deployment, it is not in ready. Let me run it again. Right. So here you can see this deployment get created. Now this deployment is having 3 desired state, 3 current state, means it has created 3 pods. And here on the top, you can see these are the 3 pods. Okay, just now it got created 17 seconds, 16 seconds ago. Right. Now this deployment is having, if you see these pod names, see it is Nginx deploy, which is the name of this pod, sorry, deployment. And what is this number? This deployment has created a replica set. So see, this is the replica set. And this replica set is started with the deployment name hyphen and some random value. So this replica set has created these pods. If you want, you can double check this replica set. Okay. So if I say kubectl and describe replica set, just this one. So you can see all these pods get created because of this replica set, and this replica set get created because of the replication controller. Here you can see it is saying something. It has label app equals to my deployment name. Label we cannot create with the command, and also you can see it is having some template hash value, and that hash value is this one. So that is the name created for the replica set. Okay. So this is one way you can create the deployment by using command. Okay. Another way is you can create with the manifest file. So I will try to create the manifest file by using command only. So first of all, if I say delete deployment and my deployment name, then what it will do, it will delete the deployment, and deployment will delete the replica set, and replica set will delete the pods. So it means if I say kubectl and get all, so you can see there is nothing here because we delete the deployment and all are linked with the deployment. Now, as I mentioned, let me go to a CD manifest. Let me delete all the manifest file because I have already uploaded on the GitHub repository. Right. Now, if I say ls, there is nothing. So what I will do, I will repeat that command, right? And I will just say hyphen hyphen dry run equals to client minus o YAML. Okay. So this is the manifest file. I will put it into a file. Okay. So I'll say greater than deploy.yaml file, or I will specifically say nginx deploy.yaml file. Okay. So now if I go to this nginx deploy.yaml file, I need to modify something. I want to give my label app equals to, I will say nginx app instead of deploy. Name of my deployment will be this one. Replica is correct. Now, because it is using the replica set in the background, so that is why you see here the API version is app/v1. This is the same in the replica set we have used. And similar way, you can see match label, means it is, you can use the match expression also, because this is the replicas, it is using replica set in the background, right? Now, next is that, next is all right. Next is the rolling update strategy. Here it is not mentioned, but we can see that rolling update strategy, which is the maximum update and maximum, search, right? So those values, and this is a port template for the replica set. Few things I don't need at this moment. I'm going to remove that one. So what I'm going to remove, I don't need status. We will see the status. Resources means memory and CPU limit, and strategy also, if you don't mention, and rest of the thing looks fine to me. So what I will do, I will save this file, and I will say, I will create now at this moment kubectl get all, there is nothing. Now what I'll say, kubectl and create -f and nginx deploy.yaml. So it has created my deployment. Let us double check. kubectl and get all or get deployment. So you can see there is a deployment get created, right? And it is having 3 out of 3, right? 3 pods which are 3 out of 3 means 3 pods are running. Okay. Rest of the thing is same as I explained earlier. Now, if you want to see more about the deployment, so what you can do, you can run kubectl describe deployment and the nginx deployment. Okay, I want to see this deployment. So here you can see this deployment has created a replica set, right? And that replica set further created the pods, right? And currently it is using the Docker image, which is this one. There is one more interesting, this is the rolling update strategy, which I was talking about. As I mentioned, if you don't specify the rolling update strategy, then 25% maximum unavailable and 25% maximum search. This is the default value, but I will show you how you can change it. Now, here you can see underneath this deployment, there are 3 desired, 3 updated, and 3 total, and 3 are available and 0 unavailable pods. Now, how it will select the pods? It will select the pods. This is the selector. It will select the pods on the basis of app equals to nginx. Oh, sorry. This is the. Okay. 1 second. I did not change the pod label. I need to change the pod label. Let me do one thing. kubectl delete -f and nginx deployment. Now let me open this nginx deployment. So here this name, and here I need to change. I will say nginx app. Okay. So what I'm trying to say here, that my pod will be created with the label app equals to nginx app. Now let me save this. And now let me create this. There is something wrong. Here also I need to change. Okay. This one you can make it. This is the label of the deployment. And this is the label for the pod. And this is the label selector. Okay. So here means if you want to put the label, this is fine. Or if you want to put deploy, that is also fine. Okay. I will keep all same. Now created. Now if I say kubectl and describe my deployment, which is Nginx deployment. Name I did not change. Okay. So here if you see now the pod template, right? Pod label is app equals to Nginx app. Right. Same way. You can see here app equals to Nginx app. This is the label selector. Means on the basis of this label, it will select the pods. Now there is something called annotation. Annotation is same as labels, but it represents some predefined values. For example, here it is saying Kubernetes, your deployment revision. So far we have implemented one time. There is one time change happened to this particular deployment. So this is 1. If I update again, it will be 2. Then if I update further than 3, 4, and so on. Okay. So now, right. Now, the next thing is that I want to update the deployment with a new Docker image. If you see here, my container name is Nginx. Okay. So I want to update this image with some other Nginx image, maybe latest, or we will take some other versions. We'll take the 1.29.6. Okay. Now here, if you see, the image is this one. Now first, let me show you the rollbacks way. Rollback. Right. So here, what I will do, I will deliberately update the version with a invalid Docker image, and I want to show you that there is a zero downtime. Okay. So now how I will do that. So I'll say kubectl and set image for my deployment, which is Nginx deployment, and I want to update the image of my Nginx container, and I want to put it Nginx colon 1.92, which does not exist. Okay, so what it will do first, it will create a new pod with this image which does not exist, and it will be in the you know it will show the error, but it will not impact the already running containers or pods. Okay, so when I run this, it is saying updated. Now if I run the command kubectl get all, so now here you can see that there is one more replica set get created. You see here a replica set get created, and it is saying desired state 1 because initially 1 get created, but it is not in the ready state. And here you can see this is the my second deployment, right? Second replica set, and this is showing the error image full. So it means this is an error. So we should not update our existing pods with this image, and you see my other ports are in the running state, right? So it means, right? So it means I need to do a rollback. If you want, you can check the logs of this particular pod. So you can say kubectl and logs of this particular pod. So here you can see that it is saying I'm waiting to start, image cannot be pulled. So now you clearly understood that there is a rollback, right? So rollback required, right? So because there is a image error. Error image pull is a very commonly known error, which is basically saying image is not a valid image. Now what I need to do, I need to do a rollback, and my other pods are keep running, right? So you can see other pods are last 3 minutes 12 seconds, these are running. So what I will do then, I will roll back this change. So kubectl and rollout status, also you can say rollout status for your deployment, which is the Nginx deployment, right? So it is saying I'm still waiting to roll out changes 1 out of 3. Means I have not updated even 1. Okay, so I have created 1 pod, but it is not updated so far. Okay, so Control C to come out. Now I know that now it's a problem. Then echo $question. This is called the exit code, right? When this is Linux command. So this is the exit code, and it is saying, okay, exit code is 1, means something went wrong. That is why exit code is non-zero value. If it is 0, means everything is fine. For example, if I run something here, echo hello Kubernetes, and now if I see echo $, 0. So 0 means yes, your previous command get executed successfully. But my previous command, which is the status command which I have executed, it did not execute successfully. The reason is because rollback. So that we can take as a input exit status. It means in our CI/CD pipeline, we can say if the exit status is 0, then proceed, otherwise not. Okay, something like that we can do. Now, here, yeah. So now what I want to do, I want to do a rollback. Okay, so let's roll back. One more thing I just want to show you here, kubectl describe and my deployment, which is Nginx deployment, and I want to show you the image. See, images update, current image is using this one. Okay, and also you can see 3 desired, 1 updated, 4 total, 3 available, 1 unavailable, and revision you can see it is the second revision. Okay, so now we need to do a rollback. So I'll say kubectl and rollout and undo. Okay, and my deployment, which is the Nginx deployment. Okay, so I have done the rollback. Now, if I say kubectl and describe my deployment, now you can see my image is the older image, and everything is get recorded here also in the events, whatever changes I have done. Now it is saying your this replica set is set to 1 to 0. Okay, and here now revision is 3. See, revision is 3. Right? If you want to update this rolling update strategy, what you can do, you can write in your YAML file also, or you can say kubectl and add it deployment, which is the Nginx deployment. Right? So you can come over here and you can see that you see the strategies. Here you go. Strategy, rolling update. And if you want to update, you can, means in your YAML file, you can write under strategy, or if you want to modify on the runtime, so that also you can do that. Right? And there will be a grace timeout also. Grace time. Grace time will also be there. Yeah, termination, grace period second. So the property is the termination grace period second. By default, it is 30 seconds. And also, if you want to put it into your pod definition, so that also we can do that. So 30 seconds is the time when it can finish before terminate. It will finish its pending processes. Now, so this is done. Now I want to do, if I search this kubectl and get all, so you can see that pod get deleted. This is created 9 minutes ago. And see this replica set, it is updated with the 0, right? Because earlier it was 1. Now if you want to delete this particular replica set, that also you can do that. So if I say kubectl and delete replica set, which is this one, okay? So now, because I know this is a bad replica set, I need not to implement it in my future also. Now, next, what I want to do, I want to update with a correct version now. So now I will say kubectl and set image, and we will take the valid image now, which is 1.29.6. So I'll say 1.29.6. I want to see that the way I have explained you update version v1 with the v2 with not in one shot, but there is a gap between them on the basis of the rolling update strategy, whether it is doing in that way also or not. So now if I say get all, so you can see it is not updating in one shot. So this is still running, which is 11 minutes ago it got created. This is terminated, and see this one, which is 6 seconds ago got created. 2 seconds ago it is in the creation state. And here you can see new replica set get created 6 seconds ago, and current state is 2, desired state, ready is 1, because it has the that grace out time also. So if there is no pending, it will be terminated before that also, right? Now, so now if you see, if I run the command again, kubectl get all, so you can see my new pods get created. See, this is 43 seconds, 47 seconds, 39 seconds, right? And this is 11 minutes ago, the replica set which got created. Now it is having value 0. And the one which is created just now, it is 3 desired state and 3 current state, right? So see, this replica set is 787, which is the new one, and old one is 77B. Okay, so now let me just zoom in a little bit. Now, if I say kubectl describe deployment, which is the Nginx deployment, right? So you can see here, this is the earlier case when we updated with the wrong version up till here. Now, as I mentioned, first the new pod get created, which is to be updated. So here you can see a new pod, new replica set get created, or new pod replica set from 0 to 1. Then it is because it is created successfully, that is why it is going to update this particular replica set from 3 to 2. So one pod is removed, okay, and one pod is already created here. So 3 by 3 ready state. Then it has created one more pod for the new replica set 1 to 2. And the old pod is reduced from 2 to 1. New one is created 2 to 3. And this got created 1 to 0. Means new replica set totally replaced the old replica set. And you see here, this is 90 seconds ago, this is 86 seconds ago, 83 seconds ago. So it is not immediately. It's not, it is not something like that, which is in one shot, everything get updated. It is updated in the in this way that there should be a 0 time. Do you understand this?
Yes, sir.
Okay. So this is how deployment rolling update strategy works, so that we should maintain the zero downtime for our client. Okay. Now, next is that consider uh, right. So you want to scale out. So scale out also we can say kubectl scale my deployment, which is the Nginx deployment, and I want to scale out with the number of replicas. Equals to say 5. So now the desired state is 5 now. Kubectl get pods. This is 5. Okay. After DevOps, there is something called GitOps. Okay. GitOps, MLOps, right? So these are on the basis of this, changes which we are doing in the Kubernetes. See, whenever we are talking about the CI/CD pipeline, so CI/CD pipeline is something which is, you know, it's not a triggering point for your CI/CD pipeline when you make the changes in the Kubernetes manifest file, or maybe like I'm updating desired state. There, GitOps comes into the picture. There we talk about the Argo CD, how to manage our these YAML files into our GitHub repository, and they need to maintain. That is our next level after DevOps. Okay, GitOps. So now here you can see total 5 pods are running, and same way you can, if you want to reduce, you can reduce to 3. Now it is 3. If I delete my deployment, if I say kubectl delete deployment and the Nginx deployment, then it will delete the Nginx deployment will be deleted. Okay. Now, if I say kubectl get all, everything get deleted. Let's go to our documentation. So this is the blue-green process which I have explained to you, right? And you can just walk through this example also, right? And this we will discuss in. There is something called canary deployment. What is canary deployment? Canary deployment is something like in the same way, but here consider you are updating with version V1 to V2. Okay? And now you are saying, I will update only one pod or maybe 10% of the pods. Then later, I will update if everything. So I will say, hey, client, some minor changes are done, and it is not updated in all the pods. It is updated in 10% of my deployment. 90% are still running on the older version. Just check everything looks fine, or you as a DevOps engineer, you want to check everything is fine as per the client requirement. And if everything looks fine, then you will update gradually the another set of pods, another 90% of the pod. So that is called canary deployment. And this is one of the interview question all the time. What is the difference between canary and the blue-green process? So
Can we say, suppose we are doing some changes in like V1 to V2, and V2 we are not rolling out for all the customers, like in the small percentage. So that can be also candidate deployment.
yes.
Okay.
So here you can see V1 and V2 small percentage, then monitor, increase the replicas, and then full rollout.
Same.
Okay. So here Do I have the definition? Let me see. Canary deployment releases the new version of the small subset of user first. Example, 90% of the user, they will use the old version and 10% of the user will use the new version. If stable, then rollout continues. Okay. So this is blue-green process. So you just walk through this document. Whatever I have discussed, everything is here. Undo. History command, just it will show what are the commands we have executed. Status command, set image command. You can update with the version which we have used. Rolling update strategy. All right. So that is all about the deployment. Let us talk about one more thing, which is daemon set. Okay, it's not a big topic. That's why I want to cover it here. So daemon set is what? Daemon set has a different use case. Now consider that you are having a requirement that you need to install antivirus on all the machine by using Kubernetes. Okay, you need to install antivirus on all the worker nodes on your machine. So in that case, we use the daemon set. So daemon set, what it will do, it will run, and you can say definitely run. Okay. Certainly it will run one and only one pod on each and every machine. If you put a condition like it should run on environment equals to production, it will run on environment equals to production on each and every one and only one on every node. Okay. And in the background, it is using the replica set. Okay, it is using the replica set to create these pods. And desired state is that number of worker nodes is the desired state. Okay, so let us see that example. There is no command to create this daemon set. We need to use the YAML file. So I will say vi and daemon set.yaml file. Okay, so what I'll do, I'll just take that definition from here. Right. I'll take this definition. I'll copy this. I'll paste it here. Now you can see my daemon set name is Nginx daemon set selector. This is the pod template. I want to run Nginx, or we will call it as a antivirus daemon. Okay, something. Even though we are not using the antivirus, but for just with the name at least we can see. And my label also will be, say, I'll say app equals to antivirus pod or antivirus app. Here also I will say match label, which is the antivirus and app. Okay. In the background, it is running Nginx, but in real time, you can use the real antivirus Docker image. Now what I'll do, I will save this. Now I will, if I say kubectl get all, so there is nothing running. But when the daemon set get created, it will not show you the replica set because replica set is running in the background. So now if I say kubectl and create -f daemon set.yaml. So what it will do? It will create the daemon set. So how many pods we are, how many worker nodes we are having? 2. So desired state will be automatically 2. So if I say kubectl get daemon set, so you can see desired state is 2 because there are 2 worker nodes. Current state is 2, ready is 2. Fine. If I say kubectl get pods, minus override. So each pod will be created on each machine. See here, one is created on worker node 1, other is created on worker node 2. If you delete any of this pod, for example, if I delete it from here, then it will not create on the worker node 2 because I'm deleting worker node 1 pod antivirus. One and only one is to run on each machine. So it will create again on the worker node 1. Let us check that. If I say kubectl delete pod and the pod name is this one. So this is deleted. Now if I say kubectl get pod minus override, so you can see new pod is getting created on the worker 1 only. Okay, because it will be looking for the number of each means each pod is to be created on each worker node. Do you understand this concept?
Yes, sir.
So this is the one which is the daemon set. If you put a condition, for example, if I say kubectl get pods, get nodes, hyphen show labels. Right? Consider environment equals to staging. Okay, I want to run on all the machines where environment equals to staging or environment equals to production. I don't want to run on the other set of machine. So what I will do, I will go to my daemon dots and here in the pod definition, I will say here, I will say that node selector. So it should be in the same alignment with the container node selector. And I will say environment equals to staging. Now the desired state is 1. Okay. So if I say kubectl apply minus f daemon set dot here. Okay, it is configured. Now kubectl and get daemon set. Now see desired state is 1 because it is only running on the worker node 2. If I say kubectl get pods minus o wide, so you can see it is only running on worker node 2. Worker node 1 is deleted because I put a condition that run only on the staging machines. Do you understand this?
Yes, sir. Yeah, clear.
Yeah. Let me run the history. We need to delete this also. Kubectl delete daemon set. So I'm deleting the daemon set. And let me run the history command and share this history of commands with you. Um, let me put it on the chat window. In next lecture, we will talk about services. Okay. So कल कल तो मैं क्लास नहीं ले सकता
Monday.
मंडे को संडे को करना हो तो मर्जी है आपकी लेकिन मंडे को करना मंडे भी चलेगा
Monday कर सकते हैं सर, मैं रिवाइज कर लूंगा और
ये सारा रिवाइज कर लेना चलो
yes.
ठीक है चलो
Okay, sir. Bye.
ओके बाय services. Let me open one diagram for you. Now, consider so far what we have seen. We have seen that whenever there is a client, right, and that client wants to access a website. So in last lecture, we have discussed about the deployment, right? So there is a deployment. With the help of deployment, what we can do, we can run our pods, right? Version V1, V2, and we have discussed about uh, the blue and green process also, right? So version V1 is updated with version V2, right? Now, that is our internal process as a DevOps engineer. So what I'm going to do, I'm going to deploy my developer's code into the production or staging or some environment so that the developers, right, so they keep, if they are updating their code, it will go to the GitHub repository or automatically build, and automatically it should be deployed in the Kubernetes, right? Now, the next point comes that how client will access this. Okay, how client will access this. Consider this is running with version V1. Your all the ports are running with version V1, right? Now you have a requirement that it should be updated with version V2 because that is the case, right? V1 is updated with V2. Okay, this process is absolutely fine for the deployment point of view. But how end user or client will access it? In that case, see if you are running with some labels, all the pods are running with the same label because we are using the deployment, and deployment is having the replica setting uh, inside that, which basically runs your application in a high availability or load balancing way. Right. Now, the thing is that this is my client, and my client wants to access my pod, and everything which is running in the deployment case in the pod network means internal to the which is internal to the cluster. It is not available outside the cluster. That is why there is a concept of service comes into the picture. So what is service? Okay, one more problem I just want to highlight here, that consider if this client wants to access this particular pod, and if there is no any other layer in between, then what will happen? That this pod is running with version V1. Okay. Now client is able to access it. Then consider this pod is updated with version V1 to V2. So new pod when get created, so it will have a new IP address. If it is having a new IP address, then you need to change into your DNS setting that DNS setting that will be bit difficult, or maybe you need a lot of efforts, manual efforts, to update this DNS so that your client should access it, which is not a realistic way to do that. Okay, we don't know, no one is doing that. Okay, if they are doing, it's really a very bad practice. So now another problem is that consider you have established one link between end user and the IP address. So right, so now so what will happen that this if you have established a link and you are maintaining, if version V1 comes, and it will be updated with version V2, right? And end user can access it. But what about the load balancing? Okay, what about the load balancing? See, consider that there are a lot of traffic which is coming to this pod. So you want to distribute that traffic to other pods also. So if we are only using deployment, underneath that there is a replication controller, but for the end user point of view, right? So it will be difficult, right? Again, you need to write some custom logic to distribute the traffic. So because of all these problems, right? So we are having a solution which is provided by Kubernetes resource, and that is called the service. Okay. So now let us see how service solve this problem. So first of all, we were having a problem that there should be a static IP address, right? So service, if you are using a service, so service is having a static IP address. That is one thing. So it means if I am configuring my DNS, so what is the role of DNS? See, whenever you are accessing your application, right, you need a static IP address so that you can configure with your domain. Domain, like for example, if there is a KMIT courses.com, this is the domain, and I want it should connect with some IP address, because pod IP addresses are keep changing because of its updation process, right? So static, we need the static IP address, and this static IP address is provided by the service. That is one thing. Now, how service will transfer the traffic to these ports? So service is having something called endpoints. What is endpoint? Endpoint means the IP address which are attached to the service. So it means if you want to call a service, then it will send the your request to those IP addresses. So those IP addresses are called endpoints. So but how these endpoints are basically determined? So these are determined by using labels. So this is my IP1, this is IP2, this is IP3, right? So I have 3 IP addresses, IP1, IP2, and IP3, which is the IP address of all these 3 pods, right? So now I have a label selector, which is app equals to nginx app. So this label selector is the one which will select the pods, and the IP addresses becomes the endpoint of the service. So it means now if you hit the service IP address, then what it will do? It will go to IP1, IP2, or IP3. Right? Now consider if there is lot of traffic comes to this particular service. So service has a inbuilt feature which is called the load balancer. So service is having internally a load balancer. So it means if there is lot of traffic comes, and that traffic will be equally distributed to these pods. Okay, so this is the service. So now what will happen, that if client is going to request to access a pod, then that request will go to the service, not to the pod directly, and service will take your request and access the application which is running inside the pod. It is having the endpoint, and that endpoint is the IP addresses of the pod. So but the pod IP addresses are keep changing, so the endpoints are also getting changed automatically. How? Because of the label selector. Let me do one thing. Let me just show you that practically. So what I'll do here, I will go to my cluster. I'll go to Mova External and I will connect to my master node. So now right, right. So now let me just, first thing I always check that whether there is my cluster is in the ready state or not. So I will log in with the root user and I will say kubectl and get nodes. So all the machines are in the ready state. Let me see something running. Kubectl get pods. There is one pod. Let me delete that. Kubectl delete pod one. So what I will do, I will create a deployment. So I will go to cd manifest, that directory we are keeping, right, for our scripts. So now I will say ls and let me remove all these files. I think all these files I already have on my process. config.yml, ds.yml is there. ds.yml. Okay, I will keep this. So what I will do, I will create a I will create kubectl create. I will create a deployment, and the name of the deployment I will say Nginx deployment. And what I will do, I will say that image is Nginx, okay, and number of replicas, it is 3. Okay, I want to run 3 replicas. And what else I want? Replica equals to 3. And yeah, I think that's fine. And now I will run dry run equals to client minus o YAML. So this will be my YAML file. Let me put it into a file. So I'll say greater than, and I will call it as deploy.yml file. Now what I will do, I will open this file, which is deploy.yml file. And whatever I don't need, I will remove it. Container name, I will say Nginx. Container, that's fine. You can keep anything. Label, I will put app equals to Nginx app. This is the deployment level, but I will keep everything as Nginx app. All right, so I'm creating a deployment now, which is having 3 replicas. So kubectl create -f deploy.yaml file. So this is created. Kubectl get all. So you can see there is something wrong. Error image full. Oh, sorry. Image name is Nginx. Kubectl and apply -f. No, if I say kubectl get all, so now new pods are getting created. I will remove this replica set. Kubectl and delete replica set, which is this one. Kubectl get pods. So 3 pods are running. Now let us see their IP address -o wide. So these are the IP addresses of my pod. Now see that problem which was curl. Okay, I need to see that one. So there was one fix for the issue which I had given, that if you want to access, so see, I'm able to access this with the IP address. So I have uploaded one video right yesterday, which is fixing this issue. So just walk through that, how it is happening now. Earlier when we tried that, at that time it was not able to access on the pod IP address. We were able to access it on that particular worker node. For example, if we are on worker node 2, so there we were able to run this command, but not on the master or other worker node. So that issue was fixed, and I already have a video, so you can just check that one. Right now, I want to create a service. So first service which I want to discuss is the cluster IP service. So this service is the internal to the cluster network. Okay, means the service is available within the cluster only. Within the cluster only. Means if you want your database should be only accessible within the pod network, then you can use the cluster IP service. Okay. Whatever type of service we are going to discuss, all are having the same features: endpoints, internal load balancer, etc. So now, how to create a service? So our deployment name, kubectl get deploy. So we will target this deploy. So you can create the service by using command or by using, excuse me, manifest file. So now here, this is my deployment name. Okay, Nginx app. So I'll say kubectl expose. Okay, kubectl expose command for the service. Expose the deployment, and the deployment name is Nginx app. And if you don't mention the type of the service, by default it is a cluster IP service. Okay. So kubectl expose deployment, nginx deployment. So type, if you don't mention, that is fine for cluster IP. If you mention, it will be the cluster IP again. And now there is something called target port. Target port is called the containers port. See, my nginx application runs at port number 80, right? My nginx application runs at port number 80. So in that case, the port number 80 is the target port. So target port is containers port. And now my service is to access those ports, right? How they will access? Through some port number. So there is a mapping required between your service and the container port. So the port is the service port which is mapped to the container or target port. So now my service is created. When you create a service like this, and you don't give the name, so you will see the service name is same as the service name is same as the deployment name, which I don't want. I want my service name should be different. See, its name is same as the deployment name. So what I will do, kubectl delete service and nginx and app service. Right, delete it. Now next is kubectl and I'll say kubectl same command, expose command, and now I will give the name of the service also. So I will name it as internal service. So this is exposed. Now if I say kubectl and get service, so now you can see now the service is created and the name of the service is internal service, right? And this is the IP address of my service, which is a fixed or static IP address. It will never change. Now, how it will be connected to my pods? Because I am mentioning here deployment is nginx deployment. Now let me show you that one. If I say kubectl get pods minus override, so here you can see these all are my pods and these are the IP addresses of my pod. Now if I say kubectl and describe my service, which is the internal service. So what will happen now? You can see there is something called endpoint. So these are the endpoint, which are nothing but these are the IP address and the port number, because we have port number port 80, right, which is mapped to my target port. Now this is the IP address of my service. Now, let us do one thing. See, consider I'm going to delete one of the any of this pod. Let me delete this. So it will create a new pod because of the deployment and replica set. And now after that, a new pod will be created. So new pod should be automatically becomes the part of my endpoint, right? So let us see. So if I say kubectl and delete pod and the pod name. So I'm deleting this pod. Pod got deleted. A new pod should be created. Now you can say so far not created. Okay, it will create. So it is getting created. Now new pod get created, which is having the IP address .74. Now, if I describe my service, so you can see 73 IP address is removed and 74 IP address is automatically attached in the endpoint. So these endpoints are the reference where the actual traffic goes. So when you access through your service, so service is having one IP address. So if I say kubectl and get service, so you can see this is the IP address of my service. Now if I say curl and this IP address, so you can see I'm able to access the application. Why? Because this service is sending my traffic to the pods or pod IP addresses. Do you understand what I'm explaining here?
Yes, sir.
All right. Now, next thing is that now this service, the one which I have created, kubectl get service, which is a cluster IP service, right? And this service is only available within the cluster. Means if I go outside the cluster and if I try to access this, so I will not be able to access my application. Okay. So it is the main use cases for this is your database, your some private applications which you don't want to expose to external world. So those are basically comes under this cluster IP service. Now you can also create the service by using a YAML file. So how to create that? You can run this command, expose command, and hyphen dry run equals to client minus o YAML. Okay. So this will be your YAML file, and I would suggest that you try this by yourself, put it into a YAML file, and then kubectl create minus f and create this service. Okay, so this thing you need to try by yourself. Now, let me delete this service, kubectl delete service, and the service name is internal service. So I'm deleting this service. Now, service will not delete the pods. Service only deletes the service. Deployment will delete the replica set and the pods. Now, second type of service is node port service. Okay. So this is a service if you want to access your application outside the cluster, like web application, right? Microservices, etc. Okay. So what it will do? It will just 1 second. All right. So it will be so what it will do, node port service. So if you want to access your application to the outside the world, then we use this node port service. So what it will do, it will expose port, you can say 30,000 to 32,767. Okay. So these ports are exposed to cluster level, okay, which on the cluster level. So with the help of that, we can access our service externally with host IP address. Let us see what does it mean. Now I have that deployment, Nginx app deployment. So I'll say kubectl. Actually, we will use the same command, this command, expose command, right? And here I will name it as the external service. Type of the service is node port service. Target port and container port is same. And now here, if I create this service now, so now service got created. Now if I say kubectl and get service, so now here you can see there is an IP address of my service. So if I say curl and this IP address, so I will get the Nginx service because it is pointing to my deployment. Now here you can see my port 80 of my host machine, port 80 of my service is mapped to port number 31,112 port number. As I mentioned, this port number can be any number when you are using the expose command. It's a random number, but it will be within this range. So now the port, which is 3112, it is open. So it means if I say curl localhost, okay, so earlier what I was doing, I was using the IP address localhost colon and 3112. One more one. See, I'm able to access my application. Or if you want to see what I will do on any master, because service is available on the cluster level. So you can open the port number for any worker node or master node. So what I'll do that, I will just open a port forwarding and 30,000. I will open another port. I will say 127.0.0.1 and my host port number, I will put the same 31112 and it will be guest IP means my virtual machine IP address, port number 31112 and I'll say okay. So now if I go here and if I go to my browser and if I open localhost colon 31112, so you can see my Nginx application is up here, right? Now consider you are going to update this image with new version, or let me update with HTTPD image. So what I will do, kubectl. So my container name is Nginx, okay, kubectl and set image, right? Kubectl set image for my deployment, which is the Nginx app deployment, and container name is Nginx, and I want to give the Docker image HTTPD, which is a Docker image for Apache. So now if I say kubectl get pods, so new IP addresses will be, see, 9 seconds ago it is getting created, right? So new IP addresses are, so here when it is updating, let us refresh. Say it is showing this, right? So this is not yet updated, looks like. So it is creating. So because it depends that where my request goes. Now you can see it is updated with the, it works. So this is the default page of HTTPD. So now I am able to access my application, right? Which is, I'm able to access this application, which is basically shows that my pod is updated. So in this case, I did not change end user point of view anything. I did not give a new IP address. I did not give, different port number. So this is something which is fixed. That is the purpose of service. So it will have a static IP address so that you can basically use it for your domain, or you can map it with your domain. Is this point clear to you?
So no, sir.
Huh?
Yeah.
You got it. Okay. Now, the next thing is that can we fix this port number? Because if I create a new service, it will have a different port. Yes, you can do it, but not with the command, but with the YAML file. So what I will do, I will kubectl and delete service, and I will delete my external service. So this service is deleted. Now we are having that expose command, and I will say --, try run equals to client minus OYAML, and I will put it into the node port.yaml file. Okay. So now this is created. Now I will open node port.yaml file. So here you can see we are having the target port and the service port. Here I can write the node port. Okay. And I need to give a number between that range 30,000 to 32,767. So here I will say 31,000. Okay. Now I will save this. Now I will create kubectl and create -f and node port.yaml. This is created. Kubectl get service. So you can see now it is having a port number which is 31,000. Now it means if I say curl localhost and 31,000, so you can see it gives me this output, right? Because my pods are running with the Apache's HTTPD image now. All right, so this is how node port works. Now what I'll do, I will delete this service, kubectl delete service, and the service name is external service. Now, third type of service is load balancer service. What is load balancer? See, as I mentioned that service is having internal load balancer, right? Which is basically distribute the traffic to the pods. But consider you are having your own load balancer, or if you are having a load balancer on your cloud. Say an example, you are using a cluster in AWS, which is EKS cluster, or you are using Azure cluster, or you are using the GKE, which is the Google Kubernetes engine. So if you are using those clusters, right? So in that case, these cloud service providers, they are having their own load balancer. Okay, so if you create a AKS cluster or EKS cluster, so AWS is having load balancer service, application load balancer, right? Classic load balancer. Same way in AKS, there is load balancer. So if you want to use your pods or your service is to use that load balancer instead of internal load balancer, then you use the load balancer type of service. So load balancer service. When we use a load balancer, right, instead of, or you can say when we use an external load balancer instead of service load balancer. Right? So you want to integrate your load balancer to your Kubernetes service, so that is possible. No, it is the similar command which we have done it here, expose command, right? So now the service name, you can give any name. I'm giving load balancer service, right? And this kind of command is more suitable for the cluster where you are having cloud-based environment. So I would suggest that when you try these things on the cloud-based environment, right? So there you can try these commands. Okay. Here it will be not that much meaningful because we don't have the load balancer. Now the type of the service is load balancer. Okay. So this command we write when we are using EKS or AKS, or you can also put something called external IP. Okay, external IP means your load balancer. For example, if I first let me just remove this and create this.
So what type of load balancer it will create? It will create a network load balancer or your application load balancer?
So it depends upon that where you are running. So for example, if you are running on AKS, right? So it will create a load balancer, not the application gateway load balancer. Okay. And if you are using the EKS, then it will create a normal classic load balancer. But we can when we use EKS, so we can specify whether we want the application load balancer or the classic load balancer. By default, it creates a classic one.
Okay.
So now, what happened? Spelling balance. Oh, balancer spelling is wrong. Right. So my load balancer service is created. Now, if I say, so load balancer service creates a node port service plus load balancer board. kubectl get service. So now here you can see my load balancer service is created. This is the IP address. And now you can see this is external IP, which is my load balancer IP address. Because we don't have any load balancer at this moment. So that is why it will be in the pending, and it will be always in the pending state. So what I want to do, I want to replace this with, consider you are having a load balancer IP address. So that also we can do. So now let me do one thing, kubectl and delete service, which is the load balancer service. Okay. So I'm deleting this service. Now, next what I want to do is same thing, same command, and I will put here the external load balancer IP address if you have. I'm giving some dummy one, say 200.10.10.10. Okay, something. Now, if I say kubectl get service, so you can see now external IP address. So this is my load balancer IP address. Okay, so this is my load balancer, and also it is having a node port. See, there's a port number. So now, next is that if I say curl and this IP address 200.10.10, So even though it's a dummy, but we will be able to access our application. Right? So, but in real time, it will be actual load balancer IP address. So this is the third type of service. So we have discussed cluster IP, which is within a cluster. Node port with the host machine IP address, you can access your application. And third one is load balancer IP address. So load balancer is basically your external load balancer. It could be on your EKS, AKS, or if you already have some load balancer IP address, you can specify that also. Right. And this is all about the services also. Now, if I say kubectl get service, let me delete this service, kubectl delete service, which is the load balancer service. And how to create with the YAML file, that you need to try by yourself. Hyphen dry run equals to client minus o YAML, and then create it. That way also you can have your load balancer service. Now let me discuss about one more concept, which is called ingress controller. Okay. Ingress controller. So what is ingress controller? Now, whenever you want to access your application externally, you need a node port or load balancer type of service, right? But you don't want to directly access your service through your IP addresses. You want to create cluster IP services which are internal to the pod network, and you want to create an ingress controller which will point to these services and helps them to expose externally. Okay, let me just show you in this way. For example, if I go here, so right, something like this. So you want to access your application externally, right? But you don't want to give the or internet, and you don't want to expose your services as a node port service because these are internally defined but access externally. Only one public IP address is required. See, if there are, say, an example, 10 services which is exposed externally, maybe you can use different port number. Or if you are accessing with the load balancer services, then you are having different public IP addresses, and IP addresses are not free of cost. You need to pay as per your requirement. You just need to pay whatever you are using the public IP addresses. So that is why what you can do, you can have one public IP address, but under that there are many services which are defined, like your cluster service 1, cluster service 2, cluster IP service 3, and all are accessible by using certain rules. Okay. How? What are the rules? Rules will be something like this. I have my service. For example, my service is KMIT courses.com, right? And I want kmitcourses.com / if I say blogs, so it will go to the blogs I want KMIT courses / news. So it will go to the news service. Blog is a service, news is a service, something like that I want to do. Okay. Now let us see how we can achieve this. So first of all, we need to install the ingress controller. Now so what I'll do here, let me first check kubectl get, or let me delete the deployment. Delete deployment -. So that deployment is deleted, replica set will be deleted, pods will be deleted. Now what I will do, here I will say kubectl and run. I will call a pod as news pod, and with the Docker image, I will use the same, say Nginx. Same way, I will create another pod with the Tomcat, and I will call it as a mail pod. Okay, 2 pods get created. Now I want to create a service, one for news pod and second is for the mail pod, and both are the cluster IP services. So I'll say kubectl and expose, right? Kubectl expose, and my pod, which is the news pod, and name of the service I will say news service, and type is cluster IP by default, and target port is also optional. I'm saying pointing to port number 80. This is my one service. Now second one is service which is pointing to the mail pod, right? And this is a mail service, and Tomcat runs at port number 8080, right? So 2 services I have created. Now I need to download and install ingress controller. I'm going to use ingress controller, which is Nginx. Okay, so let me just go back to my notes. So I will copy this and I will run it. So there is a YAML file. On the basis of this YAML file, ingress controller related pods, services, everything get created. Now, if I say kubectl and get namespace, actually we'll talk about the namespace later, but here it is required. So there is a new namespace get created which is called ingress Nginx. Now, if I say kubectl and get service under the namespace, which is ingress Nginx. So there is a service which is called this is the service which is a node port service, and it is pointing to port number this 443. This is HTTP and this is HTTPS 443. Okay. Okay, this is fine. Now what I will do, I will create a YAML file. I will explain this. So I'll say ingress.yaml file. Now here I will use all this ingress. The name of the ingress is, I'll say something KMIT ingress, and I'm using Nginx, right? And I'm saying whenever someone says a path /news, in the background, it will go to my service, which is the news service, which runs at port number 80. And if someone says Tomcat, not Tomcat, mail, then in the background, it will go to my Tomcat service, which is named as mail service at port number 8080. Okay. So let us see what it will do. So now let me save this. Now, if I say kubectl and create -f ingress.yaml, right? So what it will do, it will create a ingress. Now you can see kubectl get ingress. So you can see that there is one ingress is running, right? Which is for HTTP only. Okay. Now I will take this port number. Let me just open that port also. I will go here, right? And where I have opened settings, I think into the network adapter 1 port forwarding. I will add one more to my localhost 127.0.0.1. Okay. This port number, which is pointing to this port. Now what I will do, I will go to my localhost colon and that port number. So when I run it, it is saying not found because I need to give the service name. If I say /news, it will go to the Nginx. And if I say /mail, it will go to the Tomcat service. Okay. So this way, right? So this way we can basically create the services and we can put it under a ingress controller, and with the help of the ingress controller, now there is single IP address, and with that IP address we can access our application by slash the service name. Like it will be easy also. For example, you are using Google, right? So google.com/mail if I say, and /news/YouTube. So it will be easy to remember for you also. So that is how we use the ingress controller. Is it clear to you?
Yes, sir. Clear.
Good, good. Right. Okay, so that is all about the services. And all the notes and everything is here. Now let me delete this namespace, or what we can do, we can just that URL, instead of apply, I will say delete. So what it will do, it will delete all the things which it has created for the ingress controller. Okay, so service part is ended here. Our next topic is storage. Okay, so let me first give a brief about what is storage. Now let us yeah. So I think for today this will be enough, right? Otherwise it will be overloaded for you.
Yes, sir.
Storage part we will discuss tomorrow.
Sure.
So okay, so once you get the time, please revise this.
Definitely.
See you tomorrow then. Bye-bye.
Okay, sir. Bye. Bye.
We'll talk about storage. Okay, so what is storage? See, in Docker also we have discussed about the storage, right? So storage means that you want to store your data. Okay? Storage is to store your data for your application, for your pod, right? So right. So like in the Docker, we were having the two types of storage. similar way, we are having two types of storage in Kubernetes also. So Kubernetes is having its own persistent and non-persistent volume. Okay, it uses its own storage instead of container storage. So let us understand that one. So whenever we go inside a pod, so we are going inside a container. Okay, and if I delete that pod, then container also get deleted. But if I delete the container, pod is not deleted. When you delete the container in the sense, for example, you are updating with a new Docker image. So the old container will be deleted and new container will be created. So in that case, what about the storage? So if you delete the container, so by default, um, the data which is stored inside the pod, it is storing inside the container only. Okay. So when you delete the container, then that data also get deleted. So in that case, definitely it is non-persistent. So that is one case, non-persistent. So it means when your data when your pod get deleted, your data get deleted. And second is called persistent. So persistent it is when your pod get deleted but data is not deleted. So we'll see these two types of example. Let me do one thing. Let me go to my Mova Extra. Let me connect to my master node. And let me connect to my worker 1 also and worker 2 also. Looks like worker 2 is not yet up. So system D. Something wrong. Location of the logical offset system max block. Data will be most likely to. Not sure what is system D problem. Okay, so at least we are having one system. So let me log in with the root user. Right. So now, first thing we need to do, let me clear the history. I have also created one more playlist. And so far I have added one video, and that is related to the troubleshooting, right? So see, now everything is running fine. I am able to create the pod, but consider there is some issue, right? How to resolve those issues, what will be your workaround for that, how to troubleshoot that. So I would say that I have just started that one. Today I have uploaded one video, two videos. One is introduction and second is the actual problem. And it is hardly 10 minutes video. So please watch that video also. So this will again help you to, uh, your your mind will go in different direction to think that if this kind of situation happen, then what we need to do. Okay, so please go through that one also. Okay, worker 2 is also ready. Right. Now, let me see kubectl get pods. Do I have any pod running? Actually, first we need to run the command which is kubectl get nodes to see all the nodes are in the ready state. If they are in the ready state, then next pods and other things we need to see. Yes, all are in the ready state, and we are using which is version 1.3.5.2. This is the latest version as of today. Okay. Now, what I will do now, I will create a normal pod. So let's create a pod, right? And then delete the existing container and replaced with new container, and then we will see the data is persisted or not. Okay, so what I'll do here, kubectl and run pod 1 with the image nginx. Okay, so this is the pod 1 get created. Now, if I say kubectl get pod, so there will be one pod which is at this moment creating state. It is still creating. So what I will do, watch kubectl get pods. So it will be watching. Okay, most of the time it get created immediately. Let's wait. So every 2 seconds it is getting updated. Something looks fishy here, not correct. Okay, let us see. Kubectl and describe pod, which is pod 1. Okay, something wrong which is related to the. Okay, it is assigned to worker node 2. Okay, worker node 2 was having a problem, right? Sudo su. So there is something wrong on worker node 2. And what is wrong? It is saying the sandbox unknown description set up the network. Okay, something wrong on the network. So what I'll do, let me check the IP address of this machine. This is having 192.168.0. And let me see the IP address of worker node 1. This is 7. This is absolutely correct. Now, actually, there is a kubeadm reset. You can reset the worker node or master node also. Do you want to reset? Yes. So it is getting reset. Okay. So I have some troubleshooting steps also here in my GitHub repository if such kind of situation happens. So DevOps. Reset your cluster. Let me run this command. Remove the CNI from here. Okay. then remove the flannel. If it does not remove the old network interface, restart container D, done, restart kubelet service, done. Now just run that command. Now if I go to master node, kubectl get nodes. Okay, worker 1 and worker 2 both are not in ready state. Sudo su. Okay, so IP address. So you can see here 7 worker 1. So something went wrong on my cluster, looks like. So what I'll do, I will repeat these commands on worker 1 also. So join command is, let me get that join command. Kubectl or print join command Kubernetes. So this is the token which get created on master node. Okay, I'll copy this command and I will run it on worker 1 as well as on worker 2. Okay, so this is fine. Meanwhile, I'll check here kubectl get nodes. Worker 2 is also not in the ready state. Worker 2 is ready. Okay, here there is some error. I'll say kube adm reset. Okay, so we need to repeat those steps. Actually, on premises or our own setup, this is the issue which we sometimes face. Reset does not perform cleanup CNI plugins. Network filtering rules. Okay, so we'll see. Looks like I need to fix this offline, this worker one, right? So at least we are having worker two. So now if I say kubectl get pods, so this is running on worker node two. So I will check that offline why worker one is not working. Right? So now here you can see pod get created. Now if I say kubectl and exec minus it, I am going inside the pod one, and I will say mkdir. I want to create a directory under root, which is test directory. Okay, so my cluster is not at all working. Connection refused. Okay. Internal error for sending the request to this. Connection refused. Okay, so Kuberian reset. Restart kubelet. Okay, this is in ready state, but it is not working. Probably I need to restart my machine, looks like. Let me do that quickly. Worker one also. Let me just restart. And for this, what we can do, we can start now these two machines. Because Kubernetes depends upon so many things, especially when we set up for our uh, own environment. So, right. So let's see once it's come back whether it is working fine or not. But meanwhile, what we can do, we can run our pod on worker node or master node. Okay. We'll create our pod on master node. How we can create? I will say kubectl and delete pod. I will delete that pod, just pod one. So I will just keep one more setup ready so that, during the class, if such kind of thing happens, we can. This is fine. It's in terminating state. That is fine. So I'll say kubectl and run, which is pod 2 with the image nginx. And what I will do, I will put it into a file, say master pod .yaml file. I will put it on the master pod. Okay. Now, if I open this master pod.yaml file, okay, I did not write kubectl get pods. So yeah, this I'll create pod 3. I did not write that hyphen dry run equals to client minus o yaml. Now, if I open this file, which is this one, so here what I will do, I will remove all these things and I will say node name, and here I will say kmaster. So it will be created on the master node. Now, if I say kubectl create minus f master pod.yaml file. So pod 3 get created. Now if I say kubectl get pod minus o void, so you can see this is in the creating state. Okay, so if I say kubectl and describe pod 3, some error, it's like, no, it is running. So now get pod, so it is in the running state. Okay. So my master node is working fine. So now what I will do, I will go inside this pod. So I will say kubectl and exec minus id, and my pod is pod 3. And if I say hyphen and mkdir, I'm creating a directory called under root test directory. Okay, this is created. Now if I say ls under root, so you will find a test directory. Okay, so test directory is there. Now I will create a file inside this test directory. So I will say touch and test.java. So I'm creating one more file, which is test.java. Now, if I say ls under root test, so you will find there is a test.java file. Now I want to change the image of this container. Okay, so currently it is using nginx. Now what I want to do, I want to update it on, I want to update this image with the httpd image. Okay, so even though if you run this command, which is curl, and this is the IP address of my pod, so you'll see that this is the nginx output. Welcome to nginx, right? Now, what I want to do, I want to say kubectl set image for my pod. Pod is pod 3, and by default container name is same as the pod name, and I want to change the container image to httpd. Okay, so pod 3 container image is updated. Now my pod will be restarted. So if I say kubectl and get pod, so you can see that it is not yet restarted. Now it is restarted. Right? So now I want to see Same command if I run, right? Now it will be HTTPD output, which is Apache HTTPD, right? Earlier it was Nginx because I replaced the image Nginx to Nginx to HTTPD. That is why this particular output is changed. Now, what about my data? So if I say, um, same command if I run, so see, there is no test directory because that directory I have created inside the pod and pod has created inside the container. Okay? So container storage is used, right? So now, basically what happened now, that container is deleted because it is replaced with HTTPD and my data also get deleted. That is why I don't find that that test directory. So it means data is non-persistent here, even though we are replacing the image. Okay, but pod is not deleted. Pod is, we use the same IP address to access our application at port number 80. So this is the default behavior of the container or default behavior of the pod. Now there is another concept which is called empty directory. So empty directory is storing the data on the basis of pod level, not on the container level. Now, if you replace the container, your data will be not deleted. Okay. Consider you are having two containers inside a single pod, and you want to share some data between these two containers. Consider one is pushing the file into that directory, and other is picking up the file from that particular directory. So in that case, we use empty directory because its scope is with the pod lifecycle scope. If you delete the pod, then it is a different thing, right? If you delete the pod, then it's a different thing. But if the pod get restarted, if the pod is if pod is alive, in that case, your data will be persistent. So let us see that. So what I'll do here, let me see, my other nodes are up. So other nodes are not up. These are up, but you know, Kubernetes, these are not working as a Kubernetes. There's something wrong in worker 2 special. Okay, so sudo su, right? And if I say kube adm reset, okay, so these are the things, deleting contents of the directory. Failed to destroy the network sandbox. Okay. Let me just one more time try these commands. If it works, then it will be good for us. I can show you on the worker node how the storage works instead of master node. If it does not work, then in worst case, I will create the storage on master node only. Okay, everything gets restarted. Okay. So now let me see. kubectl get pods, get nodes. Okay, worker 1 is in ready state, it is showing. That's cool. So now, if I create a normal pod, kubectl run pod 2, pod 4 with the image nginx, kubectl get pod. So pod 4 is in the creating state, creating state. Okay, it is, looks like it is doing something. Not yet created, it is pulling the image. Oh, it is pulling the image, but it is not able to pull the image. Looks like, but it is not showing any error so far. It is taking bit. Oh, successfully pulled the image. That's good. Now it will be in the running state. Okay. Now let me try to go inside this kubectl exec minus id pod 4 hyphen mkdir/test. Let us see whether it allows me. Okay, that's cool. So worker 1 is up. So what I will do, I will delete this pod 3 and pod 4. kubectl delete pod and pod 2, pod 3 and pod 4. I will delete all these pods. Okay, worker 2 is giving some issue. That I'll check. Okay. Now, empty directory. So basically, what is empty directory? As I mentioned, this will be having a scope on the scope on pod level, right? Empty directory. It creates when the pod starts, deleted when the pod is deleted. It survives the container restart, but not the pod deletion, right? So it will be survive if the container get deleted. So let us do one thing. Let us use this code. Okay, let me copy this code. Now let me go to my cd manifest. Now here I will say vi empty directory dot YAML file. So what I'm doing here, I'm creating a pod. Name of my pod is my pod. It is using the Docker image nginx for my container. Container name is also nginx. Now here I'm using volumes. So volume type of name of the volume is my volume and type is empty directory. So you just need to define empty directory like this. So what it will do, it will keep your storage on the pod level. And here you can see there is a mount option. So this volume mount means within the pod or container, it will have a directory called my app. If it exists, it will point to that one. If it does not exist, it will create an empty directory. And the name of the volume, this volume is mapped to this volume mode. Okay. So now let us see how it works, my pod. So I'll save this and I'll say kubectl and create -f empty directory dot here. So this is created. Now let us see where it get created. kubectl get pod -o and white. So this is in the running state on worker 1. Now my worker 2 is that looks like. Okay. So this is running on worker one. Now what I will do, I will do the same activity. I will go inside the pod, and here we have mapped this directory, my app directory, inside my container, or inside my container, which is mapped to my volume, which is empty directory volume. So we will repeat the same step to create a file inside this. So I will say kubectl and exec minus id. My pod name is my pod hyphen hyphen. And if I first want to check, is there something inside my app directory? So this is empty directory. Directory exists, but there is no file or folder. So what I will do, I will create a file here. I'll say touch, and I will say the file name is my app.java file. Okay. So I'm having this my app.java. Fine. Now, if I check now, this is there. Now my container name is Nginx container. So what I will do, I will do the same activity. I will replace Nginx with HTTPT. So I'll say kubectl and set image for my pod, right? And I want to update set image for the pod. We need to mention pod, which is my pod, and which container, Nginx container. I want to change the image to HTTPD. Right? Image is updated. Now my pod will be restarted. Right? So you can see pod got restarted. Right? Pod got restarted. It means what? Now it is running with the, if I say curl and this, so it is running with the Apache application. Earlier it was Nginx application. Now the thing is that, what about the data? My app.java file. So I will use the same thing. See, my file is there. Even though my container got deleted and it is replaced with another container, but my data is persisted. So this is how empty directory works. But its life is until your pod get deleted. If container get deleted, it won't make any impact. But if the container is if the pod get deleted, then this data will be deleted. Do you understand this concept?
Yes, sir.
And how it is different from the default behavior of the pod. Yes, if you don't have the empty directory, then your data will be deleted. But now we are having one directory called my app directory, which is pointing to the empty directory. And this information you can check in the describe command also. For example, if I say kubectl describe pod, which is my pod. So here you can see there is a volume. Name of volume is my volume. Time is empty directory, a temporary directory that shares the pod's lifetime. As after pod deletion, then this data will be deleted. So as I had given you some other example that there are multiple containers and both want to share the same data, then this is the right choice. Right. But again, it is under the non-persistent because we are having a case when pod get deleted, then this data will be deleted too. So it means this is non-persistent. We want, if the pod get deleted, data should be persisted. So this comes under the non-persistent category. So if I say kubectl and delete pod, which is my pod, right? So now this is deleted and that data is deleted too. Worker 2, what you are doing? Okay. Now, next thing is that how we can persist the data. So one option is that host path volume. So this is the persistent volume. So what is host path? Host path is basically you are saying, okay, wherever the pod get created, either on worker 1 or worker 2, on that machine, you can create one directory and keep my data into that directory. So now the data will not be stored on the container level or pod level. The data will be stored on the machine level. So if your machine get deleted, means corrupted, or that directory is deleted, that's a different thing. But your data will be persisted even though your pod get deleted. Okay, so this is creating a directory on the host machine, right? And where your data will be stored. Now we'll see. I will say vi and host path.yaml file. Okay, so this is empty directory, host path volume. Right? So host path allows the pod to access a directory or a file from the node of the host machine. So now your data will be persisted. Let me copy this one. Right. Now here what I'm doing, I'm creating a pod called my pod. Name of my container is Nginx, and I'm using Docker image Nginx. Now here you can see the volume. Name of the volume is my volume. Host path. Type of the path. This is the type of the path. Means in wherever this pod get created, in that there will be a data directory under root, and under that there is a my app. You can give any path. Okay. Directory or create. So what it will do, it will, if this directory does not exist, it will create that directory. Now, this particular volume is named as my volume, and I'm mapping it with container my app directory under root. So let us see. Let's save this. Now, if I say kubectl and create -f hp.yaml. So this is created. Now, kubectl and get pods. So pod 1, I should be running on worker 1 because other worker is not running. Get pod -o wide. So it is running on worker 1. So if I go to worker 1 now, and if I say ls root my app, what is that directory? Right. So 1 second. Data and my app. Right? So here data is a directory, right? So under data, my app. Right? So currently it is an empty directory. It was not there earlier, but now it is created because we have given the condition, or by default it is directory or create. Means if this directory does not exist, then it will create. If it exists, it will point to that particular directory. Right? Now, if I go inside my pod, so here we can also run the command kubectl describe pod and my pod. Right? Here you can see volume, my volume, type is host path, and it is mapped to this particular path of your host machine. Right? So, right. So now I want to, and our mount point is my app. Right? So this is my mount point. Right. So now what we will do here, we will go inside our pod. I will say kubectl and exec -it. right? And then my pod is my pod, and -ls. I want to check this directory, which is my app, and currently it is empty. So what I will do, I will keep some data inside this. I will say touch, and I will create a file which is my app.java file. Okay. Now if I say, so there is a my app.java file. Now if you come over here, you can see that that file is actually get stored here. So this is the actual location. Inside the pod or inside the container, it's a image, or you can say it's a mirror image. Okay. So, but this is the actual location. So if I go and, if I delete it from here, it means if I say rm and if I remove this under data and then my app, and if I delete this my app.java, now it is deleted, so I cannot see it here. Okay, so I'll create it again. Right. Now I will delete the pod. If I say kubectl delete pod my pod, now this pod get deleted, but my data is not deleted. So if you see here, my data is still there. Right. So this is the case of the persistent volume. My data is persisted even though my pod get deleted. Right. Do you understand this concept?
Yes, sir.
Just walk through one more time. So this is basically, we are talking about that where the data will be stored even though our container or pod get deleted. So that if I create another pod and I can map this particular path, so then it will be persisted. Are you aware of NFS, network file system?
No, sir.
In Linux? Okay, network file system is nothing but it is for example, this is your development machine, right? This is your development machine, and there is a storage server, right? Like there are many other developers, they are working on the same project, right? And they want something which is commonly shared with everyone. So this server is called the NFS server, network file system. So here you will create some storage directories or files. So for example, you have created a data directory, and under that you are having some files, right? So now these files you want to share with these people. So what they will do, they will mount this to the network file system. Okay, so both are pointing. So now how it is useful in our case, you just on each and every system you can create one mount point which is mounting to this particular directory, right? Now consider your pod get created on node 1 today, and now you have deleted the pod but data is on this machine. But now second time when you created the pod, it got created on other machine, but my data was here earlier. So then what I will do, instead of specifying the directory which is on in node specific, I will give the mount point which is pointing to this particular directory. And because it's a centralized one, so even though my pod get created on this this particular worker node 2, right? It will also pointing to the same NFS directory. So that way, it does not matter where the pod get created. The storage or your volume or host path volume is pointing to the one directory all the time, which is the NFS directory. Okay. So that also we can do. Because this kind of question is commonly asked when I take this storage especially. Now, one thing we have noticed in this script or the previous script, which is the empty directory, that volume definition, this is the volume definition. So volume definition is inside the pod definition. Means if I delete the pod, volume data will be there, but volume definition will be deleted. It means volume does not have its own life cycle. That is what it means. So in that scenario, what Kubernetes has done, it has created a persistent volume and persistent volume claim. So these are other type of persistent volume. PV, we call it PV and PVC, persistent volume claim. Now, basically what happens, again, you want to keep your data, on some location, right? Which is and this is called this is of two types. Persistent volume is static and dynamic. Static is similar to your host path, where you are having a fixed directory within your own premises and you are having a fixed storage, and dynamic provisioning when it is on the cloud. For example, you want to keep your data on AWS EBS volume, or you want to put on the Azure data disk, right? So in that case, right? So in that case, your data will be on the cloud environment, and you can put a lot of condition. There is something called storage class. Storage class is nothing but it tells that what type of disk you are having. Is it a GP2 disk, GP3 disk? What type of disk? So those kind of storage also we can decide on the cloud based, right? But because our environment is on-prem, or we have created locally, so we will talking about the static provisioning in persistent volume, right? So now here there are two components. One is called persistent volume and one is called persistent volume claim. And then we will have the pod. Okay. So persistent volume is a definition of the volume, which will tell that what is the capacity of the volume is. Capacity. For example, you are saying that it will be 1 GB, right? 1 GB. So that's the capacity. We can also define something called access mode. So there are different access mode. One is read only, since you want to keep your volume as read only, right? So you cannot perform the write operation. I want to read write once. It means at a time only one node can update it, right? So that is read write once. Read write many means multiple nodes. Read write many. It means multiple nodes can update those volume at the same time. Consider there are two pods which are running on two worker nodes, and they want to update this volume. One is adding file 1, other is adding file 2. So they can do if it is read write many. Right? And this is the definition. Now this definition is consumed by the persistent volume claim, PVC. So what persistent volume claim will do? It will request within this capacity the volume. For example, it is saying I need 800 MB data. So it will be bound to this persistent volume. One persistent volume is bound to one persistent volume claim. And then this persistent volume claim will be used by the pod. So pod will be using this. So this is the life cycle. And persistent volume also deciding one host path where your data will be stored. So let us see this practically. So if I go here, and what I'll do here, so I'm creating a persistent volume. Name of my persistent volume is my persistent volume. Capacity is 1 GB. Read write once is the access mode. And wherever the pod get created, there will be a path get created, which is called data. You can give any path. So let me create this persistent volume. So what I'll do here, I will go to my master node, right? And I will say vi pv.yaml, persistent volume.yaml. So data and PV storage. So you will see here under my data ls, under data, there is no my PV storage, right? It will be created once the pod get created. Right. Now we will create this volume kubectl and create minus pv.yaml. So now you can say kubectl and get PV. So here you can see this is my PV, 1 GB is the capacity. There are two reclaim policy, one is retain, one is delete. So delete is nothing but when if you want that your persistent volume, once it is deleted, persistent volume claim also get deleted. Currently it is available, it is not bound to any persistent volume claim. So now we will create a PVC, persistent volume claim. So here I'm creating persistent volume claim. Name is this, read write once, it match with this access mode, right? And I'm requesting 500 MB of data, which is within this 1 GB. Read it, kubectl and get PV, PVC. So now you can see it is bound. Earlier it was in the available stage. Now it is in the bound. Bound with what? My PVC. This is my PVC, which is bound to my persistent volume, and it has total capacity, which is 1 GB, right? But it has requested for 500 MB. So it will use 500 MB only. Now next we need to create the pod. So this is the pod, and in the pod volume I am saying my volume, which is pointing to the persistent volume claim, the one which we have created here. And name of my persistent volume claim is my PVC, right? And and volume point is under root my app directory inside the container. So let us do that. Now I will say vi and my pod .yaml. If I say kubectl create minus f my pod .yaml, created my pod. Now if I say kubectl and get pods, so you can see my pod is in the running state. Now if I say kubectl and describe pod, which is my pod, right? So here you can see created, and here you can see volume, my volume type. It is a persistent volume claim, a reference to the persistent volume claim under the same namespace. My PVC, okay, it is pointing to this. So it means the data will be stored where? Data will be, so see where this pod get created. In our case, it will be on worker node 1, but if you are having multi worker nodes, then it will be created because we have specified the path. Right now you can see PV storage directory also get created. So it means if I go to if I say kubectl and exec -id, name of my pod is my pod, and if I say -ls and under root my app, so my pod, right? So this is empty because this is empty. PVC, PV, this is empty, right? Now what I will do, I will just create a file. Now I will say touch my app and my file.java. So this is here and it will be stored under this directory. So it means if I delete my pod, if I say kubectl delete pod, my pod is getting deleted and pod is deleted. If I say kubectl get pods, so you can see pod is deleted, but my data is still there, right? So this comes under the, how it is different from the host path. In the host path, the volume definition is inside the pod definition. So volume does not have any life cycle. But here in this case, the volume is having the life cycle. It has persistent volume claim, and then we are having the pod, which is consuming the persistent volume claim. Okay, so just walk through this, these examples, and under my repository, you will find a storage, and in that you will find all these nodes as well as YAML files. So this is storage, right? So we will discuss namespace tomorrow, role-based access control, kubeconfig. I think it will take another 2 more classes for Kubernetes only.
No worries, sir.
Yeah. So then we will discuss about Prometheus and Grafana also. So maybe, so tomorrow is Thursday, right? So
So
Friday,
when will we
Saturday.
discuss Jenkins?
Oh, it is still far. After that, we will discuss the Ansible.
Okay.
After this, then we will discuss about the Terraform. Then we will discuss about the Jenkins. So yeah. All right. So I think the storage part is covered in today's lecture. And tomorrow we are not
Day after tomorrow.
having, day after tomorrow, we will discuss about the namespaces and role-based access control.
Sure. Thank you.
Thank you. Persistent volume, non-persistent volume. So today we will talk about the role-based access control. But before talking about the role-based access control, we need to know namespaces. Okay, so let me just talk about the namespaces first. Then we will talk about the kubeconfig and then role-based access. So let me just let me open the right. Right. Now consider I have a cluster. So this is my cluster. And in this cluster, I have my master node and worker node. So this is my cluster. On top of that, we are having the pod network, which is Flannel we are using. Now consider there is a development team, right? And this cluster is used by different teams. Means they want to create the pod, they want to create the deployment, services, etc. Everything is getting created on this cluster. Okay, so this is our master, and these are our worker nodes. Say this is worker node 1, this is worker node 2, right? Now, there are some other teams. For example, there is a testing team. So now test team wants that our pods should not be visible to the development team, or development team wants that our pod should not be visible to the testing team, but everything is getting created on this cluster only. Or maybe consider you are having a very big cluster, and on that cluster, what do you want? You want that these this cluster I can use for client 1 and client 2, but there should not be any interference between client 1 and client 2. So client 1 resources should be isolated from client 2. Okay, so there could be any number of use cases where you want to do the segregation. Now what I'll do here, so what I will do, I will create a virtual cluster. Okay, I'll create a virtual cluster. This virtual cluster is for my development. Same way, I will create one more virtual cluster on top of my actual cluster. This is for the testing. Okay, so this is for development team. So it means development team related pods, development related, say, pods or deployment, etc. All the resources will be in this virtual cluster, and something which is related to the testing team. So their pods, their clusters will be into this virtual cluster. So this is called a namespace. So where we are segregating the clusters, right, on the basis of the different teams or different client requirements, right? So this is the namespace for test, and this is namespace for the development. Now let us see practically where we can see these namespace and real-time use case for this. So what I'll do, I will go to my MobaXterm. Okay, and first thing I will say kubectl get nodes. So I want to see all the nodes are in ready state. Oh, worker 2 is not in the ready state. What's wrong? It's not started. Let me see. This is worker 2. Oh, worker 2 is having some problem. Okay, no worries. I will power it off and start again. Actually, I did a clone of my worker 1 and created this virtual machine. Probably that is the issue. It is powered off. Let me start this. If I start without GUI, will it work? Let us see. Maybe GUI is having some problem. Okay, so okay, at least we are having worker 1 where we can run our pods. Okay, so now if I say kubectl and get pods, so as of now you can see here no resource found in the default namespace it is saying. So knowingly or unknowingly, we are using a namespace already, and that namespace is default namespace. So in this default namespace, what is default namespace? What are the other namespaces? We can just check that. If I say kubectl get ns or namespace, you can write. So here you can see these are the namespaces. Argo CD is a separate one which I have created for different purpose. But default, this is the kubeflannel, which is for our port network plugin. Node lease, which basically when the nodes are in the ready state or not, this will be uh, the namespace for that. For kubepublic, right, which is basically used for public resources. Kube system, this is very important. Monitoring is again not by default, you will see. So because I was working on Prometheus and Grafana, that's why it is I have created this namespace. Now kube system. Kube system is the namespace where all the resources related to the Kubernetes system point of view, like your master component, like something which is required for the admin point of view or system point of view, especially internal architecture to maintain, some resources are in place and those are inside the kube system namespace. Let me show you that one. If I say kubectl get pods, so if I run this, it will show all the pods in the current namespace, and my current namespace is the default namespace. So if you are not having any specific use case, I don't want to create um, for admin related task, I don't want to create node related, means you, if those are the use cases, then you can use those namespaces. But if you are normally creating the applications and you are simply just saying that I want to create a pod, I want to create a service, so in that case, you know, this in that case default namespace is used. Okay, we can create our own custom namespaces also. So let us see get pod, but I want to see the pods under the kube system namespace. So I will say under namespace kube system. So here you can see these are the pods which are running in my kube system namespace. Okay, under my kube system namespace. So see here API server, proxy server, scheduler, master, core DNS is the, you know, you can say it's a DNS for my services, those ports. So everything is running in this namespace. So now let us see kubectl get namespace. So currently I'm in the default namespace, but how do I know I'm currently in the default namespace and how I can create a namespace? I can create a namespace simply. You can say kubectl create namespace, and namespace is, say, an example dev. So I have created a namespace called dev. So I'll say kubectl get namespace. So here you can see there is a namespace get created and it is named as dev. Okay, because for example, you want to keep all of your resources which are related to dev into the dev namespace, right? So now um, now what I want to do, if I want to delete this namespace, kubectl delete namespace and dev namespace. Right. So now dev namespace is getting created, getting deleted, and whatever is in that dev namespace, if you create some resources like pods or services, etc., so everything will be deleted. Now you can also create the namespace by using YAML. Okay. Equal -o YAML. Right. So kubectl create namespace sorry. I'm doing kubectl. What is that? Dry run, right? Dry run equals to client minus o YAML. Okay? So you can use this script and you can use the script to create the namespace. Okay? Now, so what I'll do, I will go to cd manifest and I will run this command and I will put it into the dev namespace.yaml file. Now I will say kubectl and create -f dev namespace.yaml file. So namespace is created. Now if I say kubectl get ns, so you can see dev namespace is created again. Right. Now if you are in a default namespace and you want to create a resource like pod inside the dev namespace, how you can do that? For that, you will say kubectl and run pod, or I will say dev pod under the with the image, say nginx under the namespace dev. So I need to explicitly mention that I want to create this pod under the dev namespace, right? So if I run this, so this time pod get created, but it is created under the dev namespace. If I see here kubectl and get pods, you will not find any pod because that pod is not created under default namespace. It got created under the dev namespace. So if I say kubectl get pods under the namespace dev, so now you can see, yes, my pod is in the dev namespace. Now, similar way, so there is a very commonly asked question, can I create a dev pod in my default namespace also? Because it is already in the dev namespace. So yes, you can do that. So two resources like pods can have the same name, and if they belong to different namespaces, so that is possible. Right. Now, if I want to create a resource by using a YAML file, so what I will do, -- try run equals to client minus o YAML. So here what you need to do, you just need to mention that namespace into your metadata that I'm creating a pod, and uh, in the metadata, right? So you need to mention namespace, and namespace equals to wherever you want to create. Okay. So this I will just leave up to you. You just need to try this by yourself. Okay, to create another pod by using YAML file. Right. Now, we will learn the role-based access control also, but at this moment, first we need to see how I can switch from default namespace to dev namespace. For that, we need to use something called kubeconfig. Let me see my kubectl get node. My another node is okay. Some issue in my worker node too. Let me just restart that one. That always it's in the running state. Let me power off this and let me start again. Probably I need to do. Yesterday it was working. All right, so let it be start. Right. So now, next thing is that how we can switch from one namespace to another namespace. Right? So how to switch? So there is a file which is a configuration file, and we call it kubeconfig file. and that is under your home directory. Under that, there is a folder called Q folder, and here you will find a file called config. You just check that, means sometimes it is config, something admin config. So it depends, right? But 90% it will be config only. So this is my file content. So what I'll do, I'll just copy, because from here it is difficult to read. So I will copy all this and I will put it into a notepad. I'll paste it here. I will just say language, which is here. Right. So here you can see API version. So this is a configuration file for my cluster. Okay. So if you don't have this file, then you will not be able to connect to the server. So this is my server configuration file. Right. So now let us try to understand this. Right. So first thing is the API version, right? In Kubernetes, we have seen that whenever there is a YAML file we are creating, on top of that, we are writing the API version. So here API version is V1. Now here you define the clusters, right? You can configure multiple clusters also in this configuration file. Okay. In our case, it is only one cluster, but consider you are working on AKS, EKS, and you want to configure it on your local system. You can do that, right? So now which cluster? So cluster name, you can give anything. This is the IP address of my master node. 6443 is the port number by which you can connect to the master node. Okay, 6443. Right. Now, this is the certificate authority. So there is a certificate key. See, whenever this is my master and it is having the API server. So any request which comes to the master, whether through worker node or from anywhere, right? So that hits to the API server, and this API server is checking this certificate. So if your request should come with the certificate, and on the basis of this certificate, it will authenticate you or authorize you that yes, this is a valid request. So this is a certificate authority or CA data. So where do you see this one? So if I go to my cluster again, and if I say cat or not cat ls /etc/ Kubernetes PKI, right? So here you can see there are many keys and CRT files are there. So key is your private keys. Whatever is ending with the dot key, these are the private keys. Whatever is ending with the CRT or PUB, those are your public keys. So now CA.CRT and CA.key. So if you are aware of asymmetric encryption, so that is basically happening here. Your request is coming with the public key. Okay, this key, and it is validated with the CA.key. So if I open this file, which is cat /PKI and CA.CRT, right? So a base 64 conversion of this is that whatever we see in our certificate authority. You can convert that also. So if I say, I think base 64. Yeah. So if you see this data, LS0 this. So this is this data only. Okay. Ending with 0K. And here you can, so this is your public key. So it means if you want to connect to my server, you need to come with this certificate. If you are not coming with this certificate key, your request will be rejected. So Kubernetes is very secure, so it won't entertain any request which is coming from the invalid resources. And this is validated with the .key file. Are you aware of that symmetric and asymmetric encryption? Have you heard about that?
Can you repeat that again?
That symmetric and asymmetric encryption.
I have heard that, but not
Yeah.
know when
So
to use.
asymmetric is basically when your data is traveling on the network, right? So there is a public key and private key. So public key is validated because sender is sending that public the data through public key, and that is validated with the private key. So mostly we use the asymmetric only, and Kubernetes is also following the same thing. So it takes the request with the public key, and if the public key is not resolved by the private key, then it rejects your request. All right. So now, right. Now, next one is, if you see here, context. Let us understand the concept of context. See, context, this is the context. So context is consisted of three parameters. One is cluster. Second is namespace. And third is user. So as I mentioned, you can have multiple clusters. So you want to create a context. So because we are having only one cluster, so here I will say use Kubernetes cluster. This is the name of my cluster. It could be Kubernetes 1, 1, 2, 3, whatever you want to give. That same you need to give it here. Okay. User is defined here. In Linux or Windows, we create the users, right? And we create the user, and that users are created through some command or by using some tool. But here in Kubernetes, it is not like that. In Kubernetes, whenever you are creating a user, you need to create the certificate data, means that key, and the public and private keys. Okay. See, this lecture is more related to the admin part, not the developer part. So today and tomorrow, whatever we'll be discussing, it is more focusing on the CKA, Certified Kubernetes Administrator point of view. So here you can see it is more related to the admin part. So we are doing that activity, means we will be managing our cluster. We are not creating pods now. Means, see, if someone comes to you and he say, can you create a pod? It means development. If someone says that, can you apply the security on the pod? This is not development. Okay, ultimately you need to do the development, but you need to do some admin work, security work. If someone says, hey, I need permission to create the pod, can you revoke the permissions? This is admin work. Okay, so this config file is more relevant to the admin part. So now this user, as of now, we are having the Kubernetes admin user. So I will use same Kubernetes admin user. And this entirely, it is called context. Similar way, you can have multiple contexts for cluster 2, for another user. We can also create the user. Okay, so now next thing is that if we have multiple contexts, what is the purpose of that? So consider this is my context 1, this is my context 2, and so on. I want to work on this particular area. I want to work under the namespace, say default. If you don't mention the namespace, like here in this context, namespace is not mentioned. It is by default, default. So here, what I want to do, I want to work in the default namespace. So this context should be my current context. So whatever is the current context, that will be your default namespace. Because so here you can see current context, Kubernetes admin this. So this is the name of my context. This is the name of my context. Right. So this is the name of my context, and my current context is this one only. So that is why I'm in the default namespace. If I put a different namespace here, and if I say current context this one, so that will be my current namespace, and we will do that. Now, touching this file manually is very dangerous, because if you make any mistake, whether it is a syntax mistake or something, then it will be you are messing up your cluster. So that is why we use commands to handle this file. So those commands are basically those commands which we use. These are those commands are related to the kube config file. Let me see, my cluster is worker node 2 is up or not. Oh my God, something went wrong, drastically wrong. Okay, all right. So now it is. So if I say kubectl config command, so all the commands which are related to the configuration file are started with config. Okay. So if I say kubectl config, and if I say kubectl config and view, so it will list whatever the file we have seen. So you can see that file. It will not show that that data which is encoded data like certificate, or so it will simply say data plus omitted. Okay. Now I want to see all the context. So I will say kubectl config and get context. So it is showing this context, Kubernetes admin context. Now I want to see the current context. Current context is that if you are having multiple contexts, wherever this asterisk symbol is pointing to, so that is your current context. Okay. So now if I say kubectl and config and current context, so it will show you the current context. So this is my current context. So now, as I mentioned, context is the combination of user namespace and the cluster. So what I will do, I will create a context for my dev namespace. So I will say kubectl set context. I want to create a context And context name, I will say dev context. Okay, so this is my context name, or you can say dev hyphen context. And I want to use a cluster. So cluster name is I'm using because I'm only having one cluster user. As of now, I have only one user, which is this user. So I will use this one, and hyphen hyphen namespace, which is dev namespace. So I want to create a context for dev namespace. kubectl config. Right. So dev context is created. Now, if I say kubectl get context, so now you can see there are two contexts. One is for default namespace and second is dev. Currently, I'm in the default namespace because asterisk symbol is in front of this. Asterisk symbol is in front of this admin namespace. I want to switch from my admin namespace to dev namespace as the current namespace. So what I will do, I will say kubectl and config use context, and the context name is dev context. So now I am switched from my default namespace to dev context namespace. Okay. Now, if I say kubectl get pods, it should show my dev pod. Why? Because currently I am in the dev namespace. You can verify that kubectl describe pod dev pod. So here you can see that my namespace is dev names. So this is one. So this way you can switch from one namespace to another namespace. Do you have any question? All right. So now if I say kubectl get kubectl config get context. So it will show both the context. Now I want to delete. First, I need to switch to this context, and then I want to delete this dev context. So what I'll do here, I will say kubectl config and use context, which is this context. And now kubectl delete context, which is the dev context. Deleting context will not delete the namespace, right? And it will just delete the context. Oh my God. Right, so this is deleted. Now, if I say kubectl get context, so here you will see that it is having only the one context. Right. So this is how we are basically using the Kubernetes context or Kubernetes configuration file. Now, what is the use case for this? One use case is that if someone is connecting to your cluster, okay, so they need to have this configuration file. Otherwise, that user cannot connect that. Okay. So now, because let me do one thing. Let me go to my virtual machine, and here, what I will do, I will go to the network, and I will do a port forwarding Let me see if I can connect from here. So I will say 127.0.0.1 and host number 6443. Open to 6443. Right. We'll try with this. Actually, I want to open this right to everyone. Let me see whether I can CMD. And if I say telnet to, let me see the IP address. And the IP address is 192. Right. So 6443. I'm not able to connect. Okay, no worries. We will do it on worker node 1. So this needs little bit, settings looks like. So I need to see that one. Actually, it should telnet to 6443. But it is not happening. Let me just do one more thing here. If I go to my tools, networks, and here, this is the network, input network, port forwarding. Okay. I will say hostful. Oh, I don't know. Oh, actually, I was running wrongly. It should be localhost. Yeah, it is working. So now what I will do, I will take this configuration file. I will take this configuration file and I will do some modification, or I will create a new configuration file and I will put it into my local system. On my local system, kubectl is already installed. So if I say command prompt, and if I say kubectl something, right? So kubectl is installed. So from my local system, I will connect to my cluster. Consider on my local system, I'm a developer and I want to have limited access. Okay. So you as a admin, so there is a request comes that Raman is a new user and can you give him a limited access to a particular namespace? He should not access any other namespaces. So this is called role-based access. Okay. So to give the role-based access control, what I'll do, I need to follow certain steps. So let me just go to my notes. And here, if I say github.com, and here you can see Kubernetes storage manifest. Okay. Oh, I did not put those notes. No worries. I have another DevOps world.co.in. I will update my nodes. And this is Kubernetes. And under Kubernetes, role-based access control. And what I'm going to do here, I'm going to create a namespace called finance. I'm creating a namespace, but before that, you need to take a copy of your config file, because we are going to modify that one. So I'll take a copy of my under root.kube and config file, and I will just put it under the same path. I will call it original config. Okay, because I'm going to make a change into this configuration file. So what I will do, I will create a namespace called finance. You can double check kubectl get namespace. Finance namespace is created. Now, next one is that I want to, right. So next one is that I want to create the SSL certificate. See, whenever you are connecting to your system, so you should connect with some certificate, okay, or that certificate keys. So I will use this command, OpenSSL generate certificate. I will call a user as John user. So I'm creating this one. So there is a key get created, John.key. So you can see John.key is created. Right. Now I need to create a signing request. So where I'm saying that this John is, he belongs to Java development group. Okay, done. Then I need to create a public key, and which should have a certificate.crt and certificate.key. So CRT file is to be created, which includes this certificate authority, right? CRT and .key, and it is valid for that certificate is valid for 500 days. Done. Now, if you see ls, we are having this John.crt file. Right? Fine. Now, we need to create something called roles. Roles are nothing but these are the roles like permissions. I want to give on deployment, replica set, and pods permissions like get, list, watch, create, update, patch, delete. Right? So I'm creating a role by creating a file called role.yaml. So here I will say vi role.yaml file. Okay, this file was already there. Vi cluster role, I'll say. Okay. And let me see, is there anything else or here? So this file. So here what I'm saying, for deployment, for replica set, for pod, I'm giving get, list, watch, create these permissions. Okay. Now I will save this. Now I'll say kubectl and create -f c role.yaml file. Now I'll say I will create role binding where I will bind the user to this role, means that user have these permissions. So for that, I'm creating this. This is called role binding for in my finance namespace for user John, and it will be bound to the deployment manager, which is the role I have defined on the top. Okay, so I will copy this and I will say C role binding.yaml file. So I'll say kubectl create -f c role binding.yaml file. There is some error. Oh, API version is not here. This is the API version. So created, 2 roles get created. Now next is that I want to create a user, right? And the username is, I want to set the credential for John user, and I will say take these keys, okay? And we need to change this path. So I'm creating kubectl config, set credential for my John user, and the keys which we have created, john.crt and john.key, that I'm referring here, client certificate and client key. Okay, so let us do that. Done. Then I'm creating a context for the finance namespace for user John. Right? And I want to make this context as a current context. Done. I will delete the existing context, which is for the admin. Now, if I say kubectl config get context, so you can see there is only one context, right? If I say kubectl, actually there is a, if I say kubectl config and view, so still that user, admin user information is there. I want to delete this user also. So I will say kubectl config delete user and the username this. So I should have only John user. So I'm on worker 1. I'll say sudo su login with a root user. Right. What I will do, I will make a directory under root.kube. Okay, and then I will create a file under root.kube, and file name is config file. In that config file, right, I will copy this as it is. Okay, it is copying like this. Copy. Okay. Especially this certificate is not copied properly. Okay. So what I will do here, I'll say certificate authority data. And this one, oh, there is a gap also. Oh, that is the problem actually. Not this one looks like. So what I'll do, I will go to my master node. You have some time. I want to finish this.
Yeah, please go ahead.
Okay. .kube and config. Right. So somehow this is coming in multiple lines. It should be in single line. So because of that gap, I think now it is fine. Okay, so let me save this and try to connect. Here it is the problem still, but I will go to the worker 1 and I will paste it here. Okay, and the IP address is 192.168.0.5, and certificate I will put it under /tmp/this. Okay, so I just need to create these two files. Rest of the things should be fine. Let me save this. This is on worker one, right? So I will say vi/tmp and john.key. Okay, so here if I say cat john.key, so I will copy this data, paste it here, and john.crt. Right. Now let me from here, let me run kubectl get pods. That config file is not copied properly, looks like. This data especially. Uh-huh. Let me copy this way. All right, so what I did, I just copied this uh, certificate authority data, okay, and I just put it into my worker one. So here, if you see, when I use vi and config file, so I just copied that, right? And after that, it is started working. So no change, just copy paste, and I just put the temp files. Under temp file, I have put my john.key, john.crt. Let us see. Now, what I'm going to do here, I'll write a command, which is kubectl and get pods. So here you can see it is showing that no resource found in the finance namespace, because this user is only having the access to the finance namespace. Now, if I say kubectl get pods under the namespace, which is default, for example, so it will not allow to get the access to the default namespace. Okay, so that is what I wanted to show you, that how we can give a access, role-based access to the user. Okay, so we'll meet in the next lecture then. Thank you. Next topic will be the open this check. Okay, let's talk about the few things. One is let's talk about dashboard. Let me go here. And I can go to devopsworld.org.in. Okay. So there is a Kubernetes dashboard. What is Kubernetes dashboard? Means you can also access your Kubernetes through dashboard, which we very rarely do. Okay. But there is a concept. So there are some steps. If I go to Kubernetes dashboard, so if I go to the Kubernetes deploy and access the Kubernetes dashboard, okay. So here our dashboard will be something like this. So here you can see all the namespaces, what are the resources we are having, right? So everything we can see it here. So for that, okay, so they are using the Helm. Actually, I prefer to come to Kubernetes website to have this because actually they most of the time they change this URL. All right, so Helm we have not discussed so far. Maybe after discussion of Helm, we will see that. We will see some other. We'll see some other topic then. I think we haven't discussed about config map and secret. Did we discuss? I don't think so.
No, sir, we have not discussed that.
Okay. So let us talk about config map and secret then. All right. So let us talk about config map. So what is config map means? For example, you are having a Docker image. Okay. So you are having one Docker image. And that Docker image is having the set of instruction to create the infrastructure for you, right? For your containers or pod. Now, the thing is that when this infrastructure is created, you are having a configuration file. So configuration file is most of the time the applications have, whether you are having the web application or your desktop application, machine learning also, right? So whatever, right? So now you have created a Docker image, and in that Docker image, you consider this is a web application, okay? And you are having a configuration file, web.xml file, right? And in this web.xml file, you are having a uh, you are having a lot of properties. One of the property is the consider connection string, okay, where you are connecting to the database, right? Now you are having different environments. So my first environment is production environment, second is dev, and so on. Okay, so this is my production environment. This is my dev environment. Right? Now this production environment is connecting to a database. Right? It is connecting to a database, which is the production database. Right? So it is connecting to a database, which is my production database. This is my production database. Similarly, my dev environment, it is connecting to a different database, which is the development database. So two different environments, and they are having two different databases. Right. So this is connected. This is referring to this database. This is referring to this database. Okay. And both are running in the Kubernetes, and Kubernetes is using this Docker image. So this is using this Docker image, because we cannot say that there are two Docker images. If we are saying two Docker images, then what will happen? That it is you know it is out of the standard. Out of the standard means if a pod is running with a Docker image, its image should be same in all the environment, so that if you make a change in the Docker image, it should be applied to all the environment. Otherwise, you will say, means in my staging it is working, but production it is not working. So it means you are having a different Docker image. So thumb rule is that we need to have the same Docker image in all the environment. Now, if you use the same Docker image, it has a different connection string, which is connecting to this database. Its IP address is different. So it means when you create a pod on your production environment, then what will happen? Then it will be, then you need to make some changes manually or with some process, which is not a good idea, right? Creating multiple Docker images also out of the standard, and the manually changing these configuration file for database connection string, that is also not a good idea. So that is why Kubernetes introduced something called ConfigMap. Okay, so they have introduced ConfigMap. So now ConfigMap is somewhere here. Okay. Now, as the name suggests, configuration mapping. Okay. So what is config map? So config map is a key value pair. Key value pair storage. Right. So what does it mean? It means that if you want to store some value in the config map, it will be stored in the key and value. Okay. So now, for example, I want to store the DB connection string for production. So I will say DB for production. Okay. And here I will put the connection string for DB. Okay. For production. Okay. Same way, I want to have a connection string which is called DB connection string for staging or dev. Then we will have the connection string for dev, right? Now these two connection strings are where? In the config map. Now when this pod is running, in the pod I will say take the connection string from config map. So now I am not changing Docker image, but I store that value inside the config map. Same way, if this dev is running, I'm not changing the Docker image and I'm saying use this config map. So that is the purpose of the config map. Let us see here. So if I say kubectl and get config map, right? So here you can see there is one config map which automatically get created when you create your namespace. Okay, so in my namespace, which is default namespace, this is the config map get created. Let us understand the config map first. So that is the one which I have not created. It is automatically get created by the Kubernetes. Now I want to create my own config map. So I will say kubectl and create config map. The short form is CM. Okay, so kubectl get config map and config map name. I will say this is config map 1. Okay, and what I want to do, I want to store some values. So for example, if I say or what we will do, first we will create some file, okay, from web.xml kind of file. Complete file I want to give it to my config map. That is also possible, right? But you cannot give more than 1 MB data to the one config map. Okay, so if you give more than 1 MB, then it will not allow. And mostly our configuration files or parameter files, these are less than 1 MB. Right? It is in KBs mostly. So I'm creating a file which is I will say echo. I will call it as this is production configuration file, something. Okay, and I will store it into the production .xml file. Okay, or I will say web underscore production.xml file. Same way, I will create one more for dev. So I will say dev, and this is my dev configuration file. Okay, now I have these two files. So now I will create a kubectl create config map. Name of the config map, I will say config map 1. You can give any name. Okay, and I want from file. Which files? From file or files? I think from files. From file. I'll check that one. So I'll say take web underscore prod.xml file. Okay, and one more from file, which is web underscore dev xml. Yeah, from file. So now a config map get created named config map 1, and it is pointing to the web production.xml file or web dev.xml file. So now we can check kubectl get config map. So here you can see config map 1 is created and it is having two data. So what is two data? One data is from this file, one data is from this file. Now if you want to see that one, so if I say kubectl get or not get describe config map and config map 1. So here you can see I have config map 1, right? Namespace, it is in the default namespace, and this is web dev.xml, right? This is the key and this is the value. So web underscore dev.xml, which is the file name, it becomes the key and the content of the file becomes the value. Same way, web prod.xml, here this is the key, prod conf dot web prod.xml, this is the key, and prod conf file, this is the value, right? Now I have these two things. What I want to do, I want to create a pod for production. Okay, so what I will do now, you can write the code, or I think I already have that code. Let me go here. ConfigMap. ConfigMap. Actually, I'm creating this pod. So I will say vi and configmap pod.yaml file. Okay, so I'm creating this pod. I'm using volume because I want to store this file somewhere, right? So now what I have done here, I'm creating a config map, and the name of the config map I will say, name of the pod I will say config map pod for production. Okay, I want to create for production. Right now, container is this Docker image. I'm using this. I'm creating volume because volume I am using this because I want to store this value into my some place inside the pod, right? So I'm saying that I want to store it into some volume. So I'm using, so Kubernetes volumes are much advanced level. So what it can do, it can point to some resource like here in this case config map, and then it can extract that information and put it into some file. Okay, so for example, here you can see the volume name is test volume, which is pointing to config map, and the name of my config map is config map 1, right? So this is my config map 1, and what I want, web underscore, I'm creating pod for production. So I'll say web underscore prod.xml file. And I want that file is to be renamed with the pod web.xml file. Okay, because whether it is staging, whether it is other environment, so all are having the name as web.xml, right? So no. So that's why items, it will check this key and it will rename that path as web.xml. Where I want to mount, you can mount it here in the pod, and the name of the pod is test volume. And here, for example, I want to store somewhere, say, so in config map, we store the non-sensitive information. Non-sensitive information means that information which is not sensitive, means if I run the describe command, others can see it. Right? So here I want to store it into, say, my data directory, okay, somewhere, and it will be read only. Now what I'll do, I will save this. Let me see, is there any pod running? There is no pod. Now if I say kubectl and create -f and cm hyphen pod.here, pod get created. Let us see kubectl get pods. So you can see it is in the running state. Now if it is in the running state, then I will say kubectl describe pod cm pod and production, right? So here you can see volume, test volume, which is pointing to the config map, a volume populated by config map. Which volume? CM1 volume, right? And it is mounted to my data directory in the pod. So it means if I say kubectl and exec -it cm pod cm and pod, cm pod prod, and if I say --ls, will it work? Yes, it is working now, right? Now we need to see, we have created my data directory. So I'll say my data. So here you can see there is a web.xml file, right? Now this web.xml file should have production information. So now I'll say cat, and here I will say web.xml. So you can see this is so it means I have created a pod pointing to my correct configuration file, right, which is a production configuration file, and I make that file, I took that file from the config map from key value pair, and now it is my production pod. It is not picking up that development. Same way, if you want to create a development, then development pod. So what happens that I did not change the Docker image, I did not do anything manual. I just put my information which I want to use at runtime for my pod, like it's a production pod or if it is a development pod into the config map. Okay. Now, similar way, what we can do, we can also set up the environment variables. So if I create a kubectl and if I say run or create config map, say config map 2, okay, I want to create, and now here I want to use from literal. From literal means you are defining the value. For example, if I say environment equals to staging, okay, or you can say stage environment equals to staging, and production from literal production environment equals to production. Okay, so I have created these two environment variable for my config map. Now if it is created, now if I say kubectl and describe my config map, which is config map 2, so here you can see I have key, which is production environment, right, which is having value prod, and the staging environment, which is having value stage, right? Now what I will do here, kubectl, and I can use these environment variables for my pod environment variables, right? Means config map key and value pair I can use as environment variables into my pod. How you can create environment variable in the pod? Kubectl, you can use the run command and just check for the help. Now here you can see there is a help which is saying environment variables, right? So here you can see we can set the environment variable for the containers. So I will say kubectl run, and my pod name is say environment pod, right, with the image nginx, and I want to just create a YAML files. So I'll say it was --env, and I want to create environment, say something, say env equals to value, environment value, variable value, right? And I will say -dry run equals to client -o YAML, right? So here you can see environment is created, name is env I have created, and value is value. But I want that this thing should come from the this thing should come from my config map, right? So for that, you can use the, you know, what we call Visual Studio code. There it will help you to write the code, or I already have this. So I'll take this code. So we just need to know the environment prod env and the state env I have created. State env and prod env. So now I will say vi config map with the environment variable dot YAML file. Okay, so what I'll do, I'll just copy paste this here. Now what I will do here, I will give the name as config map pod env something, right? Using the Docker image, we'll use Nginx prod env value coming from the config map. Which config map? My config map, which is config map 2, and prod env. And here also I will say coming from config map 2 and state env. Let me save this. Now let me apply this. kubectl delete, create -f, right? And I will say and start my worker 2 also. -f cm env. Yeah. So this is created. Now if I say kubectl get pods, so there is a pod which is the env pod get created, okay, and it is in the running state. Now what I'll do here, I will go to kubectl and describe pod and the pod name. So here you can see now we are having the environment variable prod, which is pointing to the prod env, and stage, which is indicating to the stage env. So it means if I say kubectl and exec -it, and my pod name is cm pod env, right? And if I run the env command here, environment command, so my two environment variables are set, which takes the value from the production and the staging. Is it clear? So basically,
Yes, sir.
what I have done in the config map, I have defined key value pair, and those key value pair I have used as the environment variable inside the uh, inside the pod. Okay, so fine. Now this is config map. Now I would suggest you one thing, that once you go through this topic, go to this one, which is in the Kubernetes documentation, config map in Kubernetes. Right? So here, if you go to this documentation, right, so you will see one example, and that example is mixture of environment variable and the from file. So this is the example where a config map is getting created and a pod is created on the basis of that config map. So try this example. It will give you more, insights of the config map. And this is a complete example. All right. So do you have some time? Can we discuss secret? or you want it tomorrow?
So tomorrow we can do.
Tomorrow we can. Okay. All right.
So tomorrow can we do? Can we have a class in the evening?
Evening. Okay. Or we can skip tomorrow. That's fine also.
Okay, fine.
All right. So we'll skip.
Monday we'll connect.
Yeah. Sure. Thank you.
Bye, sir.
Bye.